Hello everyone, my name is Abhishek and welcome back to my channel. Welcome to the 10-hour long video that takes you from zero to hero of DevSecOps. Basically, if you're a DevOps engineer planning to transition to DevSecOps, or if you want to step up in your organization, this is the best video that you're looking for. The overall video has 7 different parts, starting with Introduction to DevSecOps, where you will learn what exactly is DevSecOps, and you will also be introduced to a tool which shows the current security state of your application. Then in episode 2 or the part 2, you will learn about DevSecOps for Git and GitHub. This is a very interesting part where you will learn how you can secure your Git, what are the best practices that you can follow locally, and even with respect to GitHub. Then in the third part, we will cover DevSecOps for Terraform. Again, how you can secure Terraform, how you can secure your state file, what security best practices you can take while writing the Terraform manifests. Then in part 4, we will cover security best practices for containers. One of my favorite things in the space of DevOps, because this is the part where you can completely mess up with the security. That is the containers. So I've taken a lot of care in making the part 4. You will master container security by watching that part. In the 5th part, I've covered security best practices for Kubernetes. Kubernetes is an ocean, so it's a little lengthy part, but I try to cover most of the things that you should know. Then in the 6th part, you will learn about SCA, SAST, and DAST, which are currently trending in the security space. And finally, once you're done with all this, you need a capstone project. That is exactly what the part 7 is. For a 3-tier architecture application with front end, back end, and a database, I'll show you how you can implement DevSecOps from zero to hero. The goal of this part, if you join an organization or even during your interviews, you should be able to explain how DevSecOps can implement it from absolute basics. And finally, implement through pipelines, through Kubernetes, through Docker, through Terraform, everything that is involved in the entire DevOps lifecycle. So this is what you're going to learn. Of course, you need notes for this entire thing. And I have covered the detailed notes because in every episode, we have demos included. Even you want to perform the demos. That's why you can find the GitHub repository for this in the description. And the Git repository is completely updated. You can just follow that at any point of the time if you need some manifest, if you need some configuration, or to implement the demo. Let's get started. So today is the very first episode of our DevSecOps Zero to Hero series. And in this video, we will focus on Introduction to DevSecOps. Towards the end of this video, you will learn how to generate a very detailed security report for your application. And this security report can be downloaded as a PDF and it contains all the vulnerabilities related to your application. The demo is going to be super exciting. Now, before we get started, just like any of our Zero to Hero series, even for this series, I created a GitHub repository. So after watching the video, you can head to the GitHub repository and follow the notes for the episode. Make sure you do it, especially when you want to implement the demo, because the notes is going to be very detailed and it will help you as a revision material. Perfect. Now let's get started. Because this is a very first episode, let's start with what is DevSecOps and why is it important? Unfortunately, this is one of the most misunderstood terms in the industry. A lot of people think DevSecOps is completely different from DevOps. In fact, some people think they are two different roles in the companies. Let me tell you, this is not true. DevSecOps is nothing but DevOps with security mindset. In a nutshell, DevOps engineers who think of security in every activity that they perform is basically a DevSecOps engineer. That's it. Now you might have a question. In that case, why DevSecOps, the term coined, and why it became popular. Simple reason. Previously, in the initial days of DevOps engineers focused on their activities like CI/CD, Kubernetes, infrastructure as code, but they did not focus a lot on the security while dealing with these tasks. Now, this created new challenges for the organizations. Organizations started seeing security issues with respect to their infra. Now, this is why organizations push DevOps engineers to think of security. And because of this emphasis, DevSecOps coined as a term. DevOps with security mindset. This is the backstory. End of the day, any DevOps engineer taking care of security, thinking of security while performing their role is a DevSecOps engineer. Now that this is clear, let's talk about the scope of DevSecOps. Again, a lot of people think DevSecOps is scoped to CI/CD. This is not true. I have personally seen companies who just added 2 to 3 stages to their CI/CD pipelines and call it as DevSecOps. But in fact, the scope of DevSecOps is very huge. We will do one thing. Let's list down common DevOps activities and let's see how a DevSecOps engineer can introduce security to those activities. We will start with Git. DevOps engineers spend a lot of time with Git. Infrastructure as code. Scripting. It can be through shell scripting. It can be through Python scripting to automate day-to-day activities. Containers. When dealing with microservices, DevOps engineers spend almost their entire day with containers, creating images, pushing the images, pulling the images, Kubernetes, and common activities like CI/CD. So these are some very popular activities. Let's go one by one. When a DevOps engineer is working with Git, you might ask, what is security aspect with respect to Git? The tasks are very common: to create a repo, to create a branch, to create a branching strategy. Where does security come into picture? Now, this is where a good DevSecOps engineer or DevOps engineer with security mindset would introduce things like pre-commit hooks. What exactly is this? Now, when working with Git, developers can accidentally push their PEM files. Developers can accidentally commit their files like encoded passwords. This can be eliminated if a DevSecOps engineer introduce something like pre-commit hook. Whenever a commit is created, whenever a commit is pushed, this pre-commit hook validates if there is any sensitive information. Only if there is no sensitive information, the commit is pushed to the Git. On top of that, a DevSecOps engineer can also introduce strict RBAC to Git, like ensuring only the right people can read the repo, only the right people can make changes to the repo and administrate the repo. Let's talk about IAC. Now, on day-to-day basis, DevOps engineers work with IAC tools like Terraform. And while using Terraform, they create infrastructure on the cloud provider. Now, a DevSecOps engineer or DevOps engineer with security mindset, whenever they install platforms like Terraform, they would set up secret management solutions like Vault, so that any sensitive information in Terraform, like cloud provider credentials, can be stored to Vault. Even PEM files or secret files, they can also be stored in the Vault secret management. Scripting. Now, this is where things get interesting. Lot of DevOps engineers, they don't care of security while writing the scripts. Let's take example of Python. Now, you might ask, what to do with Python? A good DevSecOps engineer would not randomly use any version of the Python packages. If they want to use Flask, instead of using the Flask version suggested by ChatGPT or flash version that is available on the internet, DevSecOps engineer would look at no vulnerabilities Python package. Let's say there are two versions of Python Flask, 2.3.5, 2.3.6. ChatGPT recommends this version, but DevSecOps engineer goes to the vulnerability database, or these days, companies also have their checklist. Companies also provide the list of packages that employees can use. So they would go there, see that, okay, this is a vulnerable version. So let me use 2.3.6. Containers. There is so much to do with respect to container security. As simple as while writing a Docker file, a DevSecOps engineer would not run the container with a root user. So in the Docker file, they would not use root user. A good DevSecOps engineer would go with Distroless images. A good DevSecOps engineer would go with multi-stage builds so that the build size is small and even the end package or the end container has less number of packages. Kubernetes. Let's take one example here. A normal DevOps engineer would set up Kubernetes cluster. They would go for EKS and maybe set up the cluster. But a DevSecOps engineer would first set up virtual private cloud, then set up private subnet, and within that, they would set up the Kubernetes cluster so that the nodes of the Kubernetes cluster and entire Kubernetes cluster is secure. On top of that, they would set up secrets management solution in Kubernetes and other best practices. CI/CD, this is where a lot of people start their journey with DevSecOps. That is unfortunate. They should not do it. But yeah, anyways, people start with DevSecOps in CI/CD. So it's very popular. They would introduce stages here, right? Multiple stages like static code analysis, stages like SAST, stages like container security, using platforms like Trivi, platforms like Snyk, or even Docker today supports a lot of security related to containers. So this way, the scope of DevSecOps is not limited to CI/CD, but every activity that DevOps engineer performs. Now you might have seen me interchanging the term. Sometimes I must be calling DevOps, sometimes I might be calling DevSecOps. To be honest, I don't see the difference. I personally feel every DevOps engineer should be a DevSecOps engineer. Every DevOps engineer should think of security right from the point they start the project. This is what DevSecOps also says. One of the fundamental principles of DevSecOps is shift left principle. What is shift left? Every organization has 2 points, the left point and the right point. Left point is where the application development starts, and right point is where application is deployed to the production. Earlier, in the previous days, this is where security was considered. Once the application is deployed to production, DevOps engineers used to think of the security. Maybe if the application is deployed to Kubernetes, at this point, DevOps engineers used to think of API gateway. At this point, they used to think of securing the Kubernetes cluster or adding any best practices to Kubernetes. The shift left principle says, just like how application development starts at the left point, just like how DevOps engineers start creating infra at the beginning of the project, just like how they create Git repository at the beginning of the project, how they create Kubernetes cluster here, in the same way, they should also think about security at the left. So this is called shield right approach, the very wrong approach which was used in the past. This is called as shift left approach. By shifting security to the left, organizations can benefit. Very, very simple, right? When companies create Kubernetes cluster, at the point, they have to create a secure cluster. When they install Terraform, they should install Terraform with Vault. when they create GitHub repository, they should create pre-commit hooks while they create the repo. This is the shift left principle. Now, while we talk about all of this, some of you might have this question, Abhishek, do I really need to upskill in 2026? Because people keep saying in 2026, AI will take over all the jobs. So what's the point of learning DevSecOps? Let me tell you, DevSecOps is one skill that has reverse effect on AI. That means as AI keeps scaling, as companies start using more and more AI, DevSecOps adoption will only keep increasing. Why? Today, AI is writing most of the code. If you look at companies, in majority of the companies, 60% code is written by AI, the latest code, and 40% code is written by the developers. In some companies, 80% code is written by the AI itself, like ChatGPT or any inbuilt models that are supported by the organizations. Now, what happens with AI? Of course, it writes the best code, but a lot of times it uses outdated packages. Lot of times it uses a package that is not supported by your company or which is against the compliance of your company. A lot of times AI copies the code from other sources, like it is inspired by the code that is in Stack Overflow, or it is inspired by the code that is in the Reddit, and it might provide you the code that is working, but a buggy code, a code that has lot of vulnerabilities. Now, how will you overcome this situation? You might say, but Abhishek, developers are still in the loop. Developers are still reviewing the code that is written by AI. Yes, they are doing it, but developers mostly review the code to see if the code is working. They test the code locally, they see the flow of the code. They might not look at outdated packages, they might not see the complaints, or they might oversee the buggy code. This can be eliminated by DevSecOps. What organizations can do, they can counter the bugs introduced by AI by building strong DevSecOps pipelines. One easy use case, strong CI/CD pipelines, which can potentially look at all of these bugs. Tools in the CI/CD pipelines, something like, we learned about Quiet in the past. There is a video on the channel. Quiet is something that can identify AI related issues. If possible, we will look at Quiet even in this series as well. Or maybe use tools like Snyk. Use container security platforms like Trivi. It can tell you during the runtime if your organization will be impacted by any outdated package. It will scan the vulnerability database and it will tell you any issues with the packages. So this way, DevSecOps has a counter effect on the AI or anti effect on the AI. Okay, we learned about the what, the why, and the good and bad of DevSecOps. Now let's see how to start with DevSecOps. Okay, Abhishek. Now I will learn DevSecOps, but once I join the company, how it would look like? What would be my first step? There are two possibilities here. The first possibility, you would work in a company which is a startup, and let's say they don't have any DevOps culture there. The other possibility, you would go to a company which is a legacy company, and in the legacy company, they have the DevOps workflows in place. And mostly they will be reluctant in following any new practices. Legacy companies, they have DevOps practices. Sometimes they have security issues in the practices, but still, if it is working, they would be hesitant in upgrading the practices, especially MNCs. So this is one possibility, and this is the other possibility. If this is the possibility, you are lucky enough because you will start the DevOps in the company and you will take care of all the best security practices. But what if you will go to a company with all the legacy pipelines, all the legacy DevOps tools, and it might have some buggy code as well as buggy infrastructure. How will you convince your company to onboard DevSecOps practices? So this is where you have to implement threat modeling. Now I'll show you how to use threat modeling and how to generate a security report for your existing infrastructure as well as your applications. So that way you can share this PDF with your management. You can share this PDF with your development team and you can set up a meeting and discuss the existing infrastructure might lead us to potential issues. So let's onboard DevSecOps practices. What is threat modeling? No, it's a process where you identify the issues. It's a process where you analyze the issue and potentially you also mitigate the issues, right? That is what we will see now. So for that, there are good number of tools in the market, but most of the tools are commercial licensed. What we will do in this lecture, we will go with OWASP Threat Detector or OWASP Threat Dragon. So OWASP Threat Dragon is completely open source. You can do your proof of concept. What you can do, you can paste your or you can draw your architecture diagram of your infrastructure within Threat Dragon and it will show you all the possible issues. It will give you a PDF report with all the bugs that are related to your infrastructure, typically vulnerabilities. It's going to be super interesting. What you have to do, you have to first download this. So go to OWASP Threat Dragon, click on the download installers button and install Threat Dragon on your laptop. Now I already have it. I used it in the past. So I'll search for Threat Dragon. There you go. So this is the Threat Dragon interface. Now let's start with creating our architecture diagram. Let's go with create a new empty threat model. I'll do it from the scratch. Let's do it for a simple two-tier web application. Two-tier web app. Owner Abhishek, reviewer is Veeramalla. I leave these options default and I will provide a diagram. So click on add a new diagram, save the record. A JSON file will be saved to your local machine. Just save it. Okay. Close this and you will have an option to draw the diagram. Don't worry, you don't have to be good at drawing the diagram. You just have to explain the Threat Dragon, how your application flow looks like. It will take care of everything. So let's say we have a simple two-tier architecture, right? Where we have a web application and that web application connects to the database. So your company, what did they do? So every time a user, so I change the property here, scroll down, you can also do it. So actor, I said a user does not provide any authentication and this user talks to a web application. Okay, so I'll take there are only few components here. One is the process component, actor component, the data stores component and data flow component. That's it. Using these four components, you can draw any architecture diagram. Now process, again, I'll change the property. I'll call this as a web application. There is an option for web application. Tick this. It will ask you a few questions. What is the privilege level? Let's leave it default. Is this web application related to card payment? Leave it default. Goods and services? Leave it default. Okay. Finally, a database. For that, I will take the store option and put that here. Again, I'll change the property. So I'll call this as MongoDB. Okay, let's say my web application talks to MongoDB and it stores the inventory. There are a few questions here. Does it store any credentials? Let's say yes. Is it encrypted database? Let's say no. Does it store a log? Let's say no. That's all. We will provide this piece of information and we will say these components are connected. How? Let's take the data flow, connect user to the web application, connect web application to the database. And then let's say using this trust boundary that user is on the internet. So there is a boundary between user and the web application. Okay, so user is from the internet and these things are within the internal network. Of course, I did not put them in the same network, but it's fine. For our simple diagram, user is on the internet, web application talks to the MongoDB. Now you might say, Abhishek, everything is looking fine. What is the issue with this architecture? Let's see what OWASP Threat Dragon says. Save this. Okay, now just scroll down. Once you save it, just scroll down, select the particular component. Okay, I'll just close it, open it again. I'll select MongoDB component and click on new thread by context. There you go. So it says there is information disclosure vulnerability on your database because you did not detect any fake or compromised accounts. You did not ensure information is accessible only with authentication and authorization. It's true. In the architecture diagram, my web application is connecting to MongoDB. I did not provide any authentication, or the architecture diagram does not say there is any authentication that is set up. Okay, let's see what are the other vulnerabilities. This is one. I applied it. It says there is another vulnerability, elevation of privileges. There is another vulnerability for information disclosure where you did not stop any denial of service attack. Now there can be n number of attacks on the database. Further, and further. So you can see there are 8 different bugs that are identified on my database. Instantly on the architecture diagram, MongoDB became red. Now these are not ordinary bugs. Like you might say, Abhishek, these are some random bugs that are generated by Threat Dragon. My organization would ask for the explanation. That's good. Just go to any of this. Like if you go to scraping, so you can see this is OWASP automated threat 11. What does it say? If you go to the internet and if you search for OWASP automated threat 11, there is a complete information. You can share this information with your developer. You can share this information with your security expert, anyone who asks. Just share them. This is the definition of the vulnerability. This is the description. And this is how we can mitigate the issue. That's all. Similarly, for all the tools, enough information is provided. Let's go back to Threat Dragon. You can see all the 8 threads here. And you can work as a team. Once you all agree, like let's say your development and you agree that, okay, this is not a potential threat for us, you can open it and you can change this as mitigated. Change this to mitigated, say the severity as low, and if you want, you can delete it, or if you want, you can just apply it. So you can see this is changed to green, just like Jira. You can work as a team. So over the next few weeks, you can complete all the other issues as well. Now, not only on database, you can see some issues on the web application as well. So if you click on web app, click on new thread by context, you can see there is tampering issue on the web application. There is information disclosure issue, elevation of privileges issue. Again, another information disclosure issue. 4 vulnerabilities on the web application as well. That's why web app also turned to red. But Abhishek, how will I share all this information to my team? Right now, they don't have access to Threat Dragon on my local machine. Don't worry. Save this, close, and you can extract the report as well. Once you click on the report, you can see the detailed report, a PDF file that is generated by Threat Dragon. It says, okay, overall, there are 12 threats on your application. One threat is mitigated, which we closed. You have 0 critical vulnerabilities, but you have to be decided severity. That is, you have to work with your development team to decide the criticality. This is the architecture diagram that you provided. These are the vulnerabilities on the web application. These are the vulnerabilities on the MongoDB database. A complete security report is provided. Perfect. Now, what about dealing with more complex applications? You can deal with any complex application. In fact, what Threat Dragon does the best, it provides you some sample threat models. If you want to learn how to draw the architecture diagram, if you want to see how detailed the report is going to be, just go to the examples. Let's use one. So we have here online game. Click on it. You can see a complex online game. Okay, I'll just decrease the size here. This is the complete architecture. So you have the player's local station, you have the production network and the corporate network. A well-defined architecture diagram. Usually this looks like everything is perfect. But again, if you go to the player's database, you can see OWASP Threat Dragon says there are multiple issues with this architecture. One issue, second, third, 3 issues on the player database. Similarly, on the stats database, again, there are some issues. Now, it does not confirm these issues are not mitigated by your company, but it says, at least by the architecture diagram, you did not solve these issues. If you think you solved it outside the architecture, you solved it within your source code, just come here and close the bug, mitigate the issue. And once everything is done, save this. You can save it and you can generate a detailed report. Right? Again, the same way, you can see the architecture diagram and you can see the bugs. Because I did not save the bugs, right now it says there are no issues. Otherwise, just save all the bugs. You can get the detailed report as well. So this is about threat modeling. One thing which might be too early at this point of time, but just to tell you, in threat modeling, there are different frameworks that can be used. OWASP Threat Dragon use a framework called STRIDE, STRIDE. So this is a framework that is created by Microsoft, and internally, Threat Dragon uses this framework basically to identify issues on your architecture. I hope you learned something exciting today. You not only learned about the fundamentals of DevSecOps, but you also learned how to threat model your infrastructure and application. Go ahead, try it with your application, try it within your organization, and build a good DevSecOps culture. See you all in the next video. Take care. Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 2 of DevSecOps Zero to Hero series, and in this episode, we will focus on DevSecOps for Git. Just a backstory. In the first episode, we focused on Introduction to DevSecOps, where we learned what is it, why is it used, and most importantly, what is the scope of DevSecOps. And while learning the scope, we learned that DevSecOps is not only for CI/CD, but it is for every single activity that DevOps engineer performs. Now, one of the most common activities is Git. That's why in today's lecture, we will focus on securing Git. Now, you might think, but Git is just a utility. Git is just to store source code. So what's in DevSecOps for Git? Let me tell you, this is very, very important. And there is a lot to do when it comes to securing Git. In today's video, we will focus on 10 most common ways in which enterprises secure Git, or the best DevSecOps instance secure their Git repos. We will start with .git ignore, one of the most easiest ways and the first things that you can do. Then we will learn about pre-commit hooks. An interesting thing, but something that you should also implement in your organization. We will first learn pre-commit hooks using a custom script. Then we will go a step ahead and we will learn how to implement pre-commit hooks using a common utility. Then we will focus on repository scanning. So a lot of times existing repos in your organization, they might also have secrets or sensitive information. We will perform scanning on the repositories using Git leaks. Not only the latest commit, but also the commits that are made maybe 3 months, even 6 months before. Then we will learn how to integrate Git leaks into GitHub Actions, Git leaks into CI/CD, so that even through pull requests, accidentally as well, users cannot commit secrets to the repo. After all this, we will switch the gears and we will move towards RBAC. We will learn branch protection rules, how you can secure your main branch and other important branches in the repo. Of course, we will talk about RBAC itself, how you can grant different roles in the Git repository. Easy one. Then we will learn about mandatory reviews, something that not a lot of people talk about, but in many companies, you want certain engineers or certain AI agents to review every single PR on the Git repo. How do you achieve that? You can achieve that using mandatory reviews. We'll also talk about. Then we will learn about code owners file, something that is becoming a standard these days, followed by open source repositories from a long time. And these days, enterprises also started adopting it. Finally, we will learn about depend-abort. So depend-abort is again a popular thing which can auto fix the security issues on the repo. So these are 10 things that we are going to learn in this lecture. Now you don't have to be overwhelmed because we will go topic by topic, and for most of the topics here, we will also perform the demos. After watching the video, just spend 15 more minutes and go through the README file that I created. I created this README file with every step that I'm going to execute and every script that I'm going to use, so that you not only watch the video, but also get the practical hands-on experience. It's a free README file. It's in the same repository in the day 2 folder. Perfect. Now that the context is clear, let's start with .git ignore. As I told you, a very simple security thing that you can implement for your repos. Let's understand this with an example. Imagine there is an organization and this organization has a microservice. And this service is within their Git repository. So obviously, the source code of the service is within the repo. Now developers working on this repo, they clone the source code and they work on the local changes. Let's say one of the developer is working on this repo and this developer is basically working on database changes. So developer made some changes to the Python scripts that updates the database, and developer created a .env file or updated a existing .env file on the developer's local machine with DB password. So developer made the changes, developer tested the changes, everything is fine. Now what this developer did accidentally, along with the Python script, along with the DB changes, also committed the .env file. Now this becomes P0 issue for your organization, the most critical issue for your org, because a secret, especially the database password is committed to the Git repo. Why is it critical issue? Because Git never forgets things. Git is a version control system. Even if you revert the commit, you can perform Git revert. By the time you perform Git revert, you never know. A lot of other people must have cloned the repo. If it's an open source repository, some people must have even forked the repository. So they must have created a private or public copy of the repo. You don't know. So you can perform revert. You can use some uh, repo cleaners. You can use some external scripts. Even you can get in touch with GitHub support. You cannot do anything because the password is already shared with others. Only thing that you can do is change the database password. You never know what are the implications of it. So what I'm trying to say here, instead of all this, you should avoid the situation. Instead of talking to the GitHub support, reverting the commits, failing to do it, checking who cloned it, why not prevent something of this sort? So the first step to do it, or the easiest thing to do it, is to use the git ignore file. I should say .git ignore file. Now what does this thing do? Very simple. .git ignore file tells Git, hey Git, I will provide you with list of files that you should not track. The default behavior of Git is to track the files, right? What does Git do? It will track every single file in your repo or on your local machine. But this is a special file which tells Git, hey, don't track the files that I have with me. So the DevSecOps engineer will create a .git ignore file, and within the .git ignore file, DevSecOps engineer will make entries of the files that should not be tracked by Git. For example, .env, PEM file, or if working on Terraform, TF state file, maybe IDRSA file. This way, a good DevSecOps engineer will list down even 100 common files that should not be committed to Git. I'm not joking. To make it clear to you, if you look at our DevSecOps 0 to hero repo, I have a real-time .git ignore file that enterprises use. Look at the .git ignore, you will find a lot of entries. Now, of course, I exaggerated this file. I added things that not a lot of organizations would have. For example, I added Python related files and NPM related files as well. Maybe organizations would only have Python or NPM. But what I'm trying to tell you here, a good DevSecOps engineer should dish down every single possibility. So in this file, I added .env as well. Now, if someone is working on this repo, imagine this is the actual repo where developer is working on. Even if developer tries to commit .env file intentionally, Git would not do it. Let's see that. We will see this practically. So what I'll do, I'll first clone this repo. Git clone followed by the repository URL. Here we go. I'll switch the directory. DevSecOps 0 to hero. Nice. And here, intentionally, I will create a .env file, and within this, I will store a db password. db password is equals to Veeramalla. Okay. Now I will add git to track it. Let's see. Git add .env. Okay. What does it say? The following paths are ignored by one of your .git ignore file. So Git is saying, hey, I cannot do this because there is a .git ignore file here, the one I'm talking about, and this got ignore file told me that I should be ignoring .env. But Abhishek, what happens if I try to commit it or ask Git to track it with other files. For example, I will create a testing.py, and here, let's say I will add a simple thing that print, my bad, print hello. Okay, can we fool Git by pushing both these files together? So what if I do git add ---- all? Will Git be fooled? Let's see. If you do this, now what Git does, it did not throw you this error, the error that you were seeing earlier, but if you do git status, Git is only tracking testing.py. It did not throw the error, but it did not get fooled as well. It said, I will still stick to the .gitignore file. So this way, DevSecOps engineers can take the first step in the organization. Introduce .gitignore. Now introducing is very simple. You can take inspiration from this file, or you can talk to your developers, you can talk to your QA team, list down all the files that you want to avoid, create .gitignore, the same file, the name has to be same. Create this file. Now you might have only 5 entries in it. Save the file and do git add .gitignore, and most importantly, you have to push this file to the repo. Why? So that next time other developers clone this repo, they will also have .gitignore on their local machine. So you don't have to go to every single developer and tell them, hey, please take this file and keep it in the, or have it in the same folder of your Git repo. You don't have to tell everyone, just commit that file to the repo. It's a best practice that you can do. So this is about our first section, that is .gitignore. Now let's move to the next one, pre-commit hook. The reason for learning this concept is simple. Now .gitignore, although it is a good concept, if you observe carefully, here you are responsible for providing the list of files. Okay, so in the .gitignore, you provided that, okay, don't track .env, don't track pem file, don't track xyz file. But what if secret is in the Python file itself? You never know. There can be a junior developer who is working on a .py file. This time the developer did not create .env, but because a junior developer hard coded the password within the Python file itself. Now, added something called secret, and that secret is still in the Python file. It's added, it's committed. Or there is a junior DevOps engineer working on Terraform related files, that is the .tf files, and in the .tf files, the junior DevOps engineer hard-coded AWS secret and forgot to revoke it. Tested, forgot to revoke it. Now, in this case, .gitignore can't help you, because in the .gitignore, you cannot say .py, star.py. Okay, ignore every Python file. You cannot say it. Or you cannot say star.tf, ignore every Terraform file, because that's not possible. These are the files that should be in your Git repo. What will you do in this case? In this case, as a DevSecOps engineer, you have to introduce pre-commit hooks. So .gitignore is for known files. Pre-commit hook is for patterns. Okay, here you will rely on the pattern, not on the files. So within the patterns, you will write a custom script, maybe a shell script, and you will say, look for secret in all the files that developer is committing. Look for tokens in all the files that developer is committing. Look for password in all the files that developer is committing. Even if developer has 100 files, this script will look for the patterns in 100 files, and if the pattern is matching, the script, the pre-commit hook, will block the commit. I'll show you in practice, right? It's very easy to understand if we demo this. So this time, what we will do is we will add a pre-commit hook to the .git. Where will be pre-commit hook added? It will be added to the .git. So if you go to cd.git, here you will find a folder called hooks, and in the hooks folder, you have to create something like pre-commit. So you can call it pre-commit.sh. Even if you don't call pre-commit.sh, Git understands by default it's a shell script. So what you do here, you write a shell script, something like this. Again, don't worry, the script is in our GitHub repo. I'll walk you through the script. Okay, shebang /bin/bash, the starting point of the shell script. Echo, running a native pre-commit hook. This is something that I added. And here, I am looking into the git diff. So every time developer runs git commit, git diff is performed, and on the git diff, I am looking for the secret keyword. If there is a secret keyword, instantly I am saying secret detected, block the commit. If there is no secret, okay, go ahead and pass it. I don't have any problem. That's what pre-commit hook says. Now I'll show you this in action. First of all, I'll save this chmod +x pre-commit. You have to do it because it's a shell script. Go back. Perfect. Now I'm on the root of the repository. Now I'll do one simple thing. I will create a text file. Okay. So this is a text file I'm creating. And this text file has something called secret. Just like a Python file, I created a text file and it has cat test.txt. Okay. So you can see it has a keyword called secret. Now I'll do git add test.txt. Let's say developer did it and developer tried to commit it. Git commit -am test commit. Okay. Now if what we learned is right, this commit should be blocked. Enter. There you go. Secret detected, commit is blocked. Now what does a developer do? Very simple. Okay, developer understood. Oh, I did a blunder. Let me just fix it. So developer goes to test.txt. Okay. Developer removes this line. Developer will have other lines of the file. And now if developer tries to commit test.txt followed by git commit command, this will go through. This is the purpose of pre-commit hooks. Once again, very simple difference. .git ignore that we learned is working on the files that will avoid committing of secure files to the Git repository, files that are sensitive like .env or Terraform files. Whereas pre-commit hook, as the name suggests, it's a hook that you are writing. It's a script that you are writing that will see for a particular pattern. In our case, I looked for the secret pattern. Now you might say, but Abhishek, what if, instead of a single thing, right? Here you are looking for a secret pattern. What if developer commits token? Or what if developer commits DB password? What if developer commits something like, let's say, API keys or Terraform related AWS credentials? How do you prevent that? I'm good at writing shell script, but I cannot handle so many conditions in the shell script. Going back, so in the .git, in the hooks, in the pre-commit hyphen, okay, here I just handled one condition that is secret, grep -i. What if I have to look for token as well? Then you have to write another if condition. What if you have to look for DB password? You have to write another if condition, or you have to enhance this. This way, you don't know what are the common patterns. Or maybe you are not good at writing the shell script itself. You are a DevOps engineer, but you don't know how to write good scripts. Don't worry. Even in this case, there is something which is pre-commit framework. So if you go to the pre-commit website, so this is a framework. what this framework does, it uses something called Git leaks, right? Git leaks, and using Git leaks, it will help you. You don't have to write the script. Now I'll show you that. Okay, same thing what we learned, but this time without writing a script. So first of all, I will delete the script that I wrote, rm-r.git followed by hooks followed by pre-commit. Okay, I deleted the shell script that I wrote. Now, the first thing that you have to do is to install the pre-commit framework. If you are on a Linux machine, just run pip install pre-commit. If you are on Windows, you can go ahead and try it, but most likely it is recommended to use a Linux environment. Go for something like WSL, because a lot of times these framework won't work on your Windows machine. Anyways, you can give it a try, but in your organization, you will work on a Linux environment, so you don't have to worry. Okay, so pip install pre-commit. I am on my Mac. I will run brew install pre-commit. Okay, so the framework is installed. I have the framework ready. Now all that I have to do is I have to just add. It's in our Git repository. Go to the README file. So you have to add a pre-commit YAML file. So just add this pre-commit YAML file. Create this vim .precommit config.yaml, and within this add these 4 lines. As I told you, this is using Git leaks internally. What is Git leaks? Git leaks is a open source project, so it's a free project that anyone can use. Pre-commit is calling this Git leaks, and Git leaks is doing the job for you. This is basically handling the script that you wrote in the previous case, but in a much better way. And one more advantage of Git leaks is that it can work on all the repositories that you have. You don't have to go to every single .git. You can just use the pre-commit framework and use this configuration file for all the repositories that you have, just to pre-commit install. Okay, I will run pre-commit install, and it says, okay, I created .git hooks pre-commit file for you. What we did in the previous case, we wrote this. Now what pre-commit hook did? It wrote this script for us, or the pre-commit framework wrote this script for us. Now let's verify. I will create a secrets.env file. Okay, where in the secrets.env, I am adding AWS secret access key. I will add this git add secrets.env, and I will try to commit this. Git commit adding some secrets. Let's see what happens now. Initializing the environment, you can see it. It called the Git leaks. It is verifying. This will do on every commit. Sometimes it might take time. You have to be patient. But for security, I think you can do it. There you go. So it says, hey, I'm blocking your commit because you added AWS secret access key. And this secret access key is added to the secrets.env file. So it is saying what is the secret, and it is also saying the file in which you added the secret. Again, what a good developer would do. Oh, I accidentally committed the AWS access key to the secrets.env. Let me go ahead and delete it. So both the Git leaks and your custom script is doing the same thing. But in this case, you are writing the script, whereas with pre-commit framework, you are not writing the script. And it can handle the things in much better way. It provides you the information, it provides you the name of the file, and it can also identify not only regular patterns, but different patterns that are vulnerable. So we learned about .git ignore, we learned about pre-commit script, and we learned about pre-commit framework. Now let's see how to scan repositories. Now we are slightly switching the gear. What if you joined as a DevSecOps engineer and you want to see, Abhishek, I have this repository from 3 years. I want to see 2 years ago if anyone committed a secret to this. Because right now, if I look at these files, all these files are okay. There is no sensitive information in it. But what if I go to the commits? I go to commit that is 1 year ago. And in this commit, developer made a secret or committed a secret. Now, because this is Git never forgets things. A hacker can look at all your commits. A hacker can look at all the files in the repo, history along with the latest. And if the hacker finds the secret, then that's it. Some developer might accidentally committed a secret. Developer realized it. Just to be safe, developer immediately reverted it and developer thought it's all fine. Hey, I did a mistake and I covered the mistake. But no, Git does not allow you to do that. As a DevSecOps engineer, it is a good thing to scan the repos. Once in a while, perform the scanning. How will you do it? What you can do is you can use the same Git leaks. Git leaks detect -v, or you can just run git leaks detect. That's it. One single command. And you can see it scanned all the 11 commits and it says one leak found. Now this is because we have added the secrets.env and that is actually detecting from there. But anyways, what git leaks detect does, it scans all the 11 commits and it gets the information to see if in any of these previous 11 commits, if a developer committed a secret. So this is what you need to do as a DevSecOps engineer. Plan it as, once in 2 months activity or once in 3 months activity. You can also run it as a cron job. Just clone all the repositories. If you have 10 repositories, clone all the 10 repositories and run git leaks detect. Perfect. Now, okay, Abhishek, this is all on the local. Okay. Now, a developer might follow the instructions. Some developers might not follow. Even if I share .gitignore file, okay, some developer might not add it. A developer is new, they might ignore. Or I will share the pre-commit framework, but developer might not install the framework. What can I do? I still want to secure my repository. Now, the only possibility that you have is to create a CI/CD and make sure every time CI/CD runs on the repo. So I'll do that now. Basically, on this repo, let's create a new file that is the CI/CD file. How to do that? Add a new file, .github. Now this is in your control as DevSecOps engineer. Workflows, and here add a workflow, something like this. Okay, there you go. So the name of the workflow is git leaks. It runs on every pull request. It runs on the push request, even on the workflow dispatch. And this is the job. Now don't think I'm writing this. This is copied from the git leaks documentation itself. I haven't written even a single line of code here. I just copied it from official git leaks documentation. And anyone would do the same because I don't know this action. I have to get this action from git leaks documentation. I just copied the entire thing. And when you do secrets.github token, you don't have to provide the token. By default, GitHub Actions, it has the default token. It will use the default token. Now let's see how this works. Okay, I will commit this change. Now, imagine your developers did not add anything and they try to push a password to the main, or they try to push the same AWS secret file. Whatever we used, they try to push the same thing to the repository, secrets.env. Let's see what happens. I will create a branch. Okay, so let's do that. Create a new branch. Let's call this as test branch. From the main branch, I'm creating the test branch, and in the test branch, I am adding this file. I'll call this as secrets.env. Okay, and in the secrets.env, I am adding the same sensitive information. Echo or AWS secret access key. Perfect. Now I will commit this file. This should go. I'm committing this to the test branch. Ideally, I should not do it, but just to show you, I'm implementing this. Now, from the test branch, I will create a pull request to the main branch. Let's see what happens. Okay, we will create. Now on this pull request, what will run? The GitHub actions. The GitHub actions for the Git leaks workflow. Okay, we will create the pull request. Instantly, the Git leaks workflow should run. Okay, my bad. I did a very simple mistake. So here I directly added a workflow file. What I should be doing, I should create a folder, right? The folder name should be workflows. My bad. So workflows, and within this, let's add something like gitleaks.yaml. Okay, so I missed that. Anyways, commit. Perfect. Okay, now let's see. We'll go back to our pull request. This is our pull request. Okay, so because the pull request is already open, what we will do, we will simply close the PR and create a new one. Okay, close the pull request, and this time go back, new pull request from test to main, ability to merge. Okay, create pull request. Okay, now the git leaks pull request check is working, and you can see here the check clearly failed. Let's see the reason why. Run git leaks and it says leaks detected. Perfect. So this is in your hands. So that's why, although you recommend .git ignore file, you can recommend the common patterns, you can recommend the pre-commit hook, but as a DevSecOps engineer, make sure you add this CI/CD as well to your repositories so that you are 100% sure that even if someone tries to break the rules, even if a developer is willingly or unknowingly trying to push a secret, it can be through pull request, it can be through commit, it is blocked by your CI/CD workflow. So now we are done with the first 5 concepts. So we learned about .git ignore, pre-commit hook, git leaks, we learned about repository scanning, and we also learned how to integrate git leaks into GitHub actions. Now let's learn about branch protection rules. Very simple. So branch protection rules, you must have seen whenever you're working on the main branch. You must have seen the main branch sometimes throwing up a pop-up that your main branch is not protected. The reason is simple. So you can automatically push changes to the main branch, which should not be the case in the enterprise. For example, if you notice, I was running git push and I was pushing the changes directly to the main branch. For example, I created a lot of files here, the abc.py, text.txt, test.py, and I directly push them without any pull request, which is a bad practice. No developer, no DevOps engineer should be able to do that. On the main branch, a pull request should be created, and that pull request should always be reviewed by the fellow engineers. The review process is mandatory. Now to do that, you need to protect the main branch. How do you do that? Go to the settings, and in the settings, head to branches, and here just add a new branch rule set. It's very, very simple. Add the branch rule set, call it as branch protection, for example. Here you can enforce the branch protection status. So if you make it active, that means most of the branches will stick to the branch protection. All that you have to do in the target branch, provide the name of the branch. So you can say the default branch, which becomes the main branch. Along with that, you can also include branches with the patterns. For example, all the release branches. all the feature branches. That way you can also add. Now what will you add in the branch production? As I told you, the most important thing that you will do, require a pull request before merging. The description also explains here, require all commits to be made to a non-target branch and submitted via a pull request before they are merged to the main branch. Just check this box, scroll down and click on the create. That's it. Branch production is now enabled to the main branch. Even if I try to push to the main branch now, it will not be pushed. Now let's take a look at RBAC. What is RBAC? Role-based access control. Fortunately, when you are dealing with public Git repositories, for example, you are on GitHub or you are on Bitbucket, RBAC is very simple. So if you are a DevOps engineer, you can grant yourself admin access. For developers, you can grant write access. For QA engineers, you can grant read access, so on. How will you do that? Just head to collaborators section. If you are doing it for your entire organization, within the organization settings, you will find option to do that. But because we are working on a repo, you need to invite the collaborator. Let's say I invite Veeramalla, which is my GitHub user ID, for example. Okay. Of course, I cannot invite myself, but if I invite myself, during the time of invitation, I can grant the read access, write access, or admin access. So this way, whenever someone joins your organization, you can invite them and you can grant them with the required permission. That's all. It's very simple when you are dealing with public Git repositories on platforms like GitHub or Bitbucket. Now let's look at the most important thing, which I told you, mandatory reviews. So what if you want 2 mandatory reviews? Every time a pull request is created, right now, for example, this is a pull request that Funny has created. Now I can directly go to the pull request and I can merge the pull request, right? Maybe the CI checks will run on the PR, but I can merge it without a peer reviewing the pull request. That is, without a fellow colleague reviewing the pull request. What if you want to enforce 2 mandatory reviews? Only after 2 mandatory reviews and only after the CI checks are passing, the pull request has to be merged. You can do that by using the mandatory reviews option on this GitHub or Bitbucket. Again, very simple. Go to the settings. In the settings, go to the branches, the branch protection rules that we created, right? Similarly, if you scroll down, when you enable the automatic pull request, require a pull request before merging, here you can say number of reviews that are required. So if I say 2 reviews are required, the pull request will be merged only when 2 approvals are provided. And of course, I can also say require review from specific team, require review from specific person as well. How do you define the person? You provide the name of the person in the code owners file. This is what I was talking about. I said we will learn about code owners. What is code owners? On open source repositories, you will have 300 to 400 contributors. Even within your organization, you might have a lot of contributors, but only certain people in your organization should merge the pull requests, right? There can be 20 developers, but only 5 senior developers. What you can do, you can check this option, require review from code owners, and you will create a code owners file. Simple. The name of the file is code owners, just like how we created .gitignore. Here we will create a code owners file, and within the code owners, we will provide the GitHub usernames of those persons. If you go to popular open source repositories, you will find the same practice. They will add the code owners and then they will check that option so that whenever a pull request is created, GitHub automatically requests the code owners to review the PRs. Now finally, let's talk about depend about. Okay. So what is depend about? Now this is a very, very important thing, especially when it comes to DevSecOps. This is introduced by Git distribution systems like GitHub. What depend about does? It is capable of looking into the packages that are used by your applications. For example, your application is a Golang based application. Dependabot can continuously look at your go.mod file and it can see what are the versions of the packages in your go.mod, and whenever there is a vulnerability in the version, let's say you are using XYZ package and the XYZ package version that you are using is 1.0. This morning, a vulnerability is introduced on this particular version. Now, obviously, you will be late because you know you cannot know all the vulnerabilities that are happening across the world. So you might take 2 to 3 days to fix this vulnerability. Someone has to look at it, someone has to report it. But what Dependabot is capable of? It's a bot. It's an application that will constantly monitor your repository. It will constantly look at your go.mod file, not only go.mod. It can be pom.xml or it can be the npm related packages, anything. Even it can be your Docker related packages. It will monitor all of them. It will look at vulnerability database, a database that has all the vulnerabilities in the world. And if there is a package that is vulnerable, it will automatically create a pull request and it can also merge the pull request. So within the minutes, a vulnerability is disclosed in the world, Dependabot automatically creates a pull request and updates the version in your repository so that you are safe from the vulnerability. Let me show you an example. Popular open source projects do it. So this is ArgoCD operator project, which I used to contribute. If you look at .github, along with the CI files, you will find dependabot.yaml. Now this dependabot.yaml, because this is a Git repository, the DevOps engineer here added this particular lines. So look for go.mod. It's in the root repository. Check every day and create a pull request. Pull request limit is 10 so that Dependabot will not spam the repository. Similarly, let's say you have npm. All that you have to do is change the file. That's it. Okay, Docker as well, Docker registry, and all the folders where you have the Docker related content. So Dependabot is very, very useful if you are working with multiple applications. You cannot look for vulnerabilities in different applications. Developers cannot do it, but Dependabot can do it because it is a bot. One more time, what it will do? It will basically look at your YAML file, pom.xml or go.mod, npm related file, and it will compare the version with vulnerability database. If your version is vulnerable, automatically it creates a pull request and updates your go.mod file. It can also merge the file for you so that by the time you realize, Dependabot already fixed the issue for you. So these are 10 common patterns that DevSecOps engineers follow within the organization. Git ignore, pre-commit hooks, Git leaks, repository scanning, integrating Git leaks into CI/CD, branch protection rules, RBAC, mandatory reviews, code owners, and Dependabot. If you have any questions, do let me know in the comment section and make sure you go through the README file for the quick revision. See you all in the next video. Take care. Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 3 of DevSecOps Zero to Hero series, and in this episode, we will focus on infrastructure as code security. In the first 2 episodes, we learned about fundamentals of DevSecOps and securing Git. They are very useful videos. In case you did not watch them, I would highly recommend them. After watching today's video, you can go back to the playlist and complete those videos as well. I'll share the link to the playlist in the description. Now going back to the context, we will focus on Terraform security in today's video. This video has three primary sections. The first one is the common best practices. What are the common best practices that DevSecOps engineers follow? Then we will learn about a very interesting utility called Checkov. So we will learn how to identify insecure Terraform files using Checkov or insecure Terraform configuration. And finally, we will learn about HashiCorp Vault. So we will learn what is Vault and how Vault is the best companion for Terraform. Basically, we will learn secret management with Vault. Now you don't have to get overwhelmed. All of these concepts we will learn with demos, and the detailed documentation for the demos is already in our GitHub repository. So just like every video, I've created GitHub documentation. So head to our DevSecOps 0 to Hero repo and go to T3 folder. Here you can find the checkout.md and wall.md. So this is for the insecure Terraform configuration demo. Again, so I have provided an insecure Terraform configuration. You can use this and you can scan the configuration using Checkov. And then I have the wall.md. This is where a lot of people get confused because to install Vault, to configure it, there are a lot of steps. So I made it simple. All the steps are documented in the order. And to make our demo interesting, I made it real time. So instead of directly using Vault with Terraform, we will also use GitHub Actions. So basically, we will learn Terraform in the CI/CD pipeline, how Terraform is used with GitHub Actions, and how dynamically AWS credentials for Terraform are fetched using Vault. This is what we are going to cover in today's video. So please try to watch it till the end, and after watching, spend 15 more minutes to complete the demo. Perfect. Let's start with common best practices. Now this is very simple if you followed our previous episode, because we covered common DevSecOps practices in the previous episode. Anyways, so basically when you are working with Terraform, let's say you are a DevOps engineer, your requirement is to create an S3 bucket on AWS, or you have to create 2 to 3 resources on AWS. Now, the common things that you have to follow, number one, because you are creating resources on AWS or any other cloud platform, you should not hard code the credentials. Now, this is a very simple one. To eliminate this, we learned in the previous episode, what you need to do, you should create a .gitignore file, and within the .gitignore file, you have to store your .env. I mean, you have to make an entry for .env in the .gitignore. Because you are working with Terraform, you also have to make an entry of your Terraform state file. And then you commit the .gitignore to the Git repository, so that even your colleagues or anyone else who is working in the organization, they also have a reference of your .gitignore. This is a very simple practice. So create a .gitignore file, add an entry for .env if you are using one, add an entry for Terraform state and anything like your PEM files that you are using, IDRSA or sensitive information. This way, you will not even accidentally push your hard-coded credentials or sensitive information. Now, there is a chance, of course, we are all humans. Accidentally, you might miss adding a file entry to the .gitignore file. Now, how to ensure that? You might be a good DevOps engineer, but your colleague might be a junior DevOps engineer. They might not add .gitignore to their local machine. So this is where we learned about pre-commit hooks. So even while working with Terraform repositories, it is recommended to use pre-commit hook so that pre-commit hook will validate your commit. Whenever you run git commit, even before you run git push, you run git commit. So when you run git commit, pre-commit hook is executed and it validates, it verifies if any sensitive information is being stored to your local Git before pushing to the public Git. So what will you have in the pre-commit hook? I have recommended in the previous video to go with Git leaks. Let me show you. If any of you haven't watched the previous demo, or if you have to focus more towards Terraform, we will do a very simple demo how pre-commit hook can prevent accidental pushing of Terraform secrets to public Git. So for that, we will clone our repository, or you can even create a simple folder. But what's important is to use the pre-commit framework. So this is the pre-commit framework. If you want to go through the framework in a very detailed way, the documentation is available. So instead of writing your custom script, you can just install this framework. How do you do that? If you're on Mac, just run brew install pre-commit. If you're on Linux, just run pip install pre-commit. Now, once you do that, within your repository or in a centralized location, you have to create a .precommit file. So .precommit configuration file. And within this configuration file, provide an entry for Git leaks. What is Git leaks? Git leaks is a utility which will verify any insecure or any credentials that are being pushed. So pre-commit is a framework that is using this utility. We learned a lot about Git leaks in the previous lecture, but just to repeat again, Git leaks is a simple utility that will run and verify the files that you are pushing to your local Git. And within those files, if there is any password, if there is any secret, or if there is any token, Git leaks will instantly block the commit. That's all. This is what you need to do. Add the pre-commit configuration file, and then you need to run pre-commit install. Let's say you already have the repository, then you can run pre-commit auto update. It is better to run pre-commit auto update as well in case you have other pre-commit configuration files. Now let's see the magic. Let's say I will add a secrets.env file, and within the secrets.env file, I pushed my AWS secret access key. Imagine I'm a junior DevOps engineer. I'm working with Terraform. I need AWS credentials, and I created secrets.env looking at some documentation on the internet, or maybe by following ChatGPT. Now, along with other files, I added this secrets.env as well. Now, even if I accidentally push this to the Git, if I don't have this pre-commit framework, and if I accidentally push this to the public Git, it's a major problem for the organization, because once sensitive information is pushed to Git, it's never lost. Once you push your AWS credentials to Git, it's almost never lost, because Git is a version control system. And in big organizations, Git is used by a lot of people. Even if you try to remove using a repo cleaner, or if you try to remove by getting in touch with GitHub support, there is a possibility in this time, by the time you reach the GitHub support, someone might have cloned the repository. Someone might have forked the repository. So during this time, they have a local copy of your AWS secret. So that's why it's considered a very big disaster. Pre-commit hook can help us here. Now that we configured the pre-commit hook, let's see. If I run git commit -am Let's say the junior DevOps engineer is working on advanced Terraform workflow. So junior DevOps engineer runs this commit because pre-commit hook is configured. See what happens. It will instantly block the commit. So it says the secret is redacted. And also it says one leak is found. So I will not let your commit go into the repo. This is a best practice that everyone has to follow. Unfortunately, even after using Git for a lot of years, not a lot of people know about pre-commit hooks, pre-commit framework. Not a lot of people have even heard of Git leaks. So it becomes your responsibility as a DevSecOps engineer to prepare this best practices document and share it within the organization. You cannot go to every person's laptop. You cannot create a .git ignore file. Even you cannot install the pre-commit framework and you cannot install Git leaks. But what you can do, you can set up the best practices document and share it within the organization. Let's say even still someone does not follow. Even after you sharing the document, there will be engineers who will not have time to execute these commands. What can you do? What you can do is very simple. Just go to the Git repository and create a CI/CD pipeline. Something like this. So create a Git leaks workflow and run Git leaks on every commit. And also run it on every pull request. So that even if they store the AWS credentials on their local Git, now when they try to run Git push to create a pull request or maybe to create a commit directly to the branch, the GitHub workflow gets triggered and it will instantly block their commit or it will block their pull request by failing the CI check. So this is the ultimate thing that you can do as a DevSecOps engineer. The CI/CD pipeline configuration is within the same repository. Go to .github, go to workflows, you will find the file. So these are some common best practices that you can follow. Quick revision. What did we learn? We learned about 3 points here. 1, the usage of .git ignore. Every repository in your organization should have a .git ignore file, just like the one that we have here. See how detailed is this .git ignore file. It has all the configuration. So you can find Terraform related ignore files here. You can find Python related ones here. You can find NPM ones related here, whatever your company is using. Then the next thing is to use pre-commit hook. So you should share a document of how to use the pre-commit hook on everyone's local machine. And finally, step 3 is to set up a CI file with the Git leaks. Now, Git leaks is not the only thing. The reason why I have been talking about Git leaks, it's the most easiest one to get started. Otherwise, you have options like Trufflehog and you also have many other utilities. Perfect. So this is about the first section, best practices. Now let's move to the interesting utility, that is Checkov. What is this? Now, a lot of times when people work with Terraform, especially when junior engineers work with Terraform, like everyone, they also use Terraform to create infrastructure. Let's say a simple task is given to a junior DevOps engineer. The task is to create S3 bucket. Now let's say this junior engineer creates the S3 bucket using Terraform, takes help of ChatGPT or maybe takes help of internet, Terraform documentation and creates the S3 bucket. This is all good. But what if the S3 bucket is public? Terraform does not warn this engineer. Even the pre-commit hook will not warn the engineer because the Terraform code for S3 bucket is absolutely right. But the problem is that the junior DevOps engineer created a public S3 bucket And within this public S3 bucket, developers or your existing workflows push some logs and also some sensitive information. Now they thought, other engineers and even your existing systems, they thought your S3 bucket is private, but unfortunately, what the junior DevOps engineer created is a public S3 bucket. How can you prevent this? You might miss this in the code review, obviously, because you cannot go through each Terraform field. On top of that, your CI checks like Git leaks or your pre-commit hook is also not catching this. What do we call this? This is called Terraform misconfiguration or insecure Terraform configuration. How do you catch that? Checkov can help you with insecure Terraform configuration. Let's see how it works. So we will first create an insecure Terraform configuration, right? So we will create an S3 bucket like configuration, and within that insecure configuration, on that insecure configuration, we will run the Checkov utility. I'll go back to my terminal. Okay, so I'll create a folder here. Let's call mkdir test, and within this test, let's add a main.tf file. Okay, let's add insecure Terraform configuration to it. So as we discussed, this is an S3 bucket creation where, if you notice carefully, if you worked with Terraform in the past, intentionally, I have disabled blocking of the public ACLs. So block public ACL, false. Block public policy, false. Restrict public buckets also as false. So basically, I'm making this configuration insecure. Now imagine a junior engineer got this code from ChatGPT or somewhere from the internet. What junior DevOps engineer usually does, verifies the syntax using Terraform linting, runs the Terraform plan to see if Terraform creates S3 bucket or not. In this case, Terraform would obviously create the bucket. But what we need is secure configuration or the secure infrastructure. As I told you, this is where Checkov helps. So all that you need to run, Checkov-d followed by the folder in which you want to run it. In our case, I want to run it in the same directory where I have main.tf. Now you can see the magic. So Checkov will start understanding your Terraform configuration. It will automatically run checks depending upon your configuration. So it ran 2 plus 4, 6 checks. So Checkov initiated, it ran 6 checks, out of which 2 checks are passed and 4 checks are failed. And all these checks are related to S3 bucket configuration. Let's say you run Terraform configuration related to EC2 instance, and if you run Checkov on that, Checkov will run the checks that are only related to EC2 instance. In our case, because we are creating S3 bucket, all the checks are related to the bucket, and this is an automatic process. Okay, let's see which checks passed and which checks failed. So the first 2 checks passed, basically this one, ensure S3 bucket policy does not lock out all the root user. We did not break that. Ensure S3 bucket does not have global view ACL permissions enabled. Even we did not tweak anything in that. Now see in which cases it failed. Ensure S3 bucket has public ACLs enabled. Yes, we did that. So Checkov says this is a bad security practice. Similarly, ensure S3 bucket has block public policy enabled. Yes, we did that. That's why it failed again. The check. Another check failed and another check also failed. So how is Checkov helping you here? It is helping you as typically like the test cases, but you are not writing the test cases. Lot of times people might also ask you in the interviews, how do you define your Terraform test suite? Apart from your regular tests, you can also talk about Checkov. So you can say, we have integrated Checkov in our configuration. Every engineer runs it locally. Even we integrated this to the CI file. So anyone tries to push a Terraform configuration to our GitHub repo, even there Checkov runs and validates the configuration. Now let's see by fixing it. Okay, we got to know what are the issues. Now let me provide the right configuration in the same file. I'll open the file again, vim main.tf. All that I'll do, I'll change the block permissions or the block features from false to true. Again, the same configuration is provided in the documentation also. You don't have to copy anything from my terminal. Let's save this. So we did not allow, we say block public ACLs true. This means this will block the public ACLs, this will block the public policy, and this will also ignore any public ACLs. Even when we look at the configuration, it feels secure. Let's see what Checkov says. I'll save this and rerun Checkov-d dot. And in this case, all the checks are passed, which is a good case. So ensure bucket has ignore public ACLs, ensure bucket has public policy enabled, ensure bucket has public ACLs enabled. Very nice. So we covered the first two parts. We learned the Terraform best practices from security point of view. And we also learned insecure Terraform configuration verification, that is using Checkov. Now let's head to part 3, that is HashiCorp Vault. Now most of you might have this question. Abhishek, why should I learn something new? Why should I integrate my existing Terraform with a new tool like Vault? Let's start with this. We will understand this through a scenario. Now, most of the times when people work on a hobby project, the workflow is simple. So on the local machine, they create some Terraform files. They create a .env file. They create .gitignore, and within the .env, they had the Terraform credentials. Basically, if they are trying to create resources on AWS, they add AWS related credentials to the .env file. Now, after this, they execute Terraform. That is, they execute the Terraform files on the same local machine. Now, obviously, once it's executed on the AWS, the resources are created. This is the usual workflow. Now, if you understand the production workflow, it is totally different. So when you work in the organization, you don't follow this workflow, but what you follow, instead of writing or executing the Terraform files on the local machine, you would execute that through CI/CD or continuous integration. I'll explain the total workflow now. So basically, Terraform files are stored in the Git repository, unlike the local machine. If anyone wants to update the Terraform configuration, they clone the Git repository, they update the changes. Basically, they update the Terraform files. Then they push the changes back to the Git repository. Once they are comfortable, they push the changes. And once the changes are pushed, here CI is executed. Let's say GitHub Actions. And through GitHub Actions, resources are created on the AWS. Now you might ask why? What is the advantage of this approach? There are two major advantages. The first advantage, individually, nobody creates resources on the AWS. Everyone goes through the standard process, that is through CI. So overall, CI is the one that is creating the resources on AWS. Now CI will be provided with credentials, and only through that credentials, the resources are created on AWS. Resources are not created by Abhishek user AWS credentials or XYZ user AWS credentials. Everything will be created using the CI credentials. So there is accountability here. Who is accountable? CI is accountable. On top of that, when you add your Terraform files to Git, just like your application source code files, you get the classic features of Git in place. The first and most important thing, now you can start reviewing the changes. Imagine your team has a junior DevOps engineer and senior DevOps engineer. Junior DevOps engineer is quite new. Now, when junior DevOps engineer gets assigned with a task, maybe the junior engineer might write the wrong code on the local machine and execute that wrong code on the AWS. Although there is a senior engineer, but the code or the Terraform change did not go through a review. How can this be involved? This can be involved if you employ this approach, where the junior DevOps engineer clones the repo, makes the changes locally, push the changes back to the GitHub repository through a pull request. And then the senior engineer reviews the Terraform code. Only if the senior engineer is convinced and only when the CI check is succeeded. Of course, once the senior engineer is convinced, senior engineer asks CI check to run, and once the CI check is run, the CI creates the infrastructure on AWS. So you can follow this approach. Or what you can also do, once the pull request is reviewed and merged, then on the push action, you can run the CI. Now, once the commit is pushed, CI executes AWS infrastructure. You can also follow this approach. Additionally, now, when you use version control systems like Git, you also get backup, or you also get previous version of your Terraform script. What is the advantage here? What is the advantage of having your Terraform scripts version? Let's say even if you push a wrong infrastructure to AWS, your production might break, but instantly you can revert the commit. Because everything is in Git, just revert the commit. Again, the revert pull request is also merged, and then CI executes and creates old version of the infrastructure on the AWS. So reverting the infrastructure also becomes simple when you integrate your Terraform code with Git. Finally, there is also proper auditing in this case. If you want to know 6 months before who made changes to a particular TF file, if everyone is doing it on local, there is absolutely no way you would know who created a resource on AWS and who updated a particular resource on AWS. Let's say 6 months before, someone created an EC2 instance. 4 months before, someone updated the EC2 instance. In the manual action way, there is no way you can understand it. But if changes goes through CI/CD, you will definitely know who made the changes 4 months ago and who created the EC2 instance 6 months ago. So overall, what I am trying to tell you here, Terraform files should also be in the Git repository. And who should execute the Terraform files? It should be CI systems like GitHub Actions. Your Terraform resources should be created on the cloud provider only through the CI. Now the question is, how do you provide credentials to your CI? Right? So if it is your local machine, you provide the credentials of your personal user. Right? If I am working on a hobby project, I will provide my AWS credentials. If my colleague is working on a personal project, my colleague will provide their own AWS credentials when working with the hobby project. Now, within the organization, everyone is running GitHub Actions. So, whose user would you provide, or whose credentials would you provide? So, you need a common credentials. As I told you, we want GitHub Actions to be a single entity that is creating the infra on the cloud. So this single entity should have a single credential. Now you might say, okay, Abhishek, I will create a service account, right? I'll create a bot-like account. And for this bot-like account on AWS, I will create AWS credentials. Absolutely point on. You should do this. You should create a service account, basically like a dummy user. And for the dummy user, you should generate AWS credentials and you should provide CI with AWS credentials. But the problem is that a lot of people in your organization would have access to the CI. Let's say you wrote the GitHub workflow, a GitHub action that creates resources on AWS. And for this actions file, the common way to grant permissions, where would you store AWS credentials? You can say, Abhishek, I'll go to settings. In the settings, I'll go to secrets and variables. I'll go to actions. And here, I will provide the repository secrets. So I'll store my AWS secret access key, something like this. AWS secret access key and AWS access key ID. And within my CI file, I would reference the credentials. This is also good, but this is not completely secure. Now, I'm not denying this approach, but this approach is not 100% secure. You should ask why. The reason is that, understand this carefully. When you are working in a startup, it's okay. But if you are working in an MNC, you have thousands of users in the MNC. Even within a DevOps team, you might have 50 DevOps engineers. You might have 20 to 30 people in your management who has access to the repo. You might have some 5 developers who has access to the repo. Maybe senior developers who has access to the repo. Now, if you create a bot account, the service account on the AWS, and if you create AWS credentials for this bot account, and if you add these credentials to the GitHub, that is, if you add the credentials here, what if one of these people left the organization, but they looked at the credentials in the past and they want to use the credentials for bad purpose, or they leak the credentials to a bad actor. Now, most of the security threats happen through internal resources as well. It doesn't have to be they left the organization. They can still be in the organization. These 100 people or 80 people who has access to this repo, they can look at the AWS credentials that are being used in the CI and they can share these credentials to someone external in the organization. Now, because these are bot credentials, that is, because these credentials are from a central user like a service account, you would not really know who leaked the credentials. For example, if Abhishek's AWS credentials are leaked, Abhishek is responsible. But if bot's credentials are leaked, whom will you hold the responsible? 85 people has access to these bot credentials. One of these 85 people, they looked at the GitHub repo and they leaked the credentials to the bad actor. So again, there is no accountability here. That's why you need a strong secrets management solution. The problem that we are dealing with here is basically the long-lived credentials. What do we call this problem? This problem is long-lived credentials. You create a service account or a bot account. You create credentials for it on the AWS account and you put the credentials in the GitHub repo and they stay for ever and ever. For 3 months, 6 months, 1 year, most of the teams, they don't rotate the secrets. Even if they rotate once in 3 months, still you are at a risk period of 3 months. Within these 3 months, someone can leak the information. So what you need instead, you need a secrets management solution that can provide you with short-lived credentials. And these credentials should only live for 10 minutes, 15 minutes, till the time your CI executes, right? Now what happens when you introduce a secrets management solution like HashiCorp Vault. Let's look at the workflow. Understand this workflow carefully. Now, in this workflow, which is typically a production-like workflow, Terraform resources are stored to the Git repository. All the Terraform resources are in the Git repository. Let's say one of the DevOps engineer clones this repo, makes the changes, that is, makes the update, and push the changes back to the Git repo. Now, on the Git repo, GitHub Actions is triggered. Right? GitHub Actions, what it does not have the credential. It would go to HashiCorp Vault and it would request the HashiCorp Vault, hey, I am running a Terraform script to create resources on AWS, but I don't have the credentials of AWS. Can you provide me with a short-lived credential? That is, can you give me AWS credential that lives for 5 minutes or at the most 10 minutes? You can design this according to your GitHub action execution time. Let's say your GitHub action executes for 10 minutes. GitHub action requests HashiCorp Vault to give short-lived credentials that lives for 15 minutes. So GitHub actions takes this short-lived credentials, execute the resources on AWS, and after the 15 minutes, even if someone gets hold of these credentials, they are dead. That is, they don't work. That's the advantage of HashiCorp Vault. A lot of people think it is needed to store the credentials. No, you can store the credentials here as well. If storing credentials is problem, you have a lot of places that you can store. Best example, you can store it in the GitHub repository settings. But that's not the problem what HashiCorp Vault is majorly solving. The problem that it majorly solves is with long-lived credentials. So it will eliminate the long-lived credentials and it will generate short-lived credentials for 10 to 15 minutes for the CI/CD systems. CI systems take it and they execute the resources on the cloud provider using the credentials. And this concept is very, very interesting. Of course, I don't want to go too detailed in it because it involves concept like OIDC, lot of networking concept and secrets related concept. But still, just to give you a simple picture, what GitHub Actions does here. So GitHub Actions, it uses the OIDC and requests the Vault. Now, Vault is pre-configured by DevOps engineer. So a DevOps engineer, a senior DevOps engineer, whoever sets up Vault, they initially provide Vault with the AWS credentials. Vault uses this AWS credentials and creates an IAM user. That IAM user is short-lived. Now GitHub Actions just gets these short-lived credentials through the OIDC protocol. And for this, you need to do one-time setup. Right? So you have to install Vault on a EC2 instance, or you have to install Vault on maybe Kubernetes, and you have to configure the Vault. That's what we are going to do at this point. But two things that you have to remember here. This is very important for your interviews. One, if someone asks you, what is HashiCorp Vault? Just don't say it's a secrets management solution. You should elaborate it. It's not just a secrets management for storing the secrets, but it solves a major problem with the life of the credentials. On top of that, you should also explain them just in a one-liner. GitHub Actions uses the OIDC to interact with HashiCorp Vault and get temporary credentials. Perfect. Now that we learned about it, now that we understood the underlying concept as well, let's go ahead and create this setup. First thing that I'll do, I'll go to my AWS account. I'll create an EC2 instance here. All the commands that I'm going to execute, including EC2 instance creation and setup are within the document that I prepared. Okay, I'll just call it as Vault Server, Ubuntu. Go with the free tier instance as itself. You don't need an instance that lives for, or you don't need an instance with more resources. A free tier instance is good enough. I'll use my PEM file. Okay, I need a security group. I'll create that later. For now, I will launch the instance. Okay, I use the default options. I used Ubuntu. I used free tier and I created the instance. Let's connect to this instance. Okay, so this is a public IP. I'll just copy it, and on my local machine, I'll just use the SSH protocol. Okay, SSH-I. I have the PEM file in my downloads folder. Downloads, Abhishek.Veeramalla.pem. This is the PEM file. And here, Ubuntu at IP address. Perfect. So I have my local connected to the EC2 instance. Whenever you work on a new virtual machine, always make an habit to update the repositories. We are using Ubuntu, so I'll update the apt repositories. Perfect. Then just install basic utility. We will use unzip here. Now why I'm using unzip, you will understand that in the next commands. But for now, let me install unzip utility. Okay, clear the screen. Unzip. Okay, I installed unzip as well as wget. Now using wget that I just installed, I will download the Vault package. The Vault package is downloaded as a zip. That's why I will use the unzip utility. Perfect. Now I have the Vault folder on my local machine. Just move the Vault binary to user local bin. So we are moving it to an executable location. Now just run Vault version to verify the Vault server, the Vault utility executable is installed. There you go. The version of the Vault is 1.15.5. Now using the same executable, just run the Vault server. Very simple. Run this command, Vault server in the development mode, followed by on the address on which you want the Vault server to be listening. We will use localhost followed by port 8200. There you go. So we have the Vault server running on this terminal. We will keep this intact and on the other terminal. So I'll just duplicate this session. I'll reconnect to my EC2 instance, and here I will continue with the next steps. Till now, I just downloaded the Vault utility, the binary, and I started the Vault server. Of course, the server is started on 8200 port, so we need to open the port as well. Let's quickly do that. Inbound traffic rules. This is the one. Here we will edit the configuration, the security group, edit inbound traffic, and we can just add the custom port 8200. Or you can just open the traffic because we are just doing a demo, but in real time, don't open the entire traffic. Save the rules. Perfect. Let's access HashiCorp Vault. So we will take the instance IP one more time. This is the instance IP. And here, colon 8200. You can access the Vault server. If you want the token, go back to your instance or using this root token, just connect it here. Token, sign in. Perfect. So I use the root token, which is root in my case, and entered it in the root token section. And this is my HashiCorp console. So we have the Vault server running. Let's run, on the other terminal, let's log into the root. So I exported the address and I logged into the root. Perfect. Now we will run this command, vault secret enable AWS. Right? We are storing AWS secrets. So you can see here in the secret engines, you have AWS secret engine. Now here, as I told you, we will store our AWS access key as well as secret access key ID. How do we do that? We will use the terminal itself instead of creating it from here. So this is the command, vault write AWS configuration, and here you need to provide your secret access key ID and AWS access key ID. We will generate it. Go back to AWS security credentials, and here scroll down, create access key. Right after this demo, I'll delete it. So there is no problem with security. Copy, paste it in the access key ID section, and secret key, paste it from the terminal as well. The AWS console as well. Perfect. Data written to AWS config root. In my case, I am using the AWS root user, but let's say if you're going with a normal AWS IAM role, in this case, I'm using the root user. So by default, it has all the permissions. But let's say to this AWS credentials, if you want to add some permission, whoever is the IAM user for this AWS credentials, if you want to grant them additional permissions, you can use this command. In our case, we are basically about to create an S3 bucket through the CI/CD pipeline. So I am adding S3 full access to this IAM role or the IAM user. As I told you, if you are using the root user, you don't need to do that. But most of the cases, you will not be granted with root user in your organization. So the AWS credentials that you're using should be from an IAM user with normal permissions. Whichever permissions you want to add permissions using this vault write command. Cool. So we granted this permissions as well. Now let's enable the OIDC on this server. So we will enable vault auth enable JWT, that is Java Web Token. Abhishek, why are we enabling this authentication? Simple. We want this vault to be accessed by GitHub Actions. So for GitHub Actions to access the vault and to request for the credentials, you need to enable an authentication method. In our case, we are going to use, GitHub Actions will use JWT, Java Web Token. This is default. You cannot change it. Cool. In the next step, you enable JWT, but you have to provide the OIDC configuration that GitHub is going to use. This is provided in GitHub documentation. So you have to run this command to enable GitHub Actions for the OIDC configuration. Perfect. So now we enable Java Web Tokens and we enabled OIDC discovery URL for GitHub Actions. Perfect. Now let's create the policy. So vault policy, write a simple Terraform policy. And finally, we will bind this policy to the GitHub repository. Okay, what is the policy that we created? We created the read policy, and now we will grant this read policy to our GitHub repository. In my case, the GitHub repository is Abhishek.Veeramalla DevSecOps 0 to hero. Now this repository will get the read access, and through the read access and through JWT, Java Web Tokens, it will make a request to the Vault server, and Vault server will return it with the temporary credentials. Perfect. If you see here, token time is 1 hour. If you want, you can change this to 10 minutes as well. It's up to you. Perfect. Now we have the GitHub actions all set. Let's go to our Terraform folder. We will focus on the execution now. So we will go to the GitHub repository where I created a Terraform folder. In this Terraform folder, I will use S3 bucket configuration. Okay, provider AWS US East 1. I'm generating a random ID and I am creating an S3 bucket with name DevSecOps Vault Demo followed by this random ID so that S3 bucket name is always unique. Now this Terraform configuration should be picked up by the GitHub actions, and GitHub actions should create this S3 bucket on the AWS. For that, we need to create a GitHub action CI/CD. I'll go to .github workflows and here I will add a file. Let me just call it as ci.yaml or infracreate.yml, and I will write the simple GitHub actions here. I'll paste it here for your reference and I will explain this GitHub actions. What are we doing? Terraform deployment. On which action? On the push action. Every time there is a commit to this repo, the GitHub action should execute. But what should execute? We will use the Ubuntu runner. We will switch to the Terraform directory and we will just execute the Terraform init, the Terraform plan and Terraform approve. Only thing that you need to modify in this CI file, because it is very straightforward. We are using a GitHub runner. We are switching to the Terraform directory and we are running Terraform init plan and apply. But what's in between here is the most critical part. Fetch keys from Vault. So you need to provide the Vault IP address. In my case, the Vault IP address, I'll just copy it. You can make it a variable so that you don't have to update it manually. This is the Vault IP address and that's the only thing that I have to change. So now this GitHub action will make request to this Vault IP address. It will get the AWS credentials and using this AWS credentials, it will run Terraform init, plan and apply. The interesting part that I talked about, GitHub actions will not get access to our Vault AWS credentials, the one that we gave to Vault, but I told you Vault will create a temporary user on the AWS account. Let's watch that. Now, before I commit this file and before the CI gets execute, let's actually go to the AWS account. Let's go to IAM users and see if a temporary user is being created. We'll go to the users. Okay, right now we have 4 temporary users, which I executed in the morning just for the test purpose. Now during this execution, this should change to 5. Okay, we'll commit this file. Commit. Let's see what happens. Now the workflow should get executed. On the parent repo, we'll click on the workflow. Okay, it is running. Let's say what's happening. Okay, it actually fetched the credentials from HashiCorp or Vault already. So a user should be created. We are here, still 4 users. If I refresh, it should be 5. There you go. And the lifespan of this user, the one that is newly created, is only for 10 minutes. Even if someone hacks it, there is no problem. Let's go back. The CI execution is complete. It said Terraform init is done, Terraform plan is done, Terraform apply is also done. Let's verify. We'll go to our AWS account again, but this time I will look at S3. Okay, on the S3, let's see if a bucket is created. General purpose buckets, and we have DevSecOps Vault demo. So this is just created. We have other buckets as well. As I told you, I used it for the demo purpose. But every time you run this CI file, a new bucket is created. Because in our Terraform script, we are asking it to create a bucket. This is how things work in real time. What is the major advantage of HashiCorp Vault? I'm repeating this again, I know, but it's very important for your interviews to explain. HashiCorp Vault provides a short-lived credentials, and this short-lived credential can be used in the GitHub Actions. How GitHub Actions is using them? It gets the credentials using OIDC and Java Web Tokens. Now, if you are worrying about the configuration that we executed, the commands that we executed, don't worry. Even I will not remember those commands. Everything that you have here, the vault.md file, I have taken from official documentation. I have collected it from different sources. So even if you are doing it in your organization in real time, you will not remember these commands. You will only get it from your documentation. So don't worry about the commands. Focus on the concept. Run every step in the vault.md by yourself. Understand what every command is doing. Finally, understand how Terraform works with Vault. This is the demo for today. I hope you liked basic security practices, Checkov, and also Vault integration. If you have any questions, do let me know in the comment section. See you all in the next video. Take care. Hello everyone. My name is Abhishek and welcome back to my channel. Today is episode 4 of DevSecOps Zero to Hero series. And in this episode, we will focus on securing containers. In the last 3 episodes, we learned introduction to DevSecOps. Then we learned securing Git. In the previous episode, we learned security best practices for Terraform. In the same way, in today's video, we will learn security best practices for containers. We will focus on 5 different topics in today's video, starting with what are the security challenges of running a container with root user, which a lot of people do, especially the beginners, and how to run the containers as non-root users. What changes do you need to make in the Docker file? Then we will learn what are advantages with multi-stage Docker builds from security point of view. Then we will learn one of the most important security aspects for containers, that is Distroless images. What are Distroless images and how can they add security to your containers? Then we will learn about simple but very efficient thing, that is .docker ignore. How can you introduce this to your project? And finally, we will learn about hardening container runtime. So we will learn how can you add few parameters to your Docker run command that can harden the security of your container. So these are 5 different topics that we will focus in today's video. We will go step by step. We will learn each topic using a demo. And you don't have to worry. Everything is documented within this GitHub repository. So if you go to day 4 folder, I'll share the repository link in the description. Just head to the day 4 folder, container security. You will find the README file. And within the README file, you have all the steps, commands that I'm going to use, even configuration files. So after watching the video, spend 15 to 20 minutes more and implement the demos at your end. And to add to it, we will learn using a sample application in today's video. We will create a Docker file for a sample application, which is a Node.js application, and we will learn how to improve the Docker file to accommodate the best practices. Now, what is this demo application or the sample application? Because our focus is not about application, I've taken a very simple Hello World Node.js application. So this application runs on port 3000, and when you run the application, it will just return hello from the container. Then it also returns the user ID with which container is running. Let's say you run the container with root user, it returns the user ID as 0. If you run the container with any other user, it would return the user ID accordingly. And finally, it also prints the host name. So these are three things that the application returns, Node.js application returns, when it is run within a container or even outside. And how to run the application? Again, this is something that you need to know before you start writing the Docker file. So to run this Node.js sample application, first you will build the application using npm install, and then you will run the application using npm start. That's all. This is good enough information for you to get started with the Docker file. So all the files are here. app.js is the source code for the Node.js application. Package.json is the dependency file. So here we have Express as one of the dependencies for the application. Perfect. Now let's get started. So let's see how a junior DevOps engineer who does not care a lot about security, but cares about completing the task. What is the task? To containerize this Node.js application. How would that junior DevOps engineer write Docker file for this use case? Of course, the very first thing that this junior DevOps engineer does, take the terminal, right? So I have a terminal, and then the junior engineer clones the project, because to do anything, first the engineer needs the source code. So this person would clone the repository. In our case, the source code is in the same repository, DevSecOps 0 to hero. So let's get the GitHub URL and run git clone inside a directory. I'll go with Docker directory on my local machine. Okay, so I already have the project here. Let me just remove the project so that we can start from the basics. Git clone followed by the URL. Perfect. Day 4 folder, DevSecOps 0 to hero, day 4. The junior engineer starts writing the Docker file, or let's say DevOps engineer not caring a lot about security, vim Docker file. Perfect. Now, because this is a Node.js application, right? So what we are dealing with is a Node.js application. So what should be the base image? Base image in this case should be the node base image, so that you don't have to worry about the Node.js installation. Let's say you go with Ubuntu base image. In that case, you have to use the run command to update the apt repositories, and then you have to install Ubuntu on the base image. Instead, you can directly go with node 25, because 25 is the latest version. If you're not sure what is the latest version of the image, just head to the Docker hub and you will find the latest tag version. Perfect. Then the junior engineer would create the work directory, let's say /app, so that all the commands would run within the work directory. Then the junior engineer would copy the source code, in this case app.js and package.json. Then the junior engineer, as per the instructions here, the first command is npm install and then npm start. This is for build and this is for running the application. Okay, npm install, expose the port 3000, and finally within the CMD or entry point, the junior engineer would add the fields npm followed by start. Now this can be within the entry point as well. Perfect. So now the junior engineer verifies the Docker file by running the Docker build. Right? Let's see one more time. Cat Docker file. Okay, the file looks good. How do you run the Docker build? Very simple. Docker build. Basically, we are creating Docker image from the Docker file. Docker build. Let's provide it with a tag. Let's call it as insecure image. Followed by dot the location of the Docker file. Okay, so I don't have Docker running. I think I stopped Docker sometime back. Let me just restart Docker. I'm using Docker desktop, so I just started the Docker process. Let me verify again. There you go. Now the build is running and we have the Docker image created. Cool. So now the junior engineer verifies by running the container to see if the Node.js application is running. How would the junior engineer do? Docker, or let me clear the screen. Docker run -it interactive terminal, or without an interactive terminal, just -p port 3000 bind to the local host followed by insecure image. Okay, so the container is running. As final step, junior engineer would take a duplicate tab and verify by just running curl localhost colon 3000. There you go. Hello from container, hostname, UID. Now the task is complete, right? So the junior engineer or someone who is assigned with this task and does not care about security, they would say, there you go. My task is complete. I created the Docker file. The Docker image is also created, and I verified by running the container that Node.js application is running successfully within the container. Now, even you might say, Abhishek, the task is achieved. What to do more? Let me tell you, there are security challenges with the Docker file that is created and also issues with the container that is running. The first and the foremost issue, if you look at the UID, the user ID is 0. That means this container is running, but it is running as a root user. I can also show you. Now I'll just stop the container. This time I will run the container in the interactive mode. So if I just do -it followed by sh to take the shell on the terminal, or bash as well. Let me just do sh. And here if I run id, you will see the id is the root user. That means this container is running as a root user. What are the security challenges here? What are the security issues? Very simple. Take example of your laptop. Would you give access to your laptop to someone as an administrator? Typically no, because they can create new files, they can download anything on your laptop, or even if they are bad actors, they can run hundreds of processes on your laptop and technically make your laptop unusable. In the same way, now if a bad actor gets access to your container, the bad actor can create multiple volumes within the container, just like that, to make your container look heavy, or maybe to indirectly, if the volumes are running, this is stored on the local machine where your container is running by default. So this way they can even perform spam attack on your host machine. Same way, just like volumes, they can also run n number of processes. Imagine a bad actor running 200 processes within the container just to make your host. The container is running on a virtual machine or a host. if 200 processes are running within a container, they utilize the resources on the host. Technically, your host becomes inaccessible, or other containers that are running on the host do not get enough resources. So they can perform DDoS attack. Or most importantly, what a good bad actor can do, or what an efficient bad actor can do, is because the container is running as a root user, they can even get access to the host. Why? Because if you're using Docker as runtime through the container, they can access the Docker daemon because they are a root user, and from the Docker daemon, because Docker daemon runs as a root user, they can get access to the host as well. Understand this carefully. You are only thinking about container, right? You are thinking that my container is running as a root user. What's problem? But if your container is running as a root user, because the container is running on a host, right? Let's say the host is a virtual machine, and the container is running using Docker runtime, and Docker runtime always runs as a root user. Docker daemon runs as a root user. Now this bad actor can get access to the Docker runtime, and from the Docker runtime, they can get access to the host machine. Now, if they get access to the host machine, they are already within your network. They have complete access to your infrastructure as well, if you don't have proper virtual private cloud. Now, this is something I'm not making it up. You can find a lot of similar stories on the internet. Because of using a root user within the container, lot of companies' infrastructure was compromised. You can eliminate that. If you are a good DevOps engineer, if you want to follow security best practices, just using 2 more steps in the Docker file, you can run your Docker container as non-root user. Let me show you how you can do it. 2 basic steps. Now, use the same Docker file. There is no problem. Vim Docker file. Now, I will update this Docker file. 1, I will create a user within the Docker file. Just before you perform any instructions within the Docker file, even before copy, just create a user. So here, group add -r user. So basically, I'm creating a group, and basically I'm adding a user to the group. I'm calling it as app user. If you want, you can call it as Abhishek user, you can call it as XYZ user, or you can call it as a developer, whatever you feel like. And just switch the user. How can you switch the user? Use the user keyword within the Docker file and the name of the user that you created. That's all. Till here, commands are executed as the root user. And when you use this user keyword, from this point, the user is switched to the regular user. In our case, app user. So now, whenever someone logs into the container, they will log in as an app user. This app user does not have elevated privileges like your root user. So even if they want to perform something, they will fail to do it. Let me show you. Now we will create another Docker image. Okay. This time, Docker build -t. Let's provide the tag name. Let me just call it as rootless image or non-root image dot. Let's see what happens now. Okay, the image will be built fast because of the Docker cache. Docker already has the cache. There you go. Now, Docker run. Let me run it as an interactive terminal so that I can show you. Docker run -it non-root image sh. Okay, so I'm taking shell within the container one more time. Enter. Now let's see ID. I'll run the ID command again. Non-root user. So you can see this time user is the app user. Abhishek, can you show by running some command so that we know it does not have elevated privileges? Let's see. We will run apt install x, a random package. What does it say? Permission denied. We can also try with sudo. Let's do sudo apt install x. What does it say? Sudo does not exist. That means using this user, you cannot perform sudo. So this way, now the end user, whoever has access to this container or even a bad actor, through some way, if they get access to the container, still it's not a big problem for you because they can only access the container as a non-root user. But Abhishek, still the application runs within this container? Yeah, we did not make any significant changes. If we just do docker run -p 3000 :3000 followed by insecure image, sorry, non-root image, we should see the container running. It says port 3000 is already in use. Let's change this to 3001. Okay, on the other terminal, this time curl 3001. There you go. Hello from the container, host name, user ID is 999. So the application is running and we also ensured application is secured. All with just 2 lines more to the Docker file. What we added? We added the run command where we created a user and a group, and then we switched to the user before running the CMD. Now the junior DevOps engineer or someone without a security approach, they might think that the task is complete. Okay, now I'm running the container as a non-root user. My task is complete. Let me tell you, the task is still not complete because if you do Docker images, you will notice something very, very important. What did we create? We created non-root image user. This is the final one that we created. The content size, that is the image size, is 401 MB. Just for a simple Hello World application, your container image size cannot be, or your Docker image size, let me put it that way, cannot be 401 MB. It's too much for your image. All that you have is this simple thing, 20 lines of code. But Abhishek, how does that create security issue? We are talking about DevSecOps. We are talking about security issue. How the container image size impacts my security? It does. Because when your image size is more, understand this carefully. If your image size is more, that means you have more packages within the container, right? It can be two things. It can be system packages, that is your base image packages, the one that comes with Node 25. This is the base image that we used. Or it can be because of your application packages. So we ran npm install, right? When we run npm install to build the Node.js application, Node.js or npm can download packages from the internet, and even after the application is built, some of these packages can stay within your container image. Now this is a problem because you don't need these packages at the runtime. See, there are two stages for every application. One is build stage, one is the execution or the run stage. You need a lot of packages during the build stage because you want to download the packages from the internet, right? To build the application, to compile the application. But you don't need all of those packages during the runtime. During the runtime, you have, if it's a Java application, a jar file, war file, or you have basically a binary. And you just need this binary and runtime environment to run the binary. That's it. Now, if you keep these packages that you downloaded still in the container image, you are not checking on the timely basis if these images are vulnerable, today those packages, today those packages are not vulnerable, let's say. If you take example of ABC package, okay? ABC package, you must have downloaded 1.0.0 for building your application. Today, this package version is fine, but maybe 2 months down the line, there is a critical security issue with this version. Now, ideally, you should upgrade this to 1.0.1, but why would you log into the container? Why would you bother about checking the version? A lot of people would ignore that. So your container, it is running in production and it is still running with 1.0.0. Imagine a bad actor get access to your container. They might get access as a non-root user, but still, because there is a vulnerable version, the bad actor can attack through this vulnerable package version. So this package can be a threat for your organization. How can you avoid this? Very, very simple. Just break your Docker file. Okay, just break your Docker file into two parts. This is what we call as multi-stage build. The first stage is the build stage. Second stage is the run stage. If required, when you are dealing with a 2-tier application or something like that, you can even add more stages. But typically, you can add a build stage. You can add a run stage. In the build stage, for our use case, focus on npm install. In the run stage, focus on npm start. And from the build stage, just take the binary that you created to the run stage. And finally, the image that you created will only have the run stage artifacts. Okay, this is the advantage that Docker brings onto the table. In the Docker file, you can create n number of stages, but what Docker will consider only the last stage. The image that you have will be only created from the last stage. So what you will do as a DevSecOps engineer, you will use the build stage. In the build stage, you can download any number of packages. You can get them from the internet. You can do anything. Build the binary. And to the run stage, just copy the binary and have the container runtime. In our case, what is the container runtime? Node is the container runtime. So in the run stage, you can just have node container runtime and binary that you created in the build stage. That's it. Create a CMD and you can have your runtime environment ready. And when you do this, your container image size will significantly go down. And if the container image size significantly goes down, that itself means there are less number of packages within the container. When less number of packages, less impact radius. Let's see this in live. Okay, I'll break our container image into two stages. This time, I will create a new Docker file, or let's delete the existing Docker file, rm, or maybe let's create a new one. Okay, I'll create a folder, mkdir, multi-stage, cd multi-stage, vim Docker file. Okay, so we need two stages as we discussed. The first stage, we will keep it the same, node 25, and I will provide an alias to this stage. I'll just call it as builder. Let's choose work directory. Build stage will look more or less the same. Work directory. This time I'll just call it as /build. Then we will copy the package.json first. Abhishek, why do you only copy package.json? I've seen this multiple times. You use the two different copy commands. The first time you copy the dependency file, you run the dependency command, and then you copy the complete source code. I've seen this a lot of times in your playlist as well. The reason is simple. Why I typically do this? is because Docker builds layer by layer. That means this will be a different layer and this will be a different layer. So that let's say your source code is changed. Docker does not have to run the dependencies again and again. Typically, a lot of times, dependencies is the one that takes a lot of time for building. So if you want to reduce your Docker build execution time, make sure you break your dependencies in a different copy command and you take your rest of the source code in a different copy command. Perfect. So as per the concept that we learned in the build stage, we are using npm install. Now we will create a runtime Docker stage. Here, instead of taking node 25, I will take node 25 slim. What is the advantage here? Node 25 slim is a lightweight Node.js image, which will not have a lot of things that your regular Node image has. Are you fine with it? Yes. Why? Because we can go with Node 25 slim or lightweight image, because in this stage, we are only executing the Node.js application, or we are only running the Node.js application. Here we are not building the application, so we don't need a lot of packages that are available in the Node 25. Perfect. And these images are specially created for multi-stage Docker builds. So if you look at Docker Hub, you will find Python slim image, you will find Node.js slim image, which you can use in the runtime environment or runtime Docker build. Perfect. Now, again, we will choose the work directory. This time we can choose /app. Copy. As I told you, we will copy the binary or the artifacts that are created in the build stage. Now, what are the artifacts that are created? In Node.js, artifacts that you create are basically the node modules. Apart from that, we will also copy the app.js, okay, which is our application source code. That's it. We will expose 3000 and finally cmd followed by node app.js. So we will not run node start. We can just run node app.js because we already have the node modules that are the modules required to run this application.js file. Now you will notice when you build this Docker image, the size of the image will be significantly less. Let's see Docker build -t. Now let's call this as multi-stage image followed by dot. Okay. So it says fail to build the computer cache, fail to complete checksum at reference. Copy package.json to dot. Okay, it's a very simple mistake. Basically, we have created a new directory. Like if you look at our pwd, I have created a new directory called multistage, and here I don't have app.js or I don't have package.json, right? So what we need to do, either we will move this Docker file a folder back, or we need to copy app.js and package.json to this folder, right? Only then your copy command works. Let's do that. Copy app.js to this folder. Similarly, copy package.json to this folder. Now let's see. Okay, we will run the Docker file again. This time it should work. It's working fine, I guess. There you go. So we have the Docker image running. Let's see the size of this Docker image. Docker images. Okay. Multi-stage image 79.5 MB. That is straight from 400 MB to 79.5 MB. And most importantly, now the application that we're dealing with is a very small application. It just has app.js and package.json. Imagine when you are working with an e-commerce application or a real-time application, it has hundreds of files. Then it will be more advantage for you in terms of the container image size. So we saw the advantage from 400 MB image size shrank down to 80 MB. So it is typically 20% of your entire size. 400 MB to 80 MB, 80% reduction. Cool. Now, if you think your job is done, let me tell you, your job is still not done. Why? Even now, you have a chance to reduce your container image size and you have an opportunity to use even less packages on your container image. But Abhishek, what packages? Let me tell you, if you exec to this container image, once again, so if you run docker run followed by multi-stage image sh, okay, let me exec to it by taking -it. You will notice here there are a lot of system packages. One example, apt. Why do you need apt in the container image? Okay, if you want to run this container in the production, what is the advantage of apt? Why do you need it? You might say, Abhishek, nobody can install packages using apt. Then what is the purpose? You can just remove it. Similarly, there will be hundreds of packages on this Node 25 slim image. Okay, it's a slim image. It can help you, but still you have hundreds of packages in it which are not needed. A good hacker will still find the ways. If they have apt, they will find the ways some or the other way, hook or crook, to install something on your container and hack your container. Not only apt, I'm talking about /etc folder. There will be hundreds of packages in it. What is the purpose of it? This is where Distroless images can help you. Distroless images are images which not only help you with reducing your image size from app packages point of view, but they can also help you reduce system related binaries within the container. How do you do that? You don't have to change a lot. You can just use the same container image that you used. Only change that you have to make within the Docker file. Let me show you by updating it. Right? From multi-stage to Distroless is very, very small change. All that you have to do within your runtime, right? Here, from Node 25 Slim, go with a Distroless image like this. GCR, Google Container Registry, it has Distroless images, Node.js 20, Debian 12. But Abhishek, why are you not using Node 25? This is one drawback. When you are going with Distroless images, you have to depend on systems like GCR, where Google Cloud or open source contributors, where they are creating Distroless images for you, and they might not keep it up to date with latest Node.js version. So right now we don't have Node 25. Node 20 is up to date, so we can use Node.js 20. So you can keep it the same way. In fact, you can remove Node here and just run app.js, because the entry point for this Distroless image is Node. So even if you have app.js, it will run Node app.js. Let's see. I will save this Docker file. This time let me do docker build -t followed by, let me call this as Distroless or Distroless image demo followed by dot. Okay. Now let's see Docker images. Okay, what is the image size now? From 80 MB, it went down to 52 MB. Further reduction in the size. typically looks like 85% reduction in the container image size. Great. Now let me show you the application works absolutely fine. You might think the container image size is less, so your application might not run. It actually runs. Docker run followed by -p. This time let me use 3002, 3000 followed by Distroless image demo. Okay, let's verify. I'll just do localhost 3002. There you go. Now the application is still running on your machine. Cool. What else? Abhishek, now the application is running. We verified application is running within the Distroless image as well. This is absolutely fine. Your Docker file is now secure. You can even ship this Docker image to production, but there are few simple best practices that you can follow, which can add to what we created till now. A simple best practice that DevSecOps engineers follow is to create a .docker ignore file. So just like how we create .git ignore file, good DevSecOps engineers create .docker ignore file within the repository, right? So within this DevSecOps 0 to hero repository, where we have the code, along with these files, we can also create .docker ignore file. What is the purpose of it? Very simple. In the Docker file, we are usually using copy dot, right? It's a common practice where we use this command. Now, what does this command do? This command usually copies everything within the folder onto the Docker image. So it copies the app.js, it copies package.json. What if? No? What if it accidentally copies the files like .git? Obviously, you have .git on your machine. What if it copies it? Or what if it copies files like .env? What if it copies node modules, right? Even why should it copy Docker file, right? This can only increase the size of your image. You can eliminate that by creating a .docker ignore file. So just create .docker ignore, put it in the repository where you have your source code, and when you run copy ... what Docker does, it looks at the .docker ignore file and it will ignore copying everything that you add to the .docker ignore file. Very similar to .git ignore concept. When you add .git ignore, Git will look at that file and stop tracking the files that are in .git ignore. Similarly, when you add .docker ignore, when you run the copy command, Docker will ignore copying these files onto the Docker image. That way, you can reduce the image size and copying unwanted files to your Docker image. Perfect. Finally, okay, now that the .docker ignore concept is clear and you know how to build good Docker images, let me tell you one simple concept, how to use your Docker run command. But Abhishek, we know how to use the Docker run command. Now we just use Docker run -p followed by the port, or we just use Docker run -it for taking an interactive terminal within the Docker. That is definitely good, but a best way of using Docker run is by passing parameters to Docker run, something like this. These are parameters that I usually recommend. What are these parameters? Very simple. Let me go through each and every parameter. --read only. Something that I highly recommend. What this does, Docker run -read only. That means the process that is running within the container becomes a read-only process instead of write process. But Abhishek, what if my process want to write some information to the local host, or what if it wants to write some information to the host system, you can use -- temporary file system and provide /tmp or any temporary file system, because this will prevent the hackers. If hackers tries to create more volumes, or if hackers tries to create something on the host from the container, this will prevent, because your container is running as a read-only container. And if at all it wants to write something, there is a temporary file system to which it can write. Perfect. Similarly, you can also pass -- drop all and -- security opt no new privileges. Both of them are used typically to ensure your container does not gain any additional powers. A lot of times, as I told you, hackers, they try to escalate the privileges. When they get access to the container, the first thing that they try is to add more privileges to the container, or they try to see if your container has any elevated permissions, so that they can not only hack the container, but they can also get access to your host system. These two parameters, even if someone like a junior DevOps engineer, someone with a lot of security knowledge, even if they get the containers, using parameters like this in your runtime can highly help you secure your containers. On top of that, --PID 100. This is basically to limit the processes. In case someone tries to perform DDoS attack on your container, you can limit the number of processes so that they cannot run more processes on your container. If they run more processes on your container, it will indirectly impact other containers, because they cannot get enough resources like CPU and memory from the host. You can prevent that by limiting number of processes. But Abhishek, what if they try to use a single process and they try to take more resources from the host? What you can do, you can limit your container resources by using --memory and --CPU. So using these parameters, you can tell my container should use only these number of parameters. So these are called hardening parameters, or these parameters can help you enhance the security of your container during the runtime. Once again, all the notes is available in the day 4 folder. Just go through the readme file. I would highly recommend that to you, and also try to practice the commands along with the configuration that I provided in the readme file. So go example by example, use the Docker file, run the commands, see the output, then go to the next step. This way, you will never forget the concepts, and you can become a better DevSecOps engineer. Thank you so much for watching today's video. If you have any questions, do let me know in the comment section. See you all in the next video. Take care. Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 5 of DevSecOps Zero to Hero series, and in this episode, let's focus on securing Kubernetes. In the previous episodes, we learned how to secure Git, how to secure Terraform, how to secure your containers. In the same way, we will learn what are the security best practices when it comes to Kubernetes in today's video. We will cover 6 different topics in the video, starting with what are namespaces and why are they called the first step of security. Then we will learn about RBAC in Kubernetes, where we will learn what is RBAC, what are different components that can help you with RBAC. Then we will learn about network policies in Kubernetes. For example, how can you restrict access to your database that is deployed in your Kubernetes cluster? Then we will learn about advanced policy enforcement. For example, how do you set up and manage your Kubernetes cluster as per the compliance of your organization or as per security requirements? Here we will learn Kyverno. Yes, I will also explain you how to set up and configure Kyverno in today's video. Then we will learn about secrets in Kubernetes. how do you store sensitive information within your Kubernetes cluster. And finally, we will learn how to store your Kubernetes secret references within version control systems like Git, where we will cover a very important concept, external secrets operator. And I'll also explain you how can you integrate external secrets operator with vault provider. So these are the concepts that we are going to learn in today's video. Most importantly, this video is going to be completely practical. So every concept that we are going to learn today will be followed by a demo. And you don't have to feel overwhelmed. All the documentation is covered as part of the Git repository. So this is a GitHub repository that we are using for the series, DevSecOps 0 to Hero. You can find the link in the description as well. If you head to the day 5 folder, you will find a README file. And this README file has everything that I'm going to cover. You can see here, the first section is namespaces, the commands related to namespaces. Then the second section is RBAC, commands, configuration, verification, everything related to RBAC. Similarly, network policies, Kyverno, and even external secrets operator. So after watching the video, I would request you to spend another 30 minutes and practice everything that is covered in the documentation. That way, you can never forget security in Kubernetes. Perfect. So now without wasting any time, let's get started with the first concept for today's video. That is namespaces. So what is a namespace? As I told you, it's a very simple concept, yet very, very powerful. Namespaces in Kubernetes offers the isolation that helps you manage a single Kubernetes cluster across different teams in your company. Let's try to understand this better through a real-time example. Imagine you created a Kubernetes cluster within dev environment of your company. And let's say you have 3 different teams in your company: payments team, shipment team, and scores team. As soon as you create this Kubernetes cluster, let's say you posted on Slack that you created a Kubernetes cluster, and these are the cluster details. The DevOps engineers who are managing the deployments of these teams, they start deploying their containers to the cluster. Now, if you imagine the world without namespaces, the DevOps engineer of the payments team can just deploy their one of the container as pod, other container as another pod, and maybe a config map. Similarly, to the same cluster, the shipments team DevOps engineer deploys, let's say, 2 pods, and the scores team DevOps engineer deploys 2 pods and 2 config maps. Now this looks good to you, but what if after some time, the DevOps engineer of the payments team accidentally deletes a pod and a config map of the scores team? Now this is a big issue because there is lack of ownership on the cluster. Similarly, the scores team DevOps engineer can accidentally delete the pod of the shipments team. This is not only a security issue, but this is also lack of ownership on the cluster. On top of that, you will also start receiving the complaints. For example, the scores team can complain, Abhishek, we have 2 pods and 2 config maps, but the shipments team and the payments team are utilizing 90% of the cluster resources. Now, this is another problem, that is resource utilization. Ideally, you might want each team to utilize 33% of the cluster, or maybe because scores team has 2 pods and 2 config maps, and maybe these pods are very important for your company, you might want them to utilize 40% and other teams to utilize 30% each. How do you define this? That is, how do you define resource utilization on the cluster? Now you can only do these things if you logically break your Kubernetes cluster. One thing is sure, you cannot physically break a Kubernetes cluster because this is not a physical thing. Only thing that you can do, you can logically break the cluster. And this logical isolation is what we call as namespaces in Kubernetes. So when you have 3 teams in your company, you might create 3 namespaces and you might assign 1 namespace for a team. So this namespace is for the payments team, this namespace is for the shipment team, and this namespace is for the scores team. Now the DevOps engineers who are working with deployments, they start deploying their workloads. It can be pods, it can be config maps, it can be secrets or anything. They would deploy their workloads to the relevant namespace. Very simple. Previously, they just run kubectl apply. They would use the same command, but this time kubectl apply followed by -n followed by namespace that is assigned to that team. But Abhishek, okay, this is fine. Now the payments team DevOps engineer would use -n payments. Shipment teams DevOps engineer would use -n shipment. But how to solve the problem with resource utilization? That still exists. You logically break the cluster, but how do you define a particular team or a particular namespace should only utilize, let's say, 30% of the cluster resources? It's actually very simple. So Kubernetes solved this problem using resource quota. So when a DevOps engineer creates the Kubernetes cluster or an administrator creates the Kubernetes cluster, and when they define a namespace, while creating the namespace, they also create resource quota for the namespace. It's just a Kubernetes resource. And within the resource quota, they define the number of CPUs and the amount of memory that a particular namespace can use. So if this Kubernetes cluster has, let's say 30 CPUs and 30 GB RAM altogether, while creating the namespace called payments, they can also define the resource quota and say this namespace should utilize 10 CPUs and 10 GB memory. No matter how many workloads they deploy, it would not exceed 10 CPU and 10 GB RAM. This way, resource quota helps the DevOps engineers or the administrators to maintain dedicated amount of resources for the namespace. Perfect. Now let's see the namespace in action. How do you create a namespace and how namespaces are used in real time? For that, we would need a Kubernetes cluster. My go-to thing is always kind. So I just installed Docker on this machine. Now I'll just run kind create cluster -name followed by, let's call the name of the cluster as keds demo. So you would need Docker running on the machine and you would need kind running on the machine. It just takes 2 steps to install Docker and kind. There you go. So we have a Kubernetes cluster. It's that easy. Now, once we have the Kubernetes cluster, how do we logically isolate it? How do we create namespaces? So we need this command kubectl create ns, which is the shorthand for namespace, followed by name of the namespace. If you want to call the namespace as payments namespace, you can just say payments ns. Namespace is created. You want to create another namespace, just call it as score namespace. Now if you run kubectl get ns, you will find along with the default namespaces, there is a payments namespace and there is a scores namespace. Now let's understand how workloads are deployed to the relevant namespace. For example, DevOps engineer of the payments namespace wants to deploy Nginx within the payments namespace. So they can just use the command kubectl create deployment, or they can prepare a YAML manifest as well. But because this is just an Nginx deployment, I'll show you through the command line. They can just run kubectl create deployment. Name of the deployment, it can be Nginx, it can be Nginx payments, followed by the name of the image, which is important, it has to be right, followed by -n payments. Now you will see here, okay, there should be some typo in the namespace that we created, kubectl get ns. Okay, it's payments namespace. So I have to just change it to payments-ns. Now you will see, if I run kubectl get pods, there are no pods here. But if I just do kubectl get pods -n payments ns, you will see the Nginx pod running in it. The same way, if the Scores DevOps engineer wants to deploy the same Nginx pod within their namespace, they will run the same command, but change the namespace to score-ns. So this is how namespaces are used in real time. But you might have a question here, Abhishek, okay, we logically broke the Kubernetes cluster into multiple parts. But what if, I have a requirement where I want to grant permissions to my pod. I don't want my pod within the payments namespace to do every action that is possible. In Kubernetes, there are multiple actions like creating a config map, reading a config map, reading a secret, writing secret, reading custom resource definition, a number of actions. But I want to restrict my pod only to read the config map. That's it. Nothing more than that. If my pod tries to write a config map to the local disk or maybe to the node of the cluster, this action should fail. How do I do that? Basically, how do I grant permissions to my Kubernetes pod? This is where our second concept comes into picture, that is RBAC. What is RBAC? RBAC stands for Role-Based Access Control. The term RBAC is not limited to Kubernetes. It's basically a security term where it is applied to different tools and different concepts. But in Kubernetes, RBAC is applied using 3 resources. If you know these 3 resources and how to use them, you can master RBAC concept in Kubernetes. What are these 3 resources? First one is service account, shorthand is SA. Second one is role. Third one is role binding. That's it. You just need to understand what are these resources. Let me explain you one by one. First thing is service account. Service account is just like the user account. What is a user account? For example, if I want to log into my laptop, I need a user account. If I want to perform any action within my laptop, I have to log in using a user account. It can be administrator, it can be Abhishek, it can be Veeramalla. Only then I'll be able to do something if I have permissions. But the first thing that I need is a user account. In the same way, in Kubernetes, every pod should run with a service account. Right? A pod in Kubernetes cannot run without a service account. But Abhishek, in the previous example, I created a pod, right, using kubectl create deployment. When I do kubectl get pods -n payments namespace, I can see a pod is running. I did not define service account. Very simple. If you try to edit this pod and see kubectl edit pod, name of the pod, right, and -n payments namespace, you will notice, although you did not provide a service account, Kubernetes assigns default service account. This line here. You can see if you don't assign a pod with a service account, Kubernetes automatically defines the default service account. But this is not a good practice. And this is not what you should do in real time. Every time you create a pod, you should assign the pod with a service account and it should only run with it. But service account is just an account. By default, it will not have any permissions. Just like I can create a user account on my laptop and I can share it with my wife or I can share it with my friends. But if I don't give any permissions to them, they can log into my laptop, but they cannot do anything. The same is with service account. Now, what grants service account some permissions? Basically, that is roles in Kubernetes. What are roles? As the name suggests, role is nothing but you define what a service account or user account can do. So Kubernetes administrators separately, they create some roles. A role can be developer or role can be test user, right? Or a role can be test pod or maybe test pod payments, whatever you would like to define. The name of the role is anything, but here you will define the permissions. Read, write, config map, read, write, secrets, read, write, CRDs. So you will define whatever permissions that is required. But Abhishek, how do we bind a role with a service account? Okay, I created different roles. I'm an administrator. I created a role called developer. I created a role called test user. I created a role called test pod service account. How do I bind the role to the service account? That is where role binding comes into picture. All that role binding does, it will bind a role to a service account. That means administrators create service accounts, administrators create roles, and they bind a service account to a role using role binding, right? Role binding does not have any other use case in specific. It will only map a role to a service account. Now let's see this thing in action as well. If you are confused, when we perform the demonstration, things will be much easier for you. So we will go back to our same Kubernetes cluster and let's create a service account first. So how do we do that? We can run this command kubectl create service account followed by name of the service account. Let's call payments user. Okay. And -n payments namespace. Perfect. Payments -ns. Perfect. So payment service account is created. Now let's grant or let's create a role and let's grant permissions to get and list other pods. That's it. Okay. How do we do that? We will run this command kubectl apply -f and we will use this manifest. Kind is role, metadata, name of the role, namespace. In our case, it has to be payments -ns, right? Followed by the rules that we want to grant this role. So the verbs decide what permissions will this role have on what resources. So the permissions that we are granting, get and list on the pods. Now, whichever user account or service account is assigned with this role, they will be able to get, that is, they will be able to run kubectl get. They will be able to run kubectl to list out all the pods within the cluster. If I change these pods to config map, they will be able to run kubectl get config maps and they will be able to list all the config maps only within the payments namespace. Again, if they try to run kubectl get on a different namespace, even for the pods, their execution will be failed because this role here is only restricted to the payments namespace. Let's create this as well. Okay, we created service account separately. We created role separately. Now we have to bind this service account to the role. How do you do that? We will run this command kubectl apply-f followed by the file that has role binding configuration. The role binding configuration, as you must have guessed, it has the name of the service account and it has the name of the role. What is the name of the role? Pod reader, the one that we defined. Let me just correct the namespaces here. The namespace here should be payments-ns. Similarly, payments-ns. That's it. We are good enough now. Let's do this. Okay. So now service account is created, role is created, role binding is also created. Let's verify if the service account called payments user can get the pods within the payments-ns namespace, which should be successful because we granted the access. This is the command to verify the permissions. kubectl auth. Can I list pods as payments user service account in the payments-ns namespace? What should be the output? It should be yes. There you go. Now, if I try to see, okay, instead of list, if I change this to kubectl auth, can I create pods? The output should be no. Similarly, if I run kubectl auth, can I delete pods? Again, the output should be no. Even if I do kubectl, can I get pods within the payments namespace? You would see yes. But if I change the namespace, okay, from payments namespace, if I just do something like score namespace, you would see the output again as no. Why? We created the role, but the role is restricted only to the payments namespace. Using this payments user, if you try to perform actions in a different namespace, your execution will fail. But Abhishek, what if I want to, grant my pod? In this case, if I want to grant payments user to read pods across all the namespaces in the cluster, should I create multiple roles for it? It will take a lot of time. You don't have to do it. Kubernetes also supports something called cluster role. So in that case, you can create a cluster role and cluster role binding. Basically, role and cluster role are almost the same, but role is limited to a namespace. Whatever permissions that you want to give in the role, they will be limited to a particular namespace. If you want to grant permissions across the cluster, across all the namespaces in the cluster, you would go with the cluster role. That's the only difference. Perfect. So this is how RBAC works in Kubernetes. And you should definitely implement RBAC. This is one of the most important things that you have to do. Whenever you create a Kubernetes cluster, create namespaces and create RBAC for the service accounts that you use. Without this, your Kubernetes cluster will be a security mess. Anyone will be able to delete other pods. Anyone will be able to create config maps, read secrets, which is a security issue for your organization. Okay, now that you learned about namespaces and RBAC, let's go a step ahead. Let's learn about a very interesting concept, that is network policies. I'll explain this to you in very simple words. Imagine you created a Kubernetes cluster. Whenever you create a cluster, the Kubernetes cluster is set up with internal cluster network. That is, all the pods in the Kubernetes cluster can by default talk to each other. This pod can be in the payments namespace. This pod can be in the scores namespace. Because they share the internal cluster network, they can talk to each other using curl, or maybe the payments pod can make an API request to the pod in the scores namespace. Let me show you as well. Now, if I just do kubectl get pods -a, that is pods in all the namespaces, followed by -o wide, you will notice this is the pod in the payments namespace. This is the pod in the scores namespace. They share the same CIDR block. This is 10.244.0.6, 10.244.0.7. They are in the same network. So now this payments namespace pod can ping the scores pod, or maybe make an API request to it, which is a huge security issue. Maybe not for every company, but for certain companies it is. Why? Let's take the classic example. There is a front-end pod in the login namespace. There is a backend pod in the, let's say, score namespace, and a database in the DB namespace. Now, backend talking to the database, it's absolutely fine. It's a very common scenario. But front-end talking to the database should definitely be blocked. Otherwise, any potential hacker or a bad actor who has access to the front end can penetrate and access to the database. Or if your front end pod is compromised for any reason, through the front end pod, the hacker can penetrate and access the DB pod. Maybe make a curl request to it or gain access to the database and steal information from the database. How do you prevent this? As I told you, front end and DB or any other pod, they share the same cluster network. What you need in this case, ideally something like firewall, right? Something that protects your DB pod. But firewall becomes complicated. What Kubernetes does, Kubernetes supports even a better solution called network policies. How does network policies work? So you can define access to your pods. In this case, you can define access to your DB, that is, who can ingress to your DB. Which pods should only have access to your DB. You can even control egress access. If you try to make request from your DB pod, the request should be blocked. Or if someone tries to make request from the front end pod, anything, someone got access to the front end pod, they try to run a curl command, they try to run the ping command, you can block egress access or outgoing network access from the front end pod. You can do all of this using Kubernetes network policies. Of course, I made a very detailed video on the network policies, but still, because we are talking about security, I will show you this through a very useful demonstration. So what we will learn, how to set up network policies. Unfortunately, when you are using kind cluster, by default, kind is not capable of network policies. So we will install Calico in the cluster. Calico is basically a Kubernetes network interface that helps us set up network policies. And then we will take the scenario of almost the same thing, a front-end pod, attacker pod, and back-end pod. So our goal is very simple. Attacker pod should not be able to make even ping request to the backend pod. But if front-end tries to connect to the backend through a ping or something, this request should go through. Let's try to see this. One more time. We will create 3 different pods, front-end, attacker pod, and the backend pod. Front-end pod should be able to make request to the backend pod. But if we try to even make a ping request from attacker pod, it should be blocked, although they are in the same network. Firstly, I'll show you without network policy, right? So we will install a Kubernetes cluster that we already have. We will set up Calico in the cluster as the next step. We will deploy 3 pods. I'll show you first without network policy that attacker pod can talk to backend pod. Then I'll install the network policy to show you how to block the access. Perfect. We already have the Kubernetes cluster. I will create something called the payments namespace, kubectl create ns payments. The documentation has commands related to the payments namespace. That's why instead of modifying every time to payments-ns, I just created the payments namespace. It will be also easy for you. You can run the same commands from the docs. First, let's create the front-end pod. We will use this command here, kubectl run frontend -- image busybox. So I have taken a very simple busybox image. We are running the front-end pod. I attached labels to the front-end pod. Role front-end. Abhishek, why are you attaching labels? Because when it comes to the network policies, you block the access only using labels or annotations. I will use labels here to block the access in the future. That's why when I'm creating the pod, I'm creating the pod along with the label. So front-end pod has the label called role front-end. Okay, so this should create front-end pod for us. Now let's create attacker pod. So this is the attacker pod, kubectl run attacker -- image busybox -n payments. If you notice here, I did not add any label to the attacker pod. It's just like any other usual pod. Then I will also create the backend pod. Kubectl run backend -- image nginx, and I have added label to the backend pod as well. Very simple. I added label to the front-end pod and backend pod. I did not add any label to the attacker pod because network policies work with the labels. Now let's expose the backend pod. That is, I'll just create a service for the backend pod so that we can easily make curl request to the service. Perfect. So we created a service for the backend pod as well. Now we will just verify all the pods are created and running. Kubectl get pods -n payments. There you go. All the pods are running. Kubectl get svc -n payments. So you can see the backend service. The reason for creating service, if I use the cluster IP, using the pods, a pod can go down for some reason. During the demo, if the pod goes down, our curl request might fail. That's why to use a stable IP address or maybe to use a stable DNS, I created service. Otherwise, we can also use the backend pod IP. There is absolutely no problem. Step 1, I'll connect to the attacker pod, kubectl exec -it attacker pod -n payments. I'm taking shell to it. Now, firstly, I'll show you we did not create anything, in the sense we did not create any network policies. I'll just run this command wget -qo backend svc. From attacker pod, I'm trying to connect to the backend pod. Let's see what happens. Request went through. Welcome to nginx. That means attacker got access to the backend pod. Of course, even front-end pod will be able to connect to the backend pod. Now let's see network policies in action. So firstly, I will install Calico on this cluster. So this is a command to install Calico. It's also in our documentation. If you are using EKS cluster on AWS, you would not need Calico even, because your EKS cluster will be set up with the VPC CNI, and VPC CNI already has support for the network policies. If you're only using kind local Kubernetes cluster, you would need this step. Okay, all the CIDs are installed. The Calico CNI is set up. Now I'll install network policy. So I'll run this command kubectl apply -f followed by the network policy manifest. Let me walk you through the manifest. So what are we doing here in the network policy? So we are saying allow only specific traffic. This is just the name of the network policy. You can grant anything. Here we are defining the pod selector. What is the pod selector? I am saying this network policy should only be applied to the pod which has the label app my app. If you remember, we use this label on the backend pod. I can quickly show you as well. kubectl get pods -n payments. So this will list all the pods for us. If I just run kubectl edit pod backend -n payments, you will notice backend pod only has this label called app my app. So that means the network policy that we are creating will be associated with the backend pod. Okay, so we defined which pod should the network policy be associated with. Then policy type. Which policy type? Ingress is the policy type. That is, inward traffic to the backend pod should only be allowed from the front-end pod. The pod that is assigned with the role front-end. Any other pod which tries to access the backend pod, ingress should be blocked. That is, the incoming traffic should be blocked. Let's see if this works out. There you go. Network policy is created. We'll replicate the same steps. I'll again exec to the backend pod using the same command kubectl exec, the attacker pod, kubectl exec -it attacker pod. Now let's run the same command. You will notice the access is blocked. There is no response back. Even if I try to do ping followed by backend SVC, the ping is also not going through. The ping is also blocked. On the contrary, if I try to run the same command, now I'll switch this to the front end pod. Okay, -xt front end. I'll run this command wget. You will see the response. There you go. This is how network policies work in real time, right? So we understood the concept theoretically and practically. If you want to block access to certain pods, or if you want to define egress access from the pod, what you need is network policies. Best use case is database pods or the backend pods. But Abhishek, what if, on top of the usual network policies, I want to define strict policies within our company, right? Our company has very strict policies. For example, anyone who deploys a pod on the Kubernetes cluster, or anyone who deploys deployment on the Kubernetes cluster, should not use the latest tag. I'm sure you know the consequences of using latest tag. Otherwise, let me explain you. Let's say you deploy MySQL pod with the latest tag. Every day, this tag keeps changing, right? So you have deployed MySQL with the latest tag today. This might be working, but tomorrow, the developers of the MySQL, maybe at 12 AM in the morning, they might update the latest tag, and now the latest tag is pointing to different version of the application, right? That is what the purpose of the latest tag. Latest is always up to date. Today, the MySQL version might be 16. Tomorrow, the version is 17. But you are not using the version number as 16 or 17, but what you are using is the latest tag. That means yesterday latest point was pointing to version 16 of your application. Today the latest tag is pointing to version 17 of your application. This is a major problem in production because yesterday your application might work perfectly fine in the production. Today it might break because of the breaking changes in the 17 version. Of course, applications like MySQL, most of the times they are stable. But take example of your internal applications. They can break with the new versions. Maybe because of lack of testing, or maybe because of lack of verifying certain features in the application. So using latest tag is a very bad practice. And your organization has this as a compliance requirement. Even if a developer accidentally tries to use the latest tag, the deployment should fail. How do you do this? How do you enforce policy within the cluster? This can be achieved using tools like Kyverno. So Kyverno helps you enforce policies using admission control. Now, admission control is a very big concept in very simple words. We have complete video on admission control and even Istio as a service mesh using admission control. But because we need to know the concept at a high level at this point, let me tell you, admission control is nothing but Kubernetes allows you to perform admission control, that is for validation as well as mutation. So whenever you deploy a pod or you deploy a config map, you deploy a service, if you create an admission controller in the Kubernetes cluster, you can validate the resources or you can mutate the resources. Validation is nothing but you can verify. Okay, if developer creates a pod in Kubernetes, using the validation admission controller, you can check if the pod, if the image field in the pod is using latest tag. If it is using, you can block the pod. You can stop creating the pod. In the same way, Kubernetes also supports mutation admission controller. If you create a mutation admission controller, every time a pod is created or every time a config map is created, maybe you can automatically add certain labels to the pod, or maybe you can add annotation to every pod that is created in the cluster. So this can be achieved using admission controllers. Once again, admission controllers are of two types. You can create validation admission controller. You can create mutation admission controller. But Abhishek, I don't know how to create these admission controllers because I don't know how to develop a controller in Kubernetes. That is where Kyverno comes into picture. Kyverno says, you don't have to learn this. Just install me on the cluster and tell me what type of admission control that you need or what type of policy that you want to enforce. Do you want to enforce the latest image tag on the cluster? No problem. Just install me. Tell me that you are looking for a validation admission controller and you are looking for blocking pods with the latest image tag. I will do it for you. And it's very simple. Let me show you the steps, how to install Kyverno and how to perform policy enforcement. Once again, these commands are in the documentation as well. First, run this command kubectl apply followed by Kyverno install manifest. Now this will install a lot of CRDs for you. Most of these CRDs are related to admission control. Just verify the Kubernetes Kyverno is installed on your cluster. kubectl get pods -n Kyverno. Now if you notice, the pods are still in the running state. Wait for all the pods to be in the running state. Now you have to wait for this. Otherwise, when you run the next commands, you might not see the action as complete. So I'll just do -w so that I will wait for the pods to be running. There you go. It looks like the pod is initialized. In the next few seconds, we should have pod in the running state. Perfect. Now, the final step is to create the Kyverno resource. Now let's create a complete cluster policy. Okay. So this is a policy that I'm going to create. Disallow latest tag, just a random name that I provided. But what's important? Validation failure action. And this is enforce. So we are using Kubernetes for validating webhook or validating admission controller. And what does it actually validate? It is checking if any pod will be created with latest image tag. If it is created, it will fail the pod with the message image tag latest is not allowed. Let's create this first. Okay, the cluster-wide policy is created. Now let's test Kyverno. We will create a pod. Again, we will use the same payments namespace. I will create a bad pod here. kubectl run bad pod, just the name of the pod. If you see, I'm using --image nginx latest in the payments namespace. Ideally, if what we learned is right, Kyverno should block this pod. There you go. It says, hey, I will not allow the creation because what you are trying to do is image tag latest. Even before, if I do kubectl get pods -n payments, you will notice the bad pod is not even created. That means admission control is working even before your execution. It just verified if you have access to the cluster. Okay, you have access to the cluster. Then you are trying to create a pod. Kyverno came into picture or admission controller came into picture. It tried to run the validation webhook and it verified. Okay, you cannot create nginx with the latest tag. You can create nginx with v1, v2, anything. But you cannot do it with the latest tag. That's why I will block the access. And there you go. It blocked the access as well. It did not create nginx pod with the latest tag. You can try something else. Okay. So let's say you try to create nginx v1. Now this might not exist. Your image might run into not valid image or image pullback off. But at least I want to show you, in this case, Kyverno will not block your request. There you go, pod is created. Even if you try to do this action in the default namespace, even there, Kyverno will block your request because it's a cluster policy. Across the cluster, this action is blocked. This way, you should make use of Kyverno in your organization. Now, this has become very important in the recent times because companies today have a lot of compliance requirements. Not only latest tag. You can say that a pod cannot be created without resource requests and limits. A pod should definitely have things like, very simple things. For example, health check, liveness probe, readiness probe. So you can define anything that is mandatory in your organization and block otherwise with Kyverno. Perfect. Even I have complete video on Kyverno. If you want to verify more actions, if you want to deep dive into Kyverno, you can just go through my Kyverno deep dive video. But at least this information is enough if you are getting started with Kubernetes security. Now we learned about policies. Now let's move to a different concept, a very, very simple concept. Till now you learned about slightly complex topics like the RBAC, network policies, admission control. Now let's go to a very simple concept, that is secret management. Now we all deal with secrets on day-to-day basis. For example, we deal with passwords. We deal with API tokens. We deal with certificates. We deal with PEM files. How do you manage them on the Kubernetes cluster? Obviously, if you are using them on your virtual machine, if you're using them on your laptop, when you deploy your application to Kubernetes, you have to deal with these resources as well. How do you do that? This is where Kubernetes supports a resource called secrets resource. The same name, right? Your secrets are managed in Kubernetes using Kubernetes secrets resources. All that you have to do, if you want to store a password in Kubernetes, maybe you deployed a pod and this pod needs database password. So your backend pod wants to access the database pod, but for accessing the database part, it needs the database password. You cannot hard code that in your application. It's a very bad practice. So what you do, along with the pod, you create a secret resource. And within this secret resource, right, which is basically a manifest, within this manifest, you provide the DB username and the DB password. Now within the pod, okay, once you create the secret resource, within the pod manifest, you read this secret as environment variable. That's it. Now the pod has the DB username and DB password within its environment variable, so it can access the information. Let me show you this in action as well. So first of all, we will create a DB secret. So you will do that using kubectl create secret. Whenever I'm using secret or whenever I'm using create mybad, I can actually use a manifest as well. But to make it simple, I'm using the CLI commands. kubectl create secret, generic secret. The name of the secret is the DB secret. Hyphen literal. The username is admin. Password, let's say the password is strong password 123 or password is Abhishek123, anything. And let's create this in the payments namespace. Okay, now the secret is created. How can this secret be read by a pod in this namespace? For that, when you create the pod, let's say this pod wants to read the secret. This is in the payments namespace. All that it has to do, it has to provide the environment variable field. So now this pod will have an environment variable called DB user. From where does it get the DB user? It gets it from the secret reference name. Secret key name of the secret is DB secret. And within the DB secret, the username is with the key username, right? And similarly, from where does it get the DB password? Get the value from a secret called DB secret. And within the DB secret, use the field called as password. But Abhishek, when I do this, will a secret resource be created and will it have fields like username and password, the ones that I provided? Yes. You can also verify if you do kubectl edit secret followed by name of the secret, DB secret -n payments, you will see this is a secret manifest, and within the secret manifest, you have username as a field, password as a field. That's why when we created the pod here, or when we are creating a pod here, we are referencing the username and password field from the DB secret. And that is using the values from secret key reference. This is the same syntax that you have to use. In any pod, in any namespace, the syntax will remain the same. You are reading the secret as an environment variable. The name of the secret is the DB secret. And within the DB secret, the username name is username and the password name is password. Perfect. Now let's see what happens. Dev namespace is not found. Okay, that's expected. I'll change the namespace here to payments. There you go. Secret is created. Now let's look into the pod. I'll just exec the pod, kubectl exec -it. Name of the pod is secret demo -n payments -sh. Now if I just do env here, you will find the username and the password. There you go. DB user is admin, and you will also find the DB password. Somewhere here, you should see the DB password. There you go. So this is the DB username. This is the DB password. Username is admin. Password is strong password 123. This is how secret should be created, and secrets should be read within the pods. I'll repeat this one more time. When you have secrets in your Kubernetes cluster, or when you want one of the pod in the cluster to get some secrets like the DB secret or API token, first step, create a secret resource in Kubernetes. When you create the secret resource, within the secret resource, provide the username, provide the password, and then create the pod. Within the pod, use environment variables. Let's say you want to use the read the username. Read that within the username environment variable. How do you do that? You will use this field called secret reference, the one that we used here. Secret key reference, name of the secret, and field name in the secret. Similarly, if you want to read the password, provide the name of the secret and password reference in the secret. That's it. But Abhishek, are secrets really secure? Because, end of the day, you are storing secrets within a file. Are these files encrypted? The answer is no. When you create secrets in Kubernetes, they are not encrypted. They are only encoded in Kubernetes. That is, they are encoded as base 64 values. Now, this is a problem. Because your secrets are base 64 encoded, anyone that has access to your namespace, they can use kubectl edit command. So if they have access to your namespace, if they have access to all the resources in your namespace, they can just run kubectl edit command and they can read the secrets, which is a problem. And even, okay, Abhishek, I'll block access to the secrets. I'll implement RBAC, right? By implementing RBAC, I will not allow anyone to perform kubectl edit on the secrets resource. That's a good move. In fact, that is very good thing that you can do. Create RBAC and block access to any secrets using kubectl edit. But still, what if you want to store secrets in Git? Which is a valid thing, right? Just like how do you store your pod definition, or how do you store your deployment manifest? How do you store your config manifest? In the same way, if you are implementing GitOps, or if you are implementing deployments through Git, how do you store secrets in Git? Now, this is a big challenge. Kubernetes does not solve this inherently. What you need to do, you need something like ESO, that is external secrets operator. But Abhishek, what exactly is the problem? I still did not get it. Why can't I store my secrets in Git repository? Now, if you take the same secret here, right? You run kubectl edit secret, you copy this and you put this in a Git repository. You think this is secure because Abhishek, nobody can understand what my password is. This is in some random string. Just copy this. Okay. Anyone from the Git repository can copy this. They can run echo followed by base 64. They'll just run this command base 64 --decode and they can see your password. strong password 123. This is what I'm talking about. Kubernetes secrets are not secure by default. They are only base 64 encoded. So if you store them in the Git, any person who knows Kubernetes, they know they're only base 64 encoded. They'll copy the value and they will run base 64 - decode. How do you prevent this? So what you will do, you will install external secrets operator on your cluster. How does this work? So this works with 3 simple steps. First thing, you will install secret providers like Vault. What is Vault? Vault is a safe place. Instead of storing your secrets anywhere, you will store your secrets in the Vault. Vault can be HashiCorp Vault or any other implementation of the Vault. You will install Vault on the cluster where you will start storing your secrets. It can be your DB password, it can be your API tokens, anything. Step 2, you will add Vault as your secret store. That is, you will tell external secrets operator, hey, Vault is my secret store. All the secret values are in the Vault. And finally, you will create a manifest called external secret. What does this external secret have? It does not have the secret. It just has information of the Vault reference. That is, my secret is stored in the Vault and it is stored with a particular reference name. So in the external secret, you will only have the reference name. Nobody who checks your manifest in the Git knows what does this reference name mean. They can find the reference name. They don't know where is your Vault. They don't know what is the real username and password in the Vault. Only external secrets operator can understand this external secret manifest. It will read the reference because it knows your secret store is Vault. By reading it, it will go to Vault and it will fetch the real username and the password. And it will store those values in the Kubernetes cluster. Right? Very sophisticated approach, but 3 simple steps. First thing, install Vault, start storing your secrets within the Vault, add Vault as your secret store to ESO, and then instead of storing your username and password in the Kubernetes secret directly, what you can simply do, you will create a manifest called external secret manifest where you will have the references of your Vault. You will say, my secret is stored in a particular path of the Vault. Only external secrets operator understands it. It looks at the reference. Okay, it knows this path should be searched in the secret store, that is Vault. It will search it in the Vault and it will get the exact values and store the values in the Kubernetes cluster. So you can happily store your external secrets YAML file in the Git repository. Now let's see this in action. When you see this in action, you will understand this better. First step, I'll simply start with installing external secrets, right? Installing external secrets, we will do it using Helm. This is the repo for external secrets operator. Let's add the Helm repository. If you already have the Helm repository, in my case, I already have it. I'll just update the Helm repo. Now let's run the Helm install command to install the external secrets operator. We added the repo. Now let's run the Helm install command. There you go. The install is successful. Let's verify. kubectl get pods -n external secrets. The container is still in the creating state. Like I told you during Kyverno as well, please wait while the pods are in the container creating status. They should be in the running status. Let's recheck. There you go. So the pods are in the running status. Now the second step, let's install Vault. Installing Vault on Kubernetes is very simple. You just need this manifest. We have this manifest in our Git repository as well. Just run this manifest. What is it doing? It is creating Vault namespace, and then it is just installing the Vault 1.15 image. Usually when you try to set up Vault on a virtual machine, you might have to run set of commands. But on Kubernetes, we will just run a simple deployment manifest and then expose the Vault if you just want to access the Vault through the UI. If you don't want to access Vault through UI, you can skip this step. In my case, I'll do everything from the CLI. So I'll just stop the Vault. But this was just to show you, you can also access it from your browser and perform the steps from the browser. Cool. So we installed ESO, we installed Vault. Now the next step is to add Vault as the secret store, because we have to tell external secrets operator our secrets will be stored in the Vault. How do you do that? First, let's just exec to the Vault pod, the pod that we created. Okay, here how do you do that? Run this command kubectl apply -f. And I'm just trying to make it simple for you instead of taking the manifest from official documentation. I try to put everything in our GitHub repository because these manifests are not very important for you. You can get this from any sources, the official documentation, ChatGPT. What's important for you is to know the concept. So this is the secret store manifest. And here I'm configuring Vault as the secret store. Vault is running on port 8200. I'm just providing the location of the Vault pod. Cool. So this should add Vault as the secret store. So we are done with both of these steps. Now we will just store a secret within the Vault. Okay, because we want to read the secret from Vault in the external secrets. So first, let's store a secret in the Vault. How do you do that? We will exec to the Vault pod, or instead of this, you can even access Vault from the UI. Two things. If you are a CLI guy like me, do it from the CLI using Vault CLI command. If you want to do it from the browser, just use port forward and access the Vault through the UI. Now you just need to export the Vault IP address and provide the Vault token as root. This is for connecting to the Vault instance. Now using this command, that is Vault KV, we are creating a key value pair in the Vault. Put secret called DB secret. The location of the secrets is secret/payment/DB. This is within the Vault. This is a folder and this is another folder where you are storing a key value pair called key is username and value is the password, where the username, key is username, value is admin, key is password, and value is super secret 123. Basically, we are storing two key value pairs. This is one key value pair. Username is the key, password, value is the admin, my bad. Username is the password, key is the password, and value is secret superstar 123. Sorry for the confusion. This is the key, this is the value. This is the key, this is the value. We are creating two key value pairs here. Okay, now both the key value pairs are stored. Finally, let's try to create an external secret. How do we do that? Again, it's just a manifest. In Kubernetes, whatever you do, you only use the manifests. kubectl apply -f followed by external secrets manifest. One more time, why are we using this external secrets manifest? Because you cannot directly store secrets in Git. Now you can take this external secret and store it anywhere you want. Even if someone asks you, hey, I want to just know the DB username and password, I am the right person. Tell them, take this external secret. If you are the right person, deploy this on your Kubernetes cluster. We already installed external secrets on the cluster. It will take the username and password and it will create secret on the cluster. It will figure out. You don't need to get the username and the password. And as we learned in the external secrets, what are we doing? We are saying secret store reference is the vault, and within the vault, there is username within payments DB folder. There is password within the payments DB folder or the path. This is the path for the username and this is the path for the password. Where? Within vault secret store. Cool. Let's also install this. Now let's verify. I haven't created any secret, right? Now if I do kubectl, right? kubectl get secret -n payments, you will see there is a DB secret. And what is the value of this DB secret? Let's verify that. kubectl edit DB secret or secret / DB secret -n payments. There you go. So our username for the DB secret is provided and even password for the DB secret is provided. You don't have to do anything. External secrets will create this secret for you. Even if you try to delete this secret, again, external secrets will create the secret for you. Now in the pod, instead of mentioning directly the username and password, you can even provide a reference of this external secret. So this is how secret management is performed in real time. A lot of people stop their learning at the secrets, which is also good. In Kubernetes, secrets can also help you store the sensitive data if you're using it with a strong RBAC. Even after using the strong RBAC, if you need to store your secret in a Git repository, what you need is external secrets operator. Perfect. So this is how good DevSecOps engineers secure their Kubernetes cluster. We learned about 6 practices in the video. We started with understanding namespaces. Then we learned about RBAC. Then we learned about network policies. Then we learned about Kyverno, dynamic admission control. We learned about secrets and external secrets operator. I hope you found today's video informative. If you have any specific questions, do let me know in the comment section. Also, there are complete implementation videos for most of these concepts. If you want to learn, go to our Kubernetes playlist. If you go to the channel, you will find multiple playlists. Go to the Kubernetes playlist. You will find most of the Kubernetes concepts there. See you all in the next video. Take care. Hello everyone. My name is Abhishek and welcome back to my channel. Today is episode 6 of DevSecOps Zero to Hero series. And in this episode, we will focus on SAST, SCA, and DAST. 3 pillars of application security. And most importantly in today's video, we will learn these concepts practically. And you don't have to worry. After watching today's video, if you want to practice the concepts, you can head to my GitHub repository, DevSecOps Zero to Hero. Head to the day 6 folder for today's video, where you will find a README file. And within the README file, I've created everything that you need. So it covers the theory part and also it has all the demos that I'm going to perform in the video. Perfect. So without wasting any time, let's start with the video. First of all, what is application security and why is it important? To understand this better, let's look at a simple application development lifecycle. Now, a very, very basic application development lifecycle. So there are 3 important phases. Number 1 is the dev phase, where developers work on writing the source code of the application. And they also test the application locally. Then comes the test phase, where QA engineers they rerun the unit test cases just to verify the unit tests are passing. And they also run something called as regression testing or functional testing. Very simple. Let's take e-commerce application as example, as we all use e-commerce on day-to-day basis. What happens in regression testing? The QA engineers verify if the complete user flow is working as expected and all the features of application are working together well, or there are any issues. For example, a user is able to log in, user is able to look for the product, search a product, then add the product to the catalog, perform the payment, and get the application shipped there to their location. So this is what the QA engineers verify in the regression testing or functional testing. And finally, if everything looks good, QA engineers do the go ahead so that application is shipped to production. As I told you, this is a very basic application development lifecycle. Now on paper or at a very high level, this actually looks good because application is tested locally by the developers. Then QA engineers also performed unit testing. At their end, they performed regression testing. They verified application features are working fine. And only then application is moved to production. But if you see in this entire workflow, security of the application is not taken into consideration. Now, developer might have taken security into consideration while writing the application, but who knows? There is a possibility that developer might have overseen some use cases, or developer might have ignored certain security considerations. In this entire application development lifecycle, the security testing is not performed, which is actually very important because now application might work well for the end users, but a bad actor can actually attack the application and maybe gain the access to the database, gain the access to the user's information in the database, and even maybe bring your application down in the production. What not? Because the security testing of the application is not performed. This is where application security or AppSec comes into picture. And AppSec is one of the most important pieces of DevSecOps lifecycle. So what a good DevSecOps engineer does, along with the regular workflow, a good DevSecOps engineer brings application security tools or concepts like SAST, SCA, and DAST into the organization. If the organization already has a CI/CD pipeline, to the existing CI/CD pipeline, a DevSecOps engineer introduce these tools and concepts. But Abhishek, in our case, our QA engineers also perform penetration testing. They perform different types of testings like performance testing as well. But still, that does not come under security testing of the application. As QA engineers, they might use some tools for penetration testing. They might use tools for performance testing, but those tools are not designed for the security testing of the application. Now, what is security testing? Okay. Now, I have been saying the application should be tested from security point of view, but what are some common use cases? I'll give you very, very simple use cases so that you understand them well. As simple as, what if one of the developers hasn't taken care of SSL certificates well? One of the developers while writing the application has used some insecure certificates, right? Or maybe disabled security verification of the SSL in the application code so that security is skipped and application can easily talk to the other applications without considering security. Or maybe developer who is working on application hard-coded some secrets. The peer who is reviewing, another developer who is reviewing the code might have overlooked into it. And common cases like SQL injection. SQL injection is very difficult to detect at times. As a human, if you are reviewing other developers' code, you might skip SQL injection. You might not see it because hackers have their own ways of injecting things into your SQL queries and getting access to the databases. You definitely need some tools to verify if there is a possibility of SQL injection patterns. On top of that, there can be some insecure libraries, right? Very common thing. Maybe developer is using Flask and developer is using 1.2 version of the Flask. What if this version is vulnerable? Now, this version already has some critical vulnerabilities reported on the internet, and your developer did not know about it. Even somebody is reviewing the code, they might not know about it. Definitely, QA engineers will not be aware of this vulnerability with a particular version because there will be thousands of packages that developers use in their code, right? These are some cases, right? When we move forward in the video, you will learn about other cases as well. But these are some common cases. And if you're working with JavaScript applications, cases like CORS, right? Cases like CSRF. Again, these things are very difficult to figure out in the manual code review process. That's why security testing is important. Now, there are three important pieces. One is SAST, other is SCA, and finally DAST. How does these concepts help in the application security part? Let's go by one. First one, SAST. SAST is basically static application security testing. That means in the SAST testing, if you're using any tools, for example, SonarQube is a very popular tool in this space. So when DevSecOps engineers use SonarQube and when they connect their application to the SonarQube, what SonarQube does, it goes through the source code of the application and it looks at the source code to understand, because it's a tool, it also comes with some AI capabilities. It has a database of known patterns. With all of those things, the tools like SonarQube can say if your application is potentially exposable to SQL injection. It can say if there is any insecure SSL verification used in the application, if there is any issues with weak cryptography, right? Or if your developer is using any insecure modules, it can be even as simple as an insecure YAML module, or maybe hard coding of secrets. All of this can be caught by the SonarQube. Now, this is a very interesting space. A lot of times interviewers ask you, okay, you used SonarQube, but what exactly are the common issues that you caught in the application using SonarQube, or the common cases that SonarQube helped your organization with? The reason why interviewers ask you this question, interviewers feel you might have learned SonarQube from some places, but you haven't implemented SonarQube in real time. Now, how do you tackle this situation? Don't worry. Because this is a common case, I've documented popular SonarQube cases in our MD file. So these are 10 popular SonarQube use cases that are used in the DevSecOps space. Hard coding secrets, SQL injection, command execution risk, insecure deserialization, arbitrary code execution. You can go through them after watching the video. But what I'm trying to say here, SonarQube or static application security testing is a way where a tool can help the DevSecOps engineers go through the source code. It goes through the source code and it identifies any common patterns of insecure behavior in the application. Then comes SCA. Now, what is SCA? Very simple. SCA stands for Software composition analysis. As the name suggests, what exactly it does? It looks at dependencies of the application, right? It looks at what direct dependencies is the application using and indirect dependencies that the application is using. Very simple. You might be using Flask, but Flask internally might be using 100 dependencies. You might be using a particular version of the Flask. You feel you are using the right version, but even because Flask is using insecure dependency, your application will be indirectly exposed to the threat. So you should not only look at direct dependencies, but you should also see if any of your indirect dependency is potentially exposable to the security threat. But Abhishek, this is very difficult because I'm using a Python application. In the Python application, I'm already using 1000 dependencies. That means these 1000 dependencies, each of them might be using 100 dependencies internally. So it becomes 1000 times 100. So technically 100,000 dependencies in my application. I'm just making up this number. Usually it's not this huge. It might come around 1000 to 2000 dependencies. But yes, you have to ensure that direct dependencies and indirect dependencies are secure for your application. You cannot do it as a human. It's not possible. This is where SCA comes into picture. Software composition analysis, where every programming language has some tools. For example, in today's video, we will look at a Python application, which I intentionally I'm using old versions or deprecated versions in the application, and we will use a Python utility that can help us. That will show us the dependency issues in the application. Similarly, Golang, Java, every programming language has their own set of tools. Abhishek, can't SonarQube do it? It can do it to some extent, but it is always good if you rely on the SCA tools rather than relying on SAST tools for dependency tracking. Perfect. Finally, DAST. Very, very important. It's actually simple concept, but it's important. What is DAST? Dynamic Application Security Testing. It actually does similar thing like SAST, but only thing is that DAST is about runtime. In SAST, a tool goes through the source code of your application and it looks at the common vulnerability patterns. But when it comes to DAST tools, they don't look at source code of your application. In fact, they don't need any source code of your application. What they do, they just need URL of your running application and they start performing different testing on the running application. So they make thousands of API calls to your application to verify if there are any known security issues with your application. Why is DAST very important? Because this is how hackers also work. What hackers usually do, let's say you have an application and your application is running on the internet. Now hackers do not have your application source code. They just take a browser and they start hitting your application for different patterns. If your application is an e-commerce application, they'll try from logging into the application, they'll go to one product, they go to the other product, they try to make API calls to your catalog service. They are not sure, right? Which part of your application is vulnerable? They are not sure because they don't have the source code. But they figure out that by making thousands of API calls. And they make those API calls on hundreds of websites. Even if one website, one flow of the one website is hackable, their job is done. They figured out one website and it's good for them. They can get ransom from those websites. The same way DAST tools also work. You can deploy a DAST tool in your organization. If your organization has 3 different websites, maybe internal, external, another external, give your DAST tool, chase the URL of all these tools. all these websites, I mean, and it will make hundred thousands of API calls, and it will figure out, okay, in this application, there are 10 known patterns for the hackers. In this, there are 5 known patterns. In this, there are 4 known patterns. It's up to you. Do you want to fix it or not? But my job is to report the issues to you. And as I told you, in today's video, the DAST tutorial is going to be very interesting. I have a demo e-commerce application, a cool one, which is almost like a real e-commerce application. It has all the flows, including login, including payments, everything. So we will use that application and we will use a DAST tool to show you how the DAST tool can figure out the patterns. Perfect. I'll repeat one more time before I go to the demos. Very shortly, right? What is SAST? So we learned there are 3 pillars of application security testing: SAST, SCA, and DAST. What is SAST? SAST is nothing but static application software testing. That is, a SAST tool just goes through source code of your application. It identifies all the known patterns in your application. This is basically part of static code analysis. SAST is a sophisticated area or a particular area of static code analysis where tools perform static testing on the apps. And popular tool in this space is SonarQube. Then what is SCA? SCA is basically software composition analysis. In short, you can just call it as dependency checkers, because the tools in the space of SCA, they go through direct dependencies of your application, indirect dependencies of the application, and they verify if any particular version of your app, direct or indirect, is known to the hackers. I mean, is potentially vulnerable in terms of CVEs. Finally, DAST. What is DAST? Dynamic application security testing. When it comes to DAST, this is performed during the runtime. So you can just give the tool. In our case, we will use OWASP ZAP, a very popular open source free tool. Usually when it comes to DAST, most of the tools are paid tools, but we will go with OWASP ZAP, a very popular open source and free tool. And using this tool, you can just provide URL and it starts sending thousands of API calls to identify any insecure patterns in your application, like the similar ones. Whatever we learned in SAST, almost the same things. It tells you if there is any CORS related issue in your application, if there is any CSRF issue in your application, or if you're using any insecure cryptographic modules or insecure SSL, almost the same things, but here it tells you through the runtime environment. Perfect. Now that this is clear, let's start with SAST first. So we will do the SAST demo now. What we will do? We will take a simple Python application. Okay. We will install SonarQube through Docker, and we will just connect the Python application to the SonarQube, and we will run Sonar CLI to connect it. We will run the Sonar CLI in the place where we have the application source code. So Sonar CLI will talk to the SonarQube and send the information of the application source code. Let's do that. So first of all, we need the application. Don't worry, we will clone our DevSecOps 0 to hero repository, because here I already have the application. app.py is our Python application. What is it doing? It's just a web application that is making API call to the database. That's it. Nothing more than that. A simple web app that makes a query to the database. Now, when you look at it, it actually looks good because it returns user management service on the home page. and it is rightly connecting to the database. So to the naked eye, you cannot see any issues. It's generating a random token and it is connecting to the database. Let's see what SonarQube tells. So for that, I'll clone this repo. On my terminal, I'll move to the test folder. I have a test folder and I'll just remove everything here and clone our DevSecOps repository. Git clone followed by GitHub, I am Veeramalla, DevSecOps 0 to hero. Perfect. Now this will clone the repository for us. Let's move to the repo. We have different folders. Let's move to 06 folder. And here we have the app.py, we have requirements.txt to run the application, and we have sonar projects.properties. But Abhishek, what is this? Once we install SonarQube, we have to create this file and we have to provide the URL of the SonarQube. Only then Sonar CLI understands where is the SonarQube application. First, let's install SonarQube. So for that, you need to have Docker running. We will run SonarQube as a container. If you have Docker running, just run this command, docker run -d, basically a detachable container running in the background. We are using the port 9000 because SonarQube runs on the port 9000 inside the container, and we are exposing it 9000 on our local host as well. If on your machine 9000 is already in use, just change the first 9000 here because this represents the host port. You can just change it to 9001, 9002, up to you. Name of the container, I'm calling it as SonarQube container. Again, you can change it, but do not change the image. This is important. We are using a SonarQube image 9.9 community version. That is, we are using free version of the SonarQube. Abhishek, what is the difference between free version of the SonarQube and paid version of the SonarQube? Just like any tool, with the free version, you can track only certain patterns. End of the day, what SonarQube is doing, it is performing static testing. It will return only for certain patterns if you are going with the community edition. But if you are using enterprise version, then it's more powerful. It can go through your application more in detail, especially the source code, and it can recognize more patterns that are not part of the community edition. So for your practice, use the community edition. Tomorrow, if you're joining a company and if you want to recommend a company the SAST tool, recommend them SonarQube Enterprise. Perfect. Cool. Now, let's verify if SonarQube is running. So we will take the local host followed by port 9000. There you go. SonarQube is running for us. All systems are operational. Home. What is the username and password? For the default version, I mean, if you just install SonarQube, the username is admin and password is also admin. See how simple it is. For community edition, you just have to run a Docker command and everything is done for you. Okay, let's change the password. Old password is admin. New password, you can set up anything. Just make sure you remember it. There you go. Okay. Now we have SonarQube running here. The beauty of SonarQube is that you can connect your application on your local machine, or you can integrate it with your CI/CD as well, which we will see in the next video. In today's video, let's only learn these tools. Let's not focus on CI/CD. Anyways, so you can connect with any of your Git distributions like GitHub, Bitbucket, anything. Or you can just connect your application manually to SonarQube, which we will do in the video. But Abhishek, how do I connect manually? If I want to connect through GitHub, I'll just provide my GitHub URL. I'll provide my GitHub API token. How do I do it manually? Of course, this is important because you will use something called as SonarQube CLI. So using SonarQube CLI, you will connect to the SonarQube interface. To install SonarQube CLI, you can just follow the steps in the official Sonar documentation. Reason why I am referring you to SonarQube CLI documentation, I can directly share you the command, but the versions keep changing. Let's say you're watching this video after 6 months. I'll put the commands in the GitHub documentation. You will try to follow it and it will break because as the versions keep changing, the parameters might change. So that's why I'm asking you to go to the Sonar CLI, the documentation. The link is in our MD file, the link to the website. Just scroll down. All you have to do here, just scroll down. You will find this hover. Click on the hover and you will find the download button. That's it. Just download it. Rest all steps you can follow from my documentation. Okay. So now once we are here, that is once we are with the SonarQube CLI, once you downloaded it, prepare the Sonar properties. So wherever you have your application, in our case, we have our application here, app.py. In the same location, prepare this file, sonarprojects.properties. And what you will put in this file? You can put the SonarQube URL. Either you can put it here or you can pass it through the CLI parameter. In my case, I'm just providing the values. What is the name of my project? This project name will be reflected in the SonarQube UI. Right now, there are no projects here, right? If I click on projects, there is nothing here. Once we run SonarQube, then a project will be created with the name vulnerable Python application. And I'm saying SonarQube that my programming language is Python. Even if you don't say that, it is intelligent enough to detect it, but it's a good practice to do it. Now, I already have Sonar CLI on my machine. So I'll run this command. Sonar scanner, right? Sonar scanner is the CLI. -d Sonar host. There is my Sonar host running on localhost port 9000. So I pass that. This is what I was talking about. You can even pass this in the Sonar properties. Finally, I'm saying this is my Sonar login token. Abhishek, what is the purpose of token? Without that, your Sonar CLI cannot connect to the Sonar UI. Who knows? You might be running this command. Someone else might be running this command. So for CLI to authenticate to the UI, you need the Sonar API token. Where will you get it? Simple. Just head to your settings here. Head to my account. Here you will find security. Click on the security and just create a token. I'll call this as test token, global analysis token, and generate it. In real time, this is generated by the admins. Perfect. Now, click on the enter and see the magic. SonarQube is reading your Python application and it will detect any issues with your application. Okay, it says unknown key, sonar.project key. Very simple. Actually, this should be sonar project.properties, not sonar projects.properties. I'll just change this from sonar projects.properties to sonar project.properties. And let's rerun the Sonar CLI. I think I have to change this in the GitHub repository as well. I'll change it. There you go. Now you can see analysis is successful and analysis is pushed to the Sonar UI. Let's see if I click on the projects. There you go. So here, vulnerable Python application is verified by SonarQube. And what does it say? It says there are no bugs, there are no vulnerabilities, but in the hotspots reviewed, it is in the E status. That means it found out some issues with our application. There are 2 security hotspots. So it is saying you don't have any critical vulnerabilities in your application, but there are 2 security hotspots which you should take a look at. When we looked at the application, We did not find that. Like looking at app.py, everything looked good. But SonarQube said, no, there are two issues with your application. Let's see what is that. The first one, so it says there is cross-site request forgery, which is CSRF. If you're into application development, you understand it. If you're not into application development, I don't want to complicate the concept because CSRF itself is a very huge concept. Just understand that within this application, there is a risk that is figured out by SonarQube. Now, SonarQube does not only tell you the issue, but it also says what is the risk and to what extent you have the risk. Sometimes, because these are tools, they just look at the source code and they think your application might have the issue. But SonarQube is a step ahead. What it says, you are only exposed to this issue if you are using a web application that uses cookies to authenticate the users. In our case, we are not doing anything like that. It's a very simple Python application. And it says, if you're performing any sensitive web operations, if your application supports HTTP post request or HTTP delete request, only then your application is exposed to this security hotspot. Now, in my case, it is not. So what I can do, I can go back to the security hotspot. Now, I can click on this and I can in fact say this is not issue in my case, right? So I'll go here in the review. I'll change the status to safe. Scroll down. I'll mark the status. Continue review. Now you will notice if you go back to the security hotspot, you will only find one issue. 50% is reviewed and fixed. I'm just trying to show you how the issues are addressed within the organization. It's not that SonarQube identified an issue and okay, you will just say it identified the issue, then we'll just keep it in the SonarQube. No, in real time, these issues are taken into Jira. These issues are worked by the developers. And once developers are confident, they come back here, they mark the issues as done. Then there is another issue with the application, another security hotspot. It says you used random.random to generate a random token, which can be issue in real time. So what SonarQube is saying, you are generating a random token, but this is not a secure package. Hackers can easily figure out what is your random token. So SonarQube recommends go ahead and change it. Again, developers work on it. And if they feel it is secure, if they feel they changed it, then they rerun the SonarQube analysis. But for some reason, if they feel it is already safe, they mark it as safe and they close this issue as well. Perfect. So this is static analysis security testing. Okay. So now, what did we learn? We learned for SAST, one of the popular tools is SonarQube. We learned how to run SonarQube. We learned it through Docker. But Abhishek, in real time also, can I run it using Docker? Yeah, definitely. If you plan to use community edition in your organization, just spin up a virtual machine for SonarQube, run SonarQube as a Docker container. There is no problem in it. Just that you have to connect it with a database so that you maintain the state of SonarQube. Or you can run it as a Kubernetes pod as well, and you make it stateful application. But in most of the cases, these days organizations go with enterprise SonarQube version. So they don't have to install SonarQube. They don't have to set up SonarQube. They'll just get the enterprise SonarQube. They will run the Sonar scanner where they will provide the URL of the enterprise SonarQube, which is a SaaS offering that is provided by SonarQube company themselves. Perfect. Now, let's look at SCA, right? What is SCA? As we learned, SCA is nothing but the composition analysis, software composition analysis. Let's do that on the same application. We are using a Python application, right? So for this Python application, there are two dependencies. If I cat the requirements.txt. In this case, developer said, I'm using Flask and I'm using the request module. And these are the versions I got from the internet. I'm using these versions. Now, as a DevSecOps engineer, what you can do, you can perform SC on this application. How? First of all, create a virtual environment, Python 3 -m pip venv.venv. That is, create a virtual environment. Okay. Oh, my bad. Python 3 -m venv.venv. Next, once the virtual environment is created, source the virtual environment. Source.venv bin activate. Perfect. Now, instead of directly installing the application, which you usually do as DevOps engineer, this time install something called pip install pip audit. Now, for every programming language, as I told you, there are different utilities. For Python, which you most likely work with, the utility is pip audit. Now, using pip audit, because we installed, we can just run pip audit -r requirements.txt. See the magic. Pip audit not only goes through those two dependencies, but it will also go through indirect dependencies, and it will tell you, hey, these are the vulnerabilities in your dependencies. It also gave you the CVE numbers, which is very good. No? Giving the CVE numbers, it is very easy for you. Now you can create a Jira ticket saying that these are the packages that are vulnerable. And if they ask you why are they vulnerable, just you can tell them as DevOps engineers, I'm not sure. You can go to this CVE and read about it. Because you are using an outdated version, this is a CVE. Go through it, read it, and you will understand. What developers do? They just copy the CVE number, they go to the internet, and they paste it on the internet. Usually there are many sources, like there is National Vulnerability Database, that is very trusted one, the NVD, or they can go to Red Hat Vulnerability Database or the popular ones. Personally, I look at NVD most of the times because it provides up-to-date information. So developers go through, they read it. Oh, okay, this is why there is issue in my application. Let me go ahead and fix it. Cool. So we learned about SCA as well. Now let's move to the final one. SCA is very easy. That's why I'm not repeating it again. You just have to install a utility and you just have to run one command. Now let's move to DAST. What is DAST? So we learned that for DAST, we have to run the application and then we will use a tool called OWASP ZAP. Right? If you remember, we used OWASP in episode 1 as well, where we learned about threat modeling. There we learned OWASP threat module, right? But here we used OWASP Threat Dragon there for modeling, threat modeling. Here we are using something called as OWASP ZAP. These are just tools. Installing them is not a big deal. What you need to know is which tool to use in the right place. We need an application for this, right? To verify DAST, we have to do it at runtime. But which application are we going to use? The better the application, better is performance of DAST. Only then you will be able to explain the interviewer or even within your organization if you have to do a proof of concept. For DAST, you need a very good application. Only then there will be more vulnerabilities in the application. Where will you get that one? So here, let me introduce you to something called as OWASP Juice Shop. So basically, one of the open source developers, they built this Juice Shop application, which is basically a e-commerce juice selling platform. And intentionally, they wrote this application with a lot of vulnerabilities. Now, when you run this application, it creates an e-commerce platform. Let me show you. We should have it somewhere here. I'll open the application and just show you how the application looks like. So this is how the application looks like. So you can find different juices, just like how you find different products on an e-commerce platform. You can find different juices. You can read about a particular juice. You can read about customer reviews. And in fact, you can place orders as well. But for that, you have to first log into the platform. Again, just like a real e-commerce application. I'll just log into the platform. And once you log in, you can select a product. Now that goes to your basket. You can add multiple numbers of the same product. Click on the checkout. You can provide the address. In fact, after providing the address, you can also head to the checkout and provide your bank account details. Of course, you'll provide dummy details, and you can head with the shipment part as well. Just to simulate a real world e-commerce platform, they developed this application. Good thing is this application is open source. So everyone started using this application for their demo purpose. Even I have used this application as a demo application in a lot of presentations. Anyways, now we have an application. So we can use this application. Good thing is that this application is made intentionally vulnerable. Now what we will do, we will install OWASP Zap, right? We will install OWASP Zap on our local machine. We will run this application on our local host and connect OWASP Zap with this application. And rest, the Zap will take care. It will make API calls to this app and it will generate an HTML report for us. So we can go through the HTML report and we can verify. In fact, what it gave is right or wrong. Let's do that. First, I'll run this application locally. How do I do that? I'll first stop the container of this application. I already had it running. Let me just stop the container. So for that, I'll do all the containers. I've removed them. Now, this is the Docker command to run the container, the juice shop container. Docker run -d. I'm running it in the background. The name of the container is juice shop. I'm running it on port 3000. And again, I'm mapping it to 3000 on my local host. You can find this command from our MD file. Okay. Now on port 3000, I have the juice shop running. Next, we need the Zap container. For the Zap container also, just run this Docker command. Just like how we installed SonarQube using a Docker command, we can install OWASP Zap also through a Docker container. Cool. Because this is open source, we can do it. Okay, there seems to be a typo here. Let me just fix it. So if you notice the command, I'm asking it to create an HTML file, zap report.html. And if you observe carefully, I'm passing my application URL as well. So I'm saying zap, my application is running on port 3000 and it is running as a Docker container. That's why I gave host.docker.internal 3000 port. Abhishek, is there a way where I can actually run OWASP Zap through the user interface? Because when I perform a proof of concept, it will be better if I show my organization through the user interface. Yeah, we will do that as well. For now, let's run Zap as a container. Let's get the HTML file because this is the easiest way. Then in the next step, I'll show you how you can run this through the user interface as well and how you can connect your application with the Zap. Container is installed. Now it is actually using the automation framework. What does that mean? It started making API requests to our juice shop application. It started making hundreds, thousands of API requests. So it will take time. And you can see here. In fact, see, it made some API request. That's why it said access a confidential document. So something is happening behind what we see. Zap is making API requests to our juice shop application. In a moment, we should have this completed. Typically, it takes 2 to 3 minutes. There you go. And it figured out a bunch of issues as well. See, This is a warning. This is a warning. How can we read it? We can read it through the HTML file that is generated. Now here we should have a ZAP report HTML document. You can read it from your browser as well. Just do pwd. So this is the location. I'll copy this. I can access it from my browser. File colon / followed by the path followed by zap reports.html. There you go. Tada. So here we have the report and spend some time reading it. I can go through some of them, but if you want to read it carefully, there are medium-sized vulnerabilities, there are critical vulnerabilities, and there are low vulnerabilities as well. Let's see what are the medium vulnerabilities. I'll go through one of them for you. So it says cross-domain misconfiguration. So there is CORS issue on the application. And here it says CSP header not set. This is one vulnerability on the app. This is another vulnerability on the app. And in fact, it is also providing us the location. For example, it says within your JuShop application, there are node modules and there is Express node module. Within the Express node module, there is an issue. Here it says dangerous Java function is being used. I mean a JavaScript function, dangerous JavaScript version. That means a vulnerable JavaScript function is being used. And it also tells you exact function in the code. If you don't trust OWASP ZAP, you can actually verify it. Copy this function, go to the source code. This is the source code. Take this in an editor. So I clicked on dot. It opened web editor for me. I'm not cloning the repo again. And here in the search button, I pasted bypass security trust HTML, which ZAP report shared. And you can see in different places, in fact, this particular function is being used. Look how cool it is. It does not have your source code, but still from the runtime application, it detected that these are vulnerabilities in your application. And it also gave you exact line number. It gave you the function name and it also gave you the line numbers. So that is why DAST is very, very powerful. You can give DAST tools n number of websites in your organization and let it run. Let it run in the background. It will do the job for you. Especially OWASP ZAP is also open source. There is no limit. It will make 100,000s of API calls and after 20 minutes, 30 minutes, you will get detailed HTML report. Share it with your management, share it with your developers and let them figure out how to fix the issues. Now, okay, we learned this through CLI. Let's do the exact same thing through the UI. Okay. So what we'll do now, we will run OWASP ZAP through the user interface. Again, very simple. Just run this Docker command. This command is also in our MD file. Docker run -it. I'm not really sure from where these lines are coming up. Let me just fix it. So this time we are just running the ZAP proxy so that we can connect from the user interface. There you go. Now it says proxy is running. You can access it on port 8080. Let's do that. Localhost port 8080 followed by /ZAP. Starting the application. So now we can access it from the browser as well. But this will take some time. For the first time, just say, no, I don't want to persist the session and start. You can just expand this utility, manage ads, close it, expand this utility because this is the one we are going to work with. Okay. And this is actually slow. That's why I initially showed you with CLI. Now what you have to do here, click on automated scan and here provide the URL. What URL will you provide? Provide the same URL, that is host.docker.com followed by colon 3000, which we gave in the uh, CLI as well. HTTP, I'll paste it here for you. HTTP host.docker.internal colon 3000 and click on the attack. If modern with Firefox, I'm using the Firefox browser and I clicked on the attack button. There you go. You can see here it started making the HTTP requests. In fact, here it is showing you the HTTP request as well. It made GET request on the juice shop build routes and it is making several other HTTP requests. And just like the CLI, this one also will take time for you. And once you have this done, you can get the report from the user interface and you can verify the report. One thing, the report will be exactly the same because whether you do it from the UI or CLI, it does not change. This is cool for your proof of concept, maybe better than CLI. But when you do it through the CI/CD pipelines, definitely CLI part is better. When we integrate this entire workflow with GitHub Actions or Bitbucket, all that we have to do is provide the Docker CLI command and OWASP will be executed. But if you do from the user interface, it is difficult to integrate in the CI/CD. Perfect. So this is all we have for today's video. This will be done in next 10 to 15 minutes. In the meanwhile, you can go through the revision material in our GitHub repository. So we learned about SAST, we learned about SCA, and we learned about DAST. SAST is for static testing, SCA is basically for dependency check, and DAST is for testing your application in runtime. If you have any specific questions, do let me know in the comment section and please share this video with every DevSecOps enthusiast that you know. And trust me, this is very, very cool. Lot of people might not be aware of OWASP and running open source DAST tool. So if you're interested, you can publish this to your LinkedIn, you can share it with your network and help others also learn. See you all in the next video. Take care. Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's learn end-to-end DevSecOps implementation. So typically you will learn what exactly a DevSecOps engineer does within an organization, or if you join an organization as a DevSecOps engineer, what will be your roles and responsibilities? How would you take an application to a production ready state? That is what we will cover in today's video. Now, obviously, when you want to learn something like this, you need a demo application. But you need a demo application that is almost like a real-time application. You need front end, back end, database. Where will you get such application? So don't worry, we will use this demo application in today's video. I created this application and I have the complete source code for the application, which is in a public repository. But before that, let me first walk you through the application. So this is just like any blogging application that you would use on the internet. It can be like Medium, or you can consider this as a lightweight blogging application where this is the front end. Whatever you are seeing on the screen is basically the front end of the application. And within the front end, you have an option to create a new post. And there is a vibe for the post. For example, let's say you want to post something that is trending on the internet. So you can pick up the vibe accordingly. You can just give a title for it. Let's say LLMs, you want to write a very trending topic, or you want to write something very hot, which can get more views for you. So you can just say LLMs are overrated. Let's say this is the title. Author Abhishek. And then you can just keep writing the content. For example, I'll just, to be decided, because I'll work on the content later, let's say, post it. So you can see, the LLMs are overrated is posted. If I go to the website back, so now there are two posts here. If anybody is interested, they can comment on the post. Let's say you make this blogging portal public, which is what we are going to see as well. I'll show you how you can share it with your friends by the end of the video. So they can just come here, they can also leave a comment, they can share their opinion. This way, you can use this as your personal blogging website as well, where every day you can post something and you can even share it on LinkedIn or anything that you do. So this becomes the front end, which is the user interface. Where are these posts getting stored? Like whenever you are creating a post, there is some content that is involved. There are some comments here. All of this will be stored in a database. And what is the bridge between your front end and the database? That's called as a backend. So what I'm trying to tell you here, we will be working on a 3-tier architecture application. This is important because in real time also, you will be working on 3-tier architecture applications. Let's say you join Amazon, their e-commerce platform is a 3-tier architecture application. Let's say you join Walmart, you join even a startup, you'll be working on 3-tier apps. If you're a beginner, I'll simplify this for you. So what is a 3-tier architecture application? There are 3 tiers here. One is called front end, which is the user interface that you see for any website. Even if you look at GitHub, whatever you are seeing here is a user interface, which comes from the GitHub's user interface. Then you have a database. Database is mandatory because end of the day, your data has to be stored. For example, I have created a repository here where I'll be writing some code, I'll be storing some code. So that has to be stored in a database. So database will serve as a storage. And there has to be a bridge between front end and the back end. Right? For example, if I'm storing something in the database, how does that get populated in the front end? So there is a layer between front end and back end, which we usually call as back end. So this is one tier, this is second tier, and this is the third tier. That's why we call this as 3-tier architecture applications. Some of you might already know this. If you already know it, it's good. But if you're a beginner, this is what we mean by 3-tier apps. Sometimes you might also come across 2-tier architecture applications, right? You might see some examples on YouTube, on internet. When they say 2-tier architecture applications, that is, there is only front end and back end. There can be some static applications, which is also called 1-tier applications, where there is only front end that is involved. For example, basic HTML pages, right? So you don't want to bother about storing the data. You just want to create a HTML page. Maybe you want to notify something, your basic personal information website or your portfolio website. That can be a front end or a 1-tier application. 2-tier, where you have front end and back end. When you want to make your portfolio website or when you want to make your front end dynamic, you would go with 2-tier architecture applications. And 3-tier, I just explained it to you. Perfect. Now, where will you find the source code of this 3-tier architecture application? Okay, Abhishek, you shared this application, but where will I get the source code? So I open sourced it. Of course, writing such application takes a lot of time. I used LLMs, I used AI to get this application. And now the source code of this application is in this GitHub repository. In general, when you join organization as a DevOps or DevSecOps engineer, your journey starts from this point. So the development team would already have a GitHub repository, unless you are joining an absolute scratch team, someone who is starting the development from absolute scratch. You would ideally get a GitHub repository like this, where they have the source code of the application and they have steps to run the application locally and also some basic information about the application. Like in which programming language the application is written, what tech stack is used to build the application, how to run the application locally, if there are any variables, what variables you need to export. All of that information is provided by the development team. So this is where you start your journey typically as a DevOps or DevSecOps engineer. And what is the end goal? So the end goal, the end goal is huge in this case because we are talking about end-to-end DevSecOps implementation. You should first start with understanding how to run the application locally. Although the steps are shared by the development team, you have to try it by yourself. Only then you know if the steps are correct. Then creating the required infrastructure, because eventually you want to host this application to production. So you need to automate the steps to create the infrastructure. You cannot just go to AWS and create the infrastructure manually because you might have to do it multiple times across different environments like UAT, staging, production, or sandbox environments, whatever it is. So ideally as a DevOps engineer, you should automate the infrastructure creation that is using platforms like Terraform, right? By following infrastructure as code principles. And then, before you deploy the application, you should containerize the application, right? So typically in this case, you have to create Docker files first. Why? Because when you're dealing with microservices, the today's standard is to deploy the microservices as containers. So first, you have to create a Docker file. Then you have to create Docker images. In this case, you have front end, back end, and database. So you have to create 3 different Docker images. And then build the application locally, but this time as containers. Previously also you ran the application, but that was using some manual steps, maybe a shell script that is shared by a developer. But here, after containerizing the application, you have to build and run the application using Docker Compose. So this is your first step of automation for the project. Now in future, if there is a QA engineer that comes to you and asks you, like, I want to run this application locally, you can just share the Docker Compose file with them. It doesn't matter if they're using Windows, if they're using Linux, Docker Compose would execute and would bring the application on their local machine. And once this is done, your job is only half done till here. So once you create the Docker Compose file, the next step would be to create Kubernetes manifests. Because end of the day, you want to deploy this blogging site onto a Kubernetes platform. Okay. So even Kubernetes would come under infrastructure creation. So when you create the infrastructure using Terraform, you would create a Kubernetes cluster. But here, at this point, you have to create Kubernetes manifests. Ideally, it is good because it is deployed as a single application. End of the day, you want this blogging platform as one single application. So it is better if you define one single Kubernetes manifest, where once you deploy this Kubernetes manifest using kubectl apply, all the resources that are related to Kubernetes are deployed to the Kubernetes cluster. It can be pods, it can be deployment, service, network policies, it can be storage related components, anything. Don't worry, we will learn all of this. And then once this is done, you also have to implement CI/CD, because every time developer creates a commit, every time developer creates a pull request, these steps should be automatically implemented. If not all the steps, at least majority of the steps should be automatically implemented. And most importantly, every action that you perform should be considered with security point of view, because what we are targeting is DevSecOps implementation. Even if someone asks you to implement DevOps, you should think about security in 2026. So that's why I keep saying, whether it is DevOps or DevSecOps, your end goal has to be the same thing. In every action that you perform, you have to take care of the security. So this is what we are going to implement in today's video. So we will implement all of this step by step. And you don't have to get overwhelmed at any point of time. Understand one thing, I've already implemented DevSecOps for this project, and I have implemented DevSecOps for hundreds of such projects. So if you find it intimidating while I run a command, or if you feel I'm going little fast at any point of time, please don't be intimidated. This comes from experience. Even if you implement DevSecOps for this project and 2 to 3 projects like this, I'll also show you at the end of the video how you can create demo applications for yourself. Once you're done with this, even you will be able to implement DevSecOps at a very easy pace. And also, to make it simple, because I want every one of you to implement this thing after watching the video, what I've done for you, if you head to this project called Journey, you will find the link in the description. The main branch will have the basic information about the application. But if you switch to a branch called DevOps, here you will have everything that I'm going to implement in the video. So you can see here, I have steps for Kubernetes, I have steps for the Terraform manifest, which is going to create VPC on AWS, which is going to create Kubernetes clusters on AWS. Each and every file is provided. And along with Kubernetes and Terraform, I have Docker implementation, I have security best practices, GitHub actions implemented, I have Docker Compose implemented. Everything is provided for you. As I told you, after watching the video, I want you to go back, if required, take some time, revise through the manifests in the DevOps branch, and then start implementing the project at your site. If you are stuck, watch the video again or get to this GitHub repository and look at the manifests. Perfect. So I hope the goal of the video is now clear. What are we going to do? We are going to implement end-to-end DevSecOps on a 3-tier architecture application, because as DevSecOps instance, that is what you're going to deal with when you join a company, mostly 3-tier architecture applications. And what are we going to implement? We are going to implement these steps on the Journey application, a personal blogging application. But Abhishek, when I join a company, will the README file be this detailed? I'll tell you one thing here. This is a question a lot of people ask me, whenever they want to learn DevSecOps, whenever they want to create a project. This is the first question that they have. Abhishek, I don't understand the code base. Definitely yes. And as a DevOps engineer, it's difficult also, because today this application is written in Node.js, React, and the database that is being used is Postgres. Tomorrow you might work on a complete different tech stack. As a developer, you won't be subjected to these many changes, because if you are a developer, you learn Java. In the next company as well, you will be working on a Java based application, because you would apply for Java based roles. But as a DevOps engineer, the only thing that is constant for you is the change. In one project, you might work on Java application. In another project, you might work on Python application. In another project, you might work on Node.js application. So what you have to rely is on the inputs that are shared by the developer. What kind of inputs? As I told you, the basic tech stack of the application, as you can see here, architecture of the application, project structure, and steps to run the application locally. And yes, developers will share you these steps. If it is a public repository, they would share these steps through the README file for you. But if it is a organizational application, that if it is a private application, they usually have something like Confluence documents, right? Or they usually have this information in Word documents or in the SharePoint documents, whatever is the internal documentation platform that your organization would use. If this information is not shared, which is very, very unlikely, you have complete right to question the developer to share this basic information for you. Only then you can tell them, I can start with the DevSecOps implementation. Let's see what information is provided here. And I wrote this information for you so that it's easy for you to get started. So the architecture of this application, whatever you saw, the journey application, the front end is written in React.js and a Nginx web server is used as a reverse proxy. So basically you hit the Nginx reverse proxy, and from the Nginx reverse proxy, request goes to the React application, something like this. So there is a user somewhere. User would access Nginx reverse proxy. So Nginx reverse proxy and front end is hosted within a container or within a pod or a virtual machine, whichever way you would pick up. If you are deploying this on Kubernetes, a pod would have both Nginx and the front end. So what happens here? The user's request would go to the Nginx reverse proxy, and from Nginx reverse proxy, the request would go to the front end, whatever you see here. And this is the general workflow as well, because you can offload the configuration related things, routing related things, security related things. It can be SSL, it can be certificates, or it can be rate limiting. You can do all of that in the Nginx web proxy. So that's why developers choose a proxy server first. And from here, request goes to the front end. So that is what is explained here. Okay. And then the request goes from the front end to the back end. And back end here is written in Node.js, and Express is used for the server purpose. Okay. So again, from the front end, request goes to the back end, and back end here, as I told you, is written in Node.js. What is the functionality of the backend? Very simple. Backend acts as a layer between front end and the database. In this case, we are using Postgres as the database. So every time a user makes the request goes to the front end. Let's say on front end, user clicks on reading a blog. The information related to the blog should be fetched from the database. That is what backend does. Backend talks to the database. Backend gets the information from the database, and backend forwards that information to the front end. And from front end, request goes to the user. This is how the usual workflow works. Okay, the same architecture is also explained here, along with the ports on which the application is running, because these ports are hard-coded within the source code. And this is the clear folder structure. Even this thing will be shared with you. So journey is the name of the application, something that I have given. If you want, you can change the name of the application. And it has 3 different folders typically. One is the front end folder, one is the back end folder, and other is the deployment folder. In the front end folder, you have the source code related to the front end. In the back end folder, there is a source code related to back end. And in the deployment folder, there are steps to run this application on an EC2 instance. Ideally, the reason for choosing Linux instructions, because if you're watching this video, you might have a Windows machine. I'm using a Mac OS laptop. A lot of times when I execute the steps, if you try to do the same thing, the execution might fail. So that's why I took an intentional choice to share the steps in the EC2 instance point of view, so that you can also create a Linux machine. I can also create a Linux machine, and we will execute the steps on the Linux machine to bring the application something like this. Perfect. Now you might say, but Abhishek, what about database? No, you don't need any specific source code related to database, because bringing up a Postgres database is just executing one single command. So that's why typically within the application source code, you would find backend folder, you would find front-end folder. Okay. So I'm in the DevOps branch. I have to go back to the main branch. Perfect. So this is backend, this is front-end, and this is deployment related script. What else? So we learned about architecture, we learned about project structure. These are the steps to run the application on an EC2 instance. Step 1, to create an EC2 instance, basically go with Ubuntu. It is most widely used. Then copy the source code to the Ubuntu instance. If you want to use SCP, you can do it. Or Ubuntu instance usually comes with Git. So you can also use Git. The reason for sharing SCP instruction here, initially I had the source code on my laptop, right? So from the laptop, I copied the source code to the EC2 instance. So I use the SCP command. In your case, it's not the same because you already have the source code in a Git repository. So you can just run git clone instead of this command. And then you have to SSH to the instance, and then you have to run the deployment script. And this will bring the application live for you. So this is your first step. Just do this and see if you're able to get the application running. But one thing that you also have to do here in the deployment script, that is setup.sh, make sure you understand what is written. Okay, this is the only thing that is part of the source code that you have to understand. You don't have to understand the backend related files. You don't have to understand how the React application is written. Only thing is focus on the deployment script, which I'll go through for you. Okay, so first of all, what is being done on the EC2 instance? The sudo command is executed so that you get the basic packages, the packages that are required like Git or update the packages, version related to Python or existing modules on the Linux machine. Then install Node.js. Why are we installing Node.js here, or why developer is asking us to install Node.js? Because the backend is written in Node.js. Then install the Postgres database, then install Nginx, then install Postgres client, run some basic queries to start the Postgres database, and finally, all that you have to do is to set up Nginx configuration, start the Nginx server, and bring the application live. These are all the Postgres related queries that we are executing and Nginx related configuration that we are performing. Let's do that. Okay, so we will head to AWS console. You must have an AWS account. If you don't have, even if you have Azure account, that is also fine. Or if you have a Windows machine, just install WSL. With WSL also, you can get a Linux environment on your machine. Perfect. Launch instance. Let me call the name of the instance as local testing. I'll use the Ubuntu operating system as recommended by the developer. Instance type, T3 micro is very small. If you don't have enough credits on AWS, you can still use it. But if you have some credits, I would recommend at least T3 small for this, because we are running a 3-tier architecture application. Then key value pair. I already have a key value pair. I'm going to use it. In your case, it's up to you. You can create a new one. Allow the application to run on HTTP. Why? If you understand the architecture, you will know the answer. Just go back, and if you notice, developer clearly shared front end is running on port 80, and what we would access is front end only. So that's why we have to expose port 80 on the instance. How do you expose port 80? So there is an option while creating the instance, allow HTTP traffic from the internet. If developer says this port is port 5000, then you have to create a new security group and you have to enable port 5000 as part of the security group. Okay. Because you're using a Postgres instance, let's say you want to use it, you really want to use it from the EC2 instance. Abhishek, I don't want to continue with the rest of the steps. For me, this initial first step is good enough. I'm just learning DevOps. Then do one thing. Because you are going to use the application from here, just increase the EBS volume size to, let's say, 16 GB. Because your Postgres database is going to use the volume from here. If you create 100 such blogs, or if you create more number of blogs, you would note this storage. Otherwise, you can go with 8 GB storage as well. And most importantly, once you're done with your demo part, delete the EC2 instance, go back to the volumes, that is, go back to EBS, search for EBS or volumes, and check all the volumes are deleted. Otherwise, you will be charged by AWS, not only for instances, but also for the volumes. You don't have to mess up with any of the advanced details. Click on launch instance. Okay, so till now, what are we doing? We are just getting started. We are just running the very first step to understand the application. And this is the most crucial step as well. Before you perform anything, like before you set up the infrastructure with Terraform, containerization, Docker images, this step is very, very important. Why? Because only at this point, you will know the architecture of your application. You will know the project structure. You have to get along this project for 6 months, 1 year, when you work in a company. So you should know the in and out of building process, deployment process. And the starting point is running the application locally. Cool. So we have the instance now. Let's access the instance. So we just need the public IP address. I will copy it. I'll go back to my terminal. You can use any terminal. If you're a beginner, you can use the native terminal on your laptop. Even PowerShell works fine if you're using a Windows machine. Otherwise, just go with MobileXterm, or WSL also comes with its own terminal. If you have a macOS, go with the terminal. I mean, the name of the terminal itself is terminal or iTerm. Cool. So what are we going to do now? We are going to SSH to the instance. SSH. Let's first switch to the downloads folder. Okay. So I'll just go to downloads. You can go to the temporary directory also, or OPT folder also. And I already have the application here. So let me first delete it so that we both are on the same page. The one who is watching the video and the one who is explaining the implementation. rm-rf journey, sorry. Okay. Now, what I'm going to do here, SSH -i followed by the PEM file. I have it in the downloads folder, followed by, what is the name of the PEM file? Sample, I guess, or what was the name of the PEM file? Let's see. So go back to the instance. Here I can find, I'll just scroll down, sample key pair. Okay. Sample key pair.pem followed by Ubuntu at IP address. If you have just downloaded the PEM file, when you do this, yes, you will run into an error, because by default, the one that you downloaded, the PEM file that you downloaded from AWS, they will come with escalated privileges. So what you have to do, you have to run this command, chmod 400, wherever is the location of your PEM file, let's say downloads, followed by the name of the PEM file. Sample, the name of the PEM file, which is sample key pair. Perfect. So run this command and then your SSH command will work. Okay, so we have SSH to the instance. Now, what is the first thing that we have to do? We have to update the app repositories. whenever you create an EC2 instance, this is the first step that you have to do. Sudo apt update. But Abhishek, why do we do this? This is a general activity that you perform because uh, the instance that you created, it comes from an operating system, and this operating system might be bundled a long time ago. Okay, and from that time to the time that you're using this instance, there might be some new versions of the packages in your operating system. So that's why you always have to do sudo apt update so that the modules that you have on this instance or packages that you have on this instance are upgraded and up to date. Cool. So now let's use git clone followed by the main branch. Okay, make sure you're on the main branch. You can copy it from here and paste it. github.com, I am Veeramalla, journey.git. Perfect. Now let's switch to the journey directory. CD, capital J, okay. And there you go. We have all the files that are required. Now we will switch to the deployment directory. Once again, because you just downloaded this or cloned this repository, you have to grant the permissions to the setup.sh. This time, because you are executing the setup.sh, you can grant 700, or if you are confident only you are using this instance virtual machine, you can also go with 777. But the safest option is to go with 700. Setup.sh. Okay, now let's run the script /setup.sh. Abhishek, should I take some time here to understand what exactly is in this setup.sh? Definitely you can do it. The reason why I did not stress a lot, because there are some SQL queries here. If you are a beginner, you might get intimidated with the queries. You might get intimidated with Nginx configuration. That's why I did not go through a lot of it. But if you feel that I can take help from the internet, I have some prior knowledge of Nginx configuration, good enough. Take some time here, pause the video, look at the setup.sh, and once you're good, resume the video. Okay. So what is this script doing? It is executing the packages first, then it will install Nginx, then it will install the Node.js, it will install Postgres. So this might take 2 to 3 minutes of your time. Perfect. So right after 3 minutes, we have the message here. Journey is now live and you can access it on the local host. When I say local host, on the EC2 instance IP address. Okay, let's see. We will go back. We will get the instance IP address one more time. This is the one. Copy it. Take a new tab on your browser and paste it. Now you should be able to access it because it is running on port 80. Let's see. There you go. So Journey blog platform. It took, I think, roughly around 1 second to come up because it has front end, back end, and database. For the first time when it loads, it will take that initial 1 second of time. Okay, so you can see here, this is the one that I have running on my local machine at this point, which I'll uninstall in a while. And this is the one we have running on the instance. Here, there are 2 blog posts. Here, there is no blog post because this is a different application which is running on my EC2 instance. This is the application which is running on my laptop. So this way, you can also create an instance of yourself. You can keep blogging here and you can share it with your friends. Okay, now what is the next step? So we are done with the first part to run the application locally. Now it's time to set up infrastructure for this application. Abhishek, why do you need infrastructure? We can just run the application on an EC2 instance. No, that's not how typically it works. Because this is a blogging application, it's fine. You are the only user, so it is okay. But imagine you are working for companies like Amazon. Okay. Even they have front end, back end, database. But every microservice of Amazon is used by millions of users, right? Even at this point, Amazon.com, if you take any single microservice, it would be used by millions of users. Not every application is used by millions of users. There will be some startup, but at least some hundreds of users would be using it. So you cannot rely on this one single virtual machine architecture. These days, the popular architecture is the microservices architecture, right? Even the developer here wrote the application in the microservice architecture. Front end is individually deployed, back end can be individually deployed, right? So for the microservice architecture, the recommended platform is the Kubernetes platform. So our end goal is to deploy this on Kubernetes, right? So we have to set up infrastructure for this. Of course, we cannot directly deploy the application to Kubernetes. There are some prerequisites. First, you have to use Docker to create containers, right? You have to verify the application is working as containers. Then again, you have to define Kubernetes manifests. But all of that comes as next step. First, let's focus on creating the Kubernetes infrastructure. How will we do it? Okay, one way you can do it manually, right? Just head to any cloud platform like AWS, Azure, GCP, and they all have user interface, right? Just go to AWS like this, just like how we created a virtual machine. Similarly, go to EKS, create a Kubernetes cluster by clicking on create cluster. But this is not the recommended approach. What you have to do, you have to follow the standard approach. That is, first you have to create a virtual private cloud in AWS. Okay. What is a virtual private cloud? Virtual private cloud is basically a private network within AWS. Because AWS is a public cloud, you don't want your application to be shared by some other in the world who is also using AWS. So first we will create a VPC, virtual private cloud. We will define subnet for the VPC. First we will define the range for the VPC. What should be the CIDR range? Then we will define a public subnet, a private subnet, and within the private subnet, we will host our EKS cluster. Okay. So this EKS cluster is a managed Kubernetes cluster. We will use EKS auto mode. Okay. When you go for EKS auto mode, you have both the control plane of Kubernetes and data plane of Kubernetes. All the Kubernetes master node and worker node are managed by AWS themselves. This is the current trend. This is how people are using Kubernetes at this point of time. I mean, mostly. So we will do the same thing with Terraform. Okay. First, we will have Terraform installed on our local machine. You can use your laptop as well. And from the Terraform, we will first connect to AWS, that is using AWS CLI. Okay. And then using this Terraform AWS credentials, we will interact with AWS APIs using Terraform modules. And then using the Terraform module for VPC, we will first create the VPC. Similarly, we will create EKS on AWS. And this EKS, we will use EKS auto mode. And once we have this infrastructure, we can go back and follow these steps. So we can go back, create the Docker file, create the container, then create Kubernetes manifest, and finally deploy the application onto Kubernetes. And where is DevSecOps here? We are using VPC, which is a secure virtual private cloud. And even while using Terraform, we will follow all the security best practices. I'll show you while creating the Terraform manifest. But I hope this part is clear. Once again, I will repeat this. So what are we going to do now? Instead of manually creating a Kubernetes cluster on these cloud platforms, we will start with using Terraform. So we will install Terraform on our local machine. We will configure AWS credentials with Terraform using AWS CLI. Then we will create VPC using Terraform modules. Then we will create EKS cluster again using Terraform modules. And we will use EKS in the auto mode so that we don't have to bother about upgrades related to control plane, upgrades related to data plane. We can ensure our Kubernetes cluster is always secure with respect to vulnerabilities related to the data plane or control plane. Okay. So again, where will you find the Terraform related code? Switch to the DevOps branch. You can find a folder for Terraform. Click on the folder and you have all the manifests that you are looking for. Cool. So let's start with installing Terraform. You can also use this EC2 instance. For some reason, if your laptop is not well equipped, you can use this EC2 instance. I'm going to use the same thing. First, I look for install Terraform. Okay. So you can search for this. You will find HashiCorp developer. Go to this. And here, look for Terraform installation through the package manager. We are looking for Linux. So, or you can just go for this option here, Linux, sudo apt-get. So we want to install on Ubuntu. So I'll go with this option. Let's start doing it. First thing, again, they are updating the apt repositories. Cool. Once this is done, install HashiCorp's GPG key. This is just to ensure you are downloading the right Terraform package. On internet, there can be some fake Terraform packages. So just to eliminate that, you will use the GPG key. Okay. And you will verify that you are using the right GPG key fingerprint. So even if someone creates a fake HashiCorp website and if they host fake Terraform package, you can eliminate that by using the GPG key fingerprint. Cool. So now add the HashiCorp official repository from where you will be installing Terraform. So we added HashiCorp repository. Because we added a new repository, we will update our apt repositories one more time. Because now our apt repositories also has Terraform package in it. By default, it does not have. Like on a Linux machine, if you just go and run sudo apt install Terraform, you will not be successful. Only you will be successful when you add HashiCorp related packages to the apt repositories. Now this command will work. Sudo apt-get install Terraform. So basically for this to work, we executed all the commands before. This is for security best practice. The GPG key, signing off it, verifying it. Otherwise, you can just run this command. This one, add official HashiCorp repository. So just add this one, just run this and run this. In 3 steps also, you can install Terraform, but all the previous steps are for security best practice. Cool. Let's see if Terraform is installed. Looks like it is. Now if I run Terraform version, there you go. So we have Terraform running now. But Abhishek, how do I connect my Terraform to AWS? Right? Because we have to create resources on AWS. Yeah, that is definitely important. How would we do that? So for that, you need to go to your AWS account. In the AWS account, just go to this option here. In the settings, go for account. Okay. So in the account, just scroll down. You have to find security credentials. I think I'm looking at the wrong place. Let me quickly see. So here within security credentials. My bad. Yeah, this keeps happening. When you keep working with different cloud platforms, because I keep working with AWS, Azure, and GCP. Sometimes I get confused with the options. Yeah, anyways. So once again, just click on this one to the top right. Then you will find the option for security credentials. Click on it and you have an option to create the access keys. You only have option to create 2 access keys. I already have 2. I'll just delete one. This one is very old. I'll just delete it. Okay. First I have to deactivate. Sure. Deactivate it and delete it. There you go. Now I'll create a new one. I'm not bothering about hiding the access key because after completing this video, I'm anyways going to delete these access keys. So this is my access key. This is my secret access key. So I'll run the command Terraform or first AWS configuration. So AWS configure. Okay. AWS is also not installed. Fair enough. Let's do sudo apt install AWS CLI. So you can see here, we are doing things from absolutely scratch. Okay, once again, AWS CLI is also not out of the box. Let's say AWS CLI download. Okay, we will head to AWS documentation, installing AWS CLI. Install and update. Okay, click on Linux one more time and go for the Ubuntu operating system. So these are the commands. First, we will curl. So we will download the AWS CLI package. Curl is successful. Then let's unzip the AWS CLI. Unzip is also not part. Sudo apt install unzip. There you go. So now we have unzip. Let's proceed with unzipping the package. Okay. So we have all the files inflated now. Now let's run the command sudo dot aws/install. Okay. So now we have AWS CLI. Let's rerun the command AWS configure. It will ask for AWS access key ID. Whatever you got here, just copy, paste it. Cool. Now it asks for secret access key. Again, copy, paste it. Default region, go with the region that is nearest to you. Make sure if you are using an EC2 instance, choose the region that is nearest to the EC2 instance, not nearest to you. I created the EC2 instance in US East 1. So I'll also choose the default region as US East 1. Perfect. Default output format. Let's go with JSON. Now we did the second part of our infrastructure setup. That is, we connected AWS with or Terraform with AWS APIs. Now, if you write the Terraform files, it can connect to AWS APIs and it can create infrastructure on AWS. Cool. How do you write the Terraform files? Okay. See, one way of doing it is obviously you have to learn Terraform first. I made videos on Terraform. We have Terraform 0 to Hero series. It's definitely not possible to cover entire Terraform in this video. So I'll quickly go through the files for you. Okay. I'll explain the steps on how to write these Terraform files because it's not practically feasible to, cover what are modules, to cover what are workspaces, to cover the Terraform lifecycle, entire thing. So I'll go through the files for you. Also the remote backend, state file, there are a lot of concepts. Instead, I'll share my Terraform playlist link in the description. Cool. So we'll go back. So we'll head to the GitHub repository. And in the GitHub repository, these are the Terraform files in the DevOps branch. First of all, you should start writing your Terraform with provider.tf. What is provider.tf? So here Terraform does not understand out of the box if you're creating infrastructure on AWS or if you're creating infrastructure on Azure If you are creating infrastructure on GCP, DigitalOcean, Oracle Cloud Platform, there are a lot of things, right? So we will define what Terraform wants to talk to in the provider.tf. So this is the file here. Okay. So the provider.tf says AWS is the provider. Okay. I'll go through each and every line for you. So understand carefully. First, we will define the provider configuration. Okay. And then we will define the within the provider. So we said AWS is the provider here. Now within the AWS provider, what region to choose, right? Because in the AWS cloud platform, there are a lot of regions. In which region the infrastructure has to be created. So you have to define that. Where will you define? You will define in the provider block. Provider AWS, region, we will define this as a variable because I don't want to hard code. If I say US East 1 here, you all will also create the infrastructure in US East 1. Instead, I will variabilize this, just like how we variabilize shell script or Python. Then these are basic tags. Even if you ignore this block, it's fine. Okay, so these are just the blocks. These are just the tags to identify that you created the resources using Terraform. Cool. Once you're done with the provider block, then the next thing that you have to do is to define the variables as much as possible. Okay, you might say, but Abhishek, at this point, I don't know what all variables to create. At least start with defining the variables that you already know. For example, you know the AWS region is going to be a variable. So just say, this is how you define variable in Terraform. Again, we learned this in our Terraform 0 to Hero playlist. So variable AWS region, just provide the description of the variable. What is the type of the variable? Is it a string? Is it a list? Or anything? Then say, what is the default value of the variable? Right? This is one good thing in Terraform. When you define a variable, when you declare a variable, you can also say, what is the default value of the variable? Is it US East 1, AP South 1? So even if someone forgets to provide the variable value here, okay, in the provider.tf, let's say even if someone forgets to initialize, so it will take the default value from variable.tf. Perfect. Then, we are also going to use the environment because as DevSecOps engineer, you will be creating the same infrastructure for UAT environment, staging, production. So another variable for environment. Name of the cluster should also be a variable. End of the day, you are creating a Kubernetes cluster. End of the day, you are creating a VPC. So you also have to provide the names for it, right? VPC comes with the default ID at least, but for the Kubernetes cluster, it's better to provide a name for it. That's what I did here. So the name of the cluster, I'm just calling it as Journey EKS. Also the version of Kubernetes, I intentionally chose 1.32 here. I can go with 1.34, which is the latest version. I think 1.35. But the reason for choosing 1.32, just to show you how DevOps engineers can mess up with the clusters. If you don't have right security mindset, you can go with an outdated Kubernetes version. I'll show you what happens once we create the cluster. It will show you a clear security banner that you're using an outdated version. Okay, but yeah, the goal here is to define a variable for the cluster version and VPC CIDR range, right? This one here. In the VPC, how many IP addresses do you need? How would you define that? You would define using CIDR range. Every time when you create variables.tf, there will be some level of uncertainty. Initially, you might not know what all variables are required. It is fine. Start with whatever you know. Then it comes to, once you define provider.tf, once you define variables.tf, start writing the main.tf. As the name suggests, main.tf is the main file that you are writing. Cool. Now, we are creating VPC. We are creating EKS. That's what we are doing, right? One good thing about Terraform is that you don't have to write a lot of code. In Terraform, by default, there are something called modules. Okay. In the Terraform modules lecture, I explained very detailed what are modules, how to create module, how to use module. But if you want to understand, at least for this video, modules are nothing but the pre-written code, or you can just assume this as pre-written functions, so that you don't have to reinvent the wheel. Let's say you want to create an EKS cluster, okay, using Terraform. You might have to run some 1,000 lines of HCL file, the Terraform files. But this is a very common thing, right? Every day, hundreds of people would do the same thing. Create EKS cluster using Terraform within their organization. So why everyone has to write this 1,000 lines of code? Someone can create a boilerplate, or someone can create, how do I say it? Someone can create a function or a module that everyone else can use. That's what Terraform does. So Terraform has modules for EKS, it has module for VPC, it has modules for S3, DynamoDB, whatnot. Terraform has thousands of modules, not only for AWS, for other cloud platforms as well. All that we have to do, we have to use these modules, right? And we just have to pass the values to it. That is what is the basic difference, right? I will be creating an EKS cluster. X person in the Y organization will also be creating EKS cluster. A person in B organization would also be creating an EKS cluster. The difference is primarily, I would use different values. Probably name of my EKS cluster is different. Version of my EKS cluster is different, right? Or availability zones of my EKS cluster are different. But rest of the things are same. That is what we will do. We will use the VPC module. We will pass some values. We will use the EKS module. We will pass some values, right? I'll show you here. So the same thing. First, I'm using the VPC module. Where am I getting this VPC module? Where is the boilerplate coming from? It is coming from Terraform AWS modules, VPC AWS. So I'm using a trusted source. In fact, you can find a lot of modules on the internet, but not everything can be trusted, right? Just like how you can find a lot of Docker images on the internet, you cannot trust everything. But at least Terraform AWS modules are the official modules. You can believe them. And then I'm passing the variables, as I told you. I'm passing the name of the VPC. I'm passing the CIDR range for the VPC. Where did I get them from? I got them from the variables here, right? I initialize the variables, so I'm using them here. And similarly, I'm just adding some default things for the module. For example, enabling the NAT gateway for VPC. I need it. Why? Because I'm using Kubernetes cluster in the private subnet. So obviously my Kubernetes cluster has to communicate with external resources. So that is needed. And then I'm also enabling, the single NAT gateway. I'm enabling here, and I'm saying a single NAT gateway so that it is cost effective. And these are some basic tags. What is the tag for private subnet? What is the tag for public subnet? If you don't need, you can avoid this as well. Overall, instead of writing 100 lines for creating a VPC, we just wrote 17 to 30, just 10 lines of code, 10 lines of HCL file. That is the benefit of modules. Then EKS module, again, will not be passing huge details, just the source of the EKS module, version of the EKS module, what is the name of the cluster, what is the name of the cluster version. Similarly, some cluster compute configuration, the VPC in which the EKS cluster has to be, the subnets in which EKS cluster has to be, authentication mode, what are the log types that you need, basic information. Abhishek, where will you get this information also? See, one thing is you can go to the Terraform documentation, but This also comes with practice. Okay. If you go to Terraform documentation, you will find a lot of fields, but you only need to take what are mandatory for you or what are important for you. These are the important fields that you have to take for minimum EKS cluster configuration. I've used the minimum configuration that is needed. You can also use the same configuration and you can explain the same thing in the interviews as well. We used this configuration for EKS. Now, finally, you have to pass the actual variables, right? Here you only declared, but you did not define. Okay. I mean, you just defined the variable name. You did not declare the variable, right? You did not say what is the actual value of it. You said this is the default value, but what if we want to pass a value for the variable? What is your actual AWS region? You can do that using Terraform TFVARs. So in the TFVARs, whatever variables you took, you assign the actual values to the variable. AWS region is a variable that you define. Here you say the actual value of it. Environment, okay, you are saying this is a dev cluster. Name of the cluster, you are saying journey EKS. Cluster version, you are saying 1.32. VPC CIDR, you are saying the value. These values here can override the default values that you have in the variables.tf, right? What is the difference between variable.tf and Terraform TFVARs? In variables.tf, you initially define the variables. You define the default value of them. But in the Terraform.tf, you actually provide the values for the variables. And whatever you provide here, this will override the default values in the variables.tf. Perfect. And then the outputs.tf, whatever you want to see on the screen. Once your Terraform execution is complete, you have two options. One is you can go to the cloud platform. You can see what is the cluster that is created, what is the name of the cluster that is created, is it created with the right name? You can do it from the user interface. If you want to do it through the CLI, you can define something called outputs.tf. Okay. In the outputs.tf, you can say print the cluster name on the screen. Once Terraform execution is complete, print the cluster endpoint, print the cluster certification authority, print the VPC ID, print the region of the VPC as well as the cluster. Cool. So now let's proceed with the execution. Here on this machine, on the EC2 instance, we have the basic setup ready. It is connected to the AWS environment also. So what I'm going to do here, I'll just go back in the journey folder. I will switch git checkout DevOps branch. Okay. You have to check out to the DevOps branch because only here you have the Terraform code. Then let's switch to the Terraform. Okay. This is the Terraform files. These are the ones. Start with Terraform init. There you go. So the basic Terraform initialization is going on. What is the basic Terraform initialization? Which provider it has to connect to? What is the provider configuration? Right? If there is any backend where you want to store your state file, right? All that configuration is done during the initialization. If you look at my provider.tf, there is also something called backend configuration, which we learned in our DevSecOps configuration or the playlist. How you can secure Terraform state file by using a backend. So right now, the Terraform state file, which holds the information of everything that you created using Terraform, will be stored on this machine. But if you don't want to store that on this machine, you can define a backend configuration so that your Terraform state file will be created within that S3 bucket. Cool. Now, before you execute, just run Terraform plan. Terraform plan will show you what all the configuration that will be created. Only if you're confident with Terraform plan, you can run the Terraform apply. It will say, okay, if you execute this Terraform files, 57 new resources will be created. Don't worry about the number, but Abhishek, why are 57 resources being created? I'm only creating VPC and EKS. There will be internal resources, right? Within VPC, you have subnets. Within subnets, you have routes, route tables. You have NAT gateway. You have endpoints. Then you have a lot of internal VPC components and Kubernetes related components. That's why it is saying 57 components will be created. Again, you can pause the video here if you're executing parallelly. Just go ahead and see what are all the resources that are being created. It will be very interesting for you. And also, it will be very insightful. Cool. Now, I'm confident with this because I wrote the Terraform script. So I'll just say Terraform apply. Okay. You don't have to be confident with the script that I've written. Just look at all the resources that are being created. Only then run Terraform apply. Cool. Now, this would take a lot of time. In fact, this can take up to 30 minutes as well. So what you can do while this is getting executed, you can go back, watch the video one more time, or you can look at the Terraform repository. Make sure you enter the value as yes. Otherwise, it will keep waiting. Click on yes. You will have roughly at least 15 minutes of time. Terraform execution is complete. It is successful. And even on the AWS console, I can see Journey EKS cluster. And importantly, status of the cluster is active and the version of Kubernetes is 1.32. But let's perform an additional check by deploying a simple resource to this cluster. One thing that you have to note, the banner here, end of standard support for Kubernetes version 1.32. So this is what I was talking about. While going through the Kubernetes version in the Terraform manifest, I told you I intentionally picked up 1.32 to show you that what happens when you pick up an older version. So right now, from March 23, this version is going to be out of support. So let's say there is some issue with this Kubernetes version, AWS will not take the responsibility. So as DevSecOps engineers, it is also important whenever you are dealing with Kubernetes, even Python packages, Terraform, make sure you use the up-to-date version. Otherwise, let's say this Kubernetes cluster is created in production. Today, there is no issue, but after 13 days, this will go out of support. Cool. So now, how do we connect this EKS cluster to our personal machine or AWS EC2 instance and deploy a sample pod onto this cluster? So for that, what you have to do, again, either take your terminal or take EC2 instance. It's up to you. The first thing that you have to do is use the AWS CLI command, AWS EKS update kubeconfig. So this is the command followed by --name, the name of the cluster, in this case, Journey EKS, --region, US East 1. Now this will update the kubeconfig configuration on your local machine. Again, for EC2 instance, whatever you're using. But one thing is that you have to have kubectl running on the machine. I already have kubectl running. Now I updated the kubeconfig. So if I just do kubectl get pods -a, I will get all the pods that are running on the cluster. Right now, there is nothing running on the cluster. Even if I do kubectl get nodes, you would see there are no nodes on the cluster. But Abhishek, why is the case? We created the Kubernetes cluster using Terraform. Why are there no nodes on the Kubernetes cluster? If you remember, we created the cluster using EKS auto mode. What happens in the EKS auto mode? So EKS auto mode is just like serverless. And this is also managed control plane as well as data plane. So only if you create a pod on the Kubernetes cluster, or you create series of pods on the Kubernetes cluster, according to your requirement, EKS auto mode is going to spin up servers for you or worker nodes for you. This is taken care by Carpenter. You don't have to install anything. By default, EKS auto mode comes up with Carpenter. Carpenter is the one, it looks at the incoming pods and creates or sets up nodes to the EKS auto mode cluster depending upon the load. I'll show you. Now we will create a deployment, kubectl create deployment. Let's say name of the deployment is Nginx -- image Nginx : latest. Now, as soon as you do this, you will notice a node will be created for you. So initially, when you go to the resources, you would see the pod in the pending status. Click on the pod, look at the description. You will see no nodes available to schedule this pod. This is where Carpenter is working. Now Carpenter will get a status update that, okay, there is some scheduling that is taking place, but there are no nodes on the Kubernetes cluster. So let me create one. In next 2 minutes, you will have a node that is set up and the pod in the running state. Yeah, there is one downside of it. This will take little time because the nodes are not created out of the box. If you go to a usual Kubernetes cluster, it's not the case, right? Usually when you create an EKS cluster, you would set up node pool by yourself, where you might create 3 node cluster, 6 node worker node cluster. So as soon as you create a pod, one of the node will be picked up by the scheduler and pod is automatically scheduled on the node. But in this case, this is very, very cost effective. So that's why it will only create the node for you when you request for a pod. Let's see. I think this should be 2 minutes. I'll refresh the status. There you go. Now it is in the running status. This is exactly how EKS auto mode works. Even if I do kubectl get nodes, now you should see one node that is set up for you. If you create 100 Nginx pods, then it might create 10 Kubernetes nodes for you, right? Okay, so this part of verification is also done. So till now, what did we do? So we are done with the first step, setting up the application locally. Then we are done with infrastructure setup as well. That is using Terraform. We are successful with this step. Now let's go to the next step, containerization of the microservices. This is where a lot of DevOps engineers get scared. Personally, I've seen a lot of them worry about creating Docker files. Why? Because I keep hearing, Abhishek, to write the Docker file, do I need to know programming or do I need to know how the application is written? Let me tell you, this is absolutely not required. Because as DevOps engineers, you will keep working on different programming language applications. Today, you might have to containerize a Node.js application. Tomorrow, you might have to containerize a Java application, .NET application. The list can just keep going on, unlike developers, right? Because developers, today, if they work on a skill set, in the next company, most likely they'll work on the same programming language. So what you need to do as a DevOps engineer, you only need to learn the structure of the Docker file. If you know the structure of the Docker file, creating Docker file is a cakewalk because every time you do exactly the same steps. I'll explain you the structure here. Just remember, then for the front end, for the back end, we will follow the same structure. The first thing that you have to do is use a base image. Okay, this is the first step. How will you pick up the base image? Just go with the programming language that is used by the developers. In our case, React or NPM, that is part of Node. So we will use Node as a base image. If you are working with the Java application, you can use OpenJDK as the base image. If you are working with Python application, you can use Python Slim as your base image. The second step, choose a work directory. It's just like choosing a directory on your laptop, but in the Docker file, you choose a work directory so that all the commands that you're going to execute next, they will be executed within the particular directory. Let's say you download a file from the internet. If you choose a work directory, you are sure that the file is downloaded within a particular location. That's why you use the work directory. Okay. Then the next thing. Once you choose the work directory, go ahead, copy the dependencies. Again, if you are using a Python application, copy the requirements.txt. If you are working with Java application, copy pom.xml. If you are working with, let's say Go application, copy go.mod. In this case, we will copy package.json. Okay. Then execute the dependencies or install the dependencies. You copied them. Now you install. Then copy rest of the source code files, typically all the files. And then you will build the application, right? These are the steps that you need to follow. You have to do it step by step because Docker caches in terms of layers. And once you do this, this is where you can actually end. You can use an entry point and you can execute the build. But what we are following in this lecture is DevSecOps practices. So from security point of view, what we will do, we will go with multi-stage Docker build. So in the multi-stage Docker build process, we will use this as the first stage. And in the second stage, which you can also call as production stage, what we will do, we will again choose a base image, but this time we will go with a lightweight base image, or we will go with, if you are dealing with frontend, we will go with Nginx base image. Why? In case of frontend, Nginx receives the request and Nginx forwards the request to the frontend, right? We already learned that during the theory part. User's request goes to Nginx and Nginx forwards the request to the frontend so that it can block certain requests, it can proxy the request, it can implement SSL for your frontend, it can implement DDoS attack prevention, anything, even web application firewall. So we will use Nginx as the base image for frontend, and we can use any other base image like a Distroless or lightweight base image for the backend. And then we will copy the artifact that we got in the first step. So when you run the build command, you would get something in the dist folder if you are working in the Node.js application. If you are working with, let's say, Java application, you get a jar file here, right? If you are working with, let's say, Golang application, you get a self-contained binary. In the production stage, just copy this binary here and use the non-root user, another good DevSecOps practice, so that you don't run your container as a root user. And finally, use the entry point or CMD. That's it. So this way, you will not have your source code, you will not have the dependencies and any unwanted things in the production stage or in the second stage of your Docker build. They are all part of your build stage of the Docker file. In the production stage, you will have a lightweight image so that there will be very less security issues potentially. You will copy the artifact that you got from the first stage. You will use a non-root user, another important security practice, and using command line or entry point, you will execute the binary. This is the process that we are going to follow. If you remember this process, any Docker file you can write effectively. And now we will do the same process for our front end first. I'll take my Visual Studio Code so that it is easy to write instead of using the terminal. I clone the repository here. I'll head to the front end folder. I'll go to the SRC, and within the SRC, I'll start writing the Docker file. So I'll create a file here, new. Let me call this as Docker file. Or, there is no hard requirement that you only have to put it within the SRC. If you want, you can also put it at the parent level. For example, within the front end, just create a new file and call it as Docker file. This is also good enough. Okay, so let's start writing the Docker file. As I told you, the first step is going to be from, we will use a base image. In this case, Node is the base image. Choose a version of Node. I'll go with 20 Alpine. You can also get this from Docker Hub. If you're not sure, Abhishek, how do I get the Node.js base image? Just go to Docker Hub and here search for Node. Okay. And you will notice, so this is the official node images, Docker official image. Click on it. And here you have all the versions. Abhishek, why did you go with 20? Because the latest version is 25. Very simple. I am intentionally taking an older version so that our CI/CD pipeline will break. I want to show you how an DevSecOps pipeline looks like. So we cannot take a perfect application. We want an application that is flawed. We want an application that breaks on our DevSecOps pipeline. That's why I'm using an older version. If you want to go with a perfectly executing CI/CD pipeline, then choose the latest version. I'll provide an alias to it as build. Cool. Then the next step, as I told you, go with the work directory. We will choose /app as a work directory. Then we will copy the package.json. So use the copy package.json, and in some cases you also have to go with package.json star. Okay, this is not required for every front-end application. At times when you have package JSON log file, or when you have similar files, you would go with this. And where you want to copy? You want to copy it to the work directory. So just say dot. And then the next step is to execute the dependencies. How would you do that? Run npm CI. And also you can just do npm cache clean -- force. Abhishek, how do you know these commands? That these are the commands that you have to use? These are actually provided in the setup.json as well. If you go to deployment folder, if you look at setup.json, to run the application locally, almost the same steps are followed. Okay. So you can either follow the instructions from here, or when you are initially writing the Docker file, you can also ask the developer. Cool. Now let's copy the rest of the files. Copy everything to the app folder and run the build process. npm run build. Right? The same thing that I explained here. I followed the exact same instructions. You give me a Golang application, I'll follow the same steps. You give me a Python application, I'll follow the same steps. Okay. Now, because we want to build a DevSecOps architecture, we want to do everything secure. Let me call this as final stage, or you can also call it as production stage. And this one, let's just leave a comment here for easy understanding for others, that this is the build stage. Abhishek, is it common to have only 2 stages? Yeah, usually you have only 2 stages, but it doesn't matter according to your application. Let's say you are dealing with a complex service where you are building the front end, back end as part of the same microservice. In fact, you can go ahead and you can create multiple stages as well. Okay. So there is no hard limit that you only have to have 2 stages in a Docker file, in a multi-stage Docker file. Okay, because we are dealing with front-end application, we will use nginx as the base image. nginx :27 -alpine. Again, you can get this from Docker Hub. As production. What is this as? This is basically a alias we are giving to this stage. Cool. Now, usually when you use nginx as the base image, it's a security best practice to remove any kind of existing nginx configuration, because we are going to place our application within the nginx folder, or our artifact within the nginx folder. So that's why I'm removing the default one. I mean, if you have used nginx in the past, when you install nginx, by default, if you run the nginx web server, you see index.html, where you see something like hello from nginx, the out of the box one. We are just deleting that one here because we don't want to see that. Instead, we want to see our application served by nginx. Cool. But Abhishek, where is our nginx configuration? It is already here. If you look at the front end, you will find nginx.conf file here that is initially written by the developer while they are working on the local development of the application. So just copy that. Copy nginx.conf, which is here, to the nginx location on the Docker image. /etc/nginx conf.d default.conf. This is where you have to place. Now it's the final step. I mean, the important step. This particular command in the build stage would have created a binary. Basically, that is in the /app/dist folder. So we will copy /app/dist, the content of the dist folder, to user nginx HTML folder. Okay. That is the most important step where we are copying the output of our first stage to the final stage. Now what happens? The front-end application is in this particular location. User share nginx HTML. Now, if this is in this location, what nginx does, instead of serving the default index.html, it will serve your front-end application. Cool? So this part is clear, right? We are copying the artifact from the first stage to the final stage, where we are placing our front-end application in this particular location. When you place front-end in this location, user requests nginx, nginx automatically forwards the request to the front-end. And for security best practice, let's create a user and let's grant permissions to the user. So I'm creating a user called nginx. I mean, in the nginx base image, the user is available out of the box. So for the nginx user and nginx group, I'm granting permissions to the nginx HTML folder. And we will say go with the user nginx so that the container runs with the nginx user instead of the root user. There are several disadvantages when you run your container with a root user. Basically, I'll give you one example. I've covered that in detail in our DevSecOps playlist. But if you run your container as the root user, anyone who gets access to the container, if your container gets hacked, potentially they can get access to your entire system. If you're running it on Kubernetes, they can get access to your entire Kubernetes cluster as well. So it is not a good practice to go with the root user. Let's expose the port, expose port 8080 or whatever is the right port. And in the CMD, we will just say nginx, right? We are running nginx -g. So basically I'm starting nginx here. Daemon off. Okay. So this is our final step. Now we are good to go. Nginx -g daemon off. So this is the Docker file for your front end. If you master this particular example, trust me, tomorrow you work with any front end application, you will be confident. Even in the interview, if they ask you to write a Docker file, you can write the same Docker file because we followed security best practices and also we wrote a perfect Docker file for the front end application. We will execute this, okay, and quickly verify if this is working. So I'll go to the folder. So the folder name here, my bad. So let me go to journey first, and here let me go to front end. We have the Docker file here. Let me see if my VS Code is syncing right. Okay, so they are perfectly synced. Now you need to have Docker running on this machine. If you are going with an Ubuntu instance, Docker should be available out of the box. You can use the Docker. If you are using your personal machine, just start Docker. So I'll run this command, Docker build -t front end. I'll just call it as front end. Yeah, I think it's okay. :latest dot. So basically, I'm creating the Docker image with this particular tag, front end latest, or let's say journey front end. Even simple way of understanding. Let's see what happens. It's okay if there is any issue, we will immediately try to address it. Nginx failed to resolve metadata. So it says, Abhishek, you are using a wrong base image. This one does not exist. Maybe there can be some typo here. Oh yeah, there you go. So there is a simple typo. It's not Nginx 27, it's 1.27. How did you figure out? You can go to the Docker Hub here. In the Docker Hub, search for Nginx. You will find the official Docker image for Nginx. Click on it. You will find set of tags. What we are using is 1.27, right? But Abhishek, why are you going with again not the latest version? As I told you, we want to see some issues with the Docker image. That's why I'm using an older version. Cool. As part of DevSecOps, we want to identify some issues. That's why we are intentionally using old versions. Let's rerun this. Oh, is it not saved? Again, it says the same thing. Maybe I did not save it well. Vim Docker file. Or let me go back to my VS Code. It's easy to address there. 1.27. This is cool. It's updated here. Nginx 1.27 Alpine node 20. Okay. So let me do it one more time. Docker build. I'll just change the tag of the image in case if it is caching the information. Cool. So that part of the Docker image went ahead. That part of the execution moved ahead. Now it is complaining about the package.json. Okay, this is fair enough. If you see the files here, there is only package.json. There is no package.json star. That's why it is saying I could not find package.json.star. That's a simple thing to fix. In fact, you will not run into this issue. Personally, why am I running into this issue? Because I used EC2 instance for the running the application locally to just show you. And here I'm using my personal machine. The reason for using personal machine is simple. I want to show you how to write the Docker file using VS Code. So that's why I'm just using my local machine for the next steps. Cool. How this can be fixed? If you just run npm install, it will generate the package log.json. So I executed npm install. Now, in the front end folder, I have package log.json as well. Now let's retry. I'll run the Docker command again. This time, I guess it should pass. Okay, looks like it is going well. So it is executing the last step of the first stage, run npm CI and run npm build. And then it also executed the production stage. It says, now we have the Docker image ready. Cool. So the front end Docker image is ready. Now it's time to go with the backend Docker image. Again, I'll go to the backend folder now. So this is the backend folder. I'll click on create a new file and Docker file. Okay. So let's start writing. It will be the same thing. As I told you, we'll follow the same architecture of the writing Docker file. So this one here, whatever I showed you. First, base image. Second step, work directory. Third step, copy the dependency files. Fourth step, install the dependencies. Fifth step, copy rest of the files. Sixth step, execute. I mean, in all the applications, it is not possible to execute, but if there is a chance, execute it and then go with the final stage. Okay, so we will start writing the backend one. I'll go back to VS Code. First, base image from node :20 -alpine. We'll give an alias to this as well as build. Abhishek, why did you choose the same base image for front end as well as back end? When you are working with JavaScript based applications, it's most likely you are using the front end, back end, everything in the JavaScript family, where you would use npm as your dependency manager. So that's why we are using node as the base image. Okay, let's say you are using JavaScript for front end like React. and you're using Python for your backend, let's say you're doing that, then in the Python backend, you have to change this base image. This would become Python. Next step, work directory. You can go with /app. Next step, copy the package.json. Along with that, copy any similar entries like package-log.json and anything else to the dot. That is this particular directory, the /app. Then we will install the dependencies, run npm ci. Okay. And again, npm clean cache --force ampersand this one. Cool. So we are installing the CI dependencies. We are using npm class clean --force. And for npm CI, if you are working with the application in production environment, go with -- only production. What exactly this is doing? So sometimes you might have dependencies related to production, dependencies related to dev, staging. So just say -- production. And for the backend, especially in this case, you don't have to copy the rest of the files and create the backend at this point. What you can directly do, you can go with the production stage itself. So *production stage, where I'm just providing an alias to the production using node alpine image. But Abhishek, why are you not executing the dependencies here? In our case, why are you not installing the application by building it? We don't have to build the backend because our backend is very, very lightweight. We can directly execute the backend in the production stage itself. Instead of creating the backend build in this stage and copying it to the production stage, if it is lightweight, you can directly do it in the production stage itself. Okay. So we will create a user and a group. Last time we did not do it because we used the Nginx base image. In the Nginx base image, we already have something called Nginx user. So we did not bother about it. Right now, we want to follow DevSecOps practice. We want to run the container as a non-root user. So I'm just creating a user in this Docker image. And then we will install the required dependencies. Then we will create a work directory. In this case, /app is a work directory. We will copy the source code along with node modules. Where did you get the node modules? You ran the dependencies here. So we are copying the dependencies. The node modules, in the case of node family, the dependencies are called node modules. So we are copying it to the final stage along with the source code. We will use the app user, the one that we just created here, to run the container. So non-root user called app user. We will expose the port, expose 5000. And finally, in the entry point as well as CMD, we will directly execute the JS image, src index.js. I hope you understood this point. Why are we not running the npm build command in the first stage? Because we just have a single index.js file, very, very lightweight one. It doesn't make sense. You create the binary here, then you copy it here. If you just have to run this single command, you can directly do it in the production stage itself. Okay, cool. So this is our backend. Let's try to verify this is also working fine. Intentionally, I did some security mistakes in this Docker file. Using the old image here as well. And even the dump init, the package that we are installing, this should also come with a specific version like 21, 22. We should not be using latest because the behavior keeps changing on every Docker execution. Let's say today the dump init version is 20. Tomorrow it is 21. Day after it is 22. Every time you build a Docker image, there will be the difference in the behavior. So always you have to pin the versions, pin the images to a particular version, just like how we did here. So I did 3 intentional mistakes in this Docker file so that our DevSecOps pipeline, the one that we are going to build, will fail on the Docker file. Cool. Okay. So I'll go back to the terminal. Docker build -t. Let me call this as backend colon latest dot. Oh, my bad. I have to switch to the backend folder. Let me do that. And rerun docker build -t backend colon latest dot. Okay, let's verify. Yeah, so the build execution is complete. We have Docker file for frontend and Docker image for frontend and Docker image for backend as well. Abhishek, what about database? You don't need to create Docker images for databases because databases Docker images are already available in Docker Hub. For example, we are using Postgres. So just search for Postgres. You will find the Postgres SQL official Docker images. You can go ahead and use them, right? Why you have to do things from the scratch? You don't want to get the Postgres source code. You don't want to create a Docker image for it. Instead, use that is already available. Okay. So we created, let's go back to our status. Where exactly are we in? So we ran the application locally. We created the infrastructure. We created the Docker files. We created Docker image for front end, back end as well. For DB, it's not required. We will use the one that is available. Now it is time to create a Docker Compose file. But Abhishek, why is Docker Compose needed? Very simple. When you are working with multiple microservices for a company or for a project in the company, it is a good practice to create a Docker Compose file. Why? Individually, in this case, we have 3 containers, right? What if you have 10 containers? Or what if you have 5 containers? Every time there is a change in the Docker file, every time you want to build a new version of your application, you cannot keep running 10 different Docker files, right? And in fact, once the Docker images are created through the Docker file, in this case, we created the front-end image, we created the back-end image, and we are using a DB image. But how will they interact with each other, right? How will you make sure they are all in the same network? How will you make sure front end can connect to the back end can connect to the database through the password, right? Your database will have a password, right? So you have to provide the password as an environment variable, or you have to provide the password through some configuration. What I'm trying to say here, just by creating the containers, your job is not done. Your responsibility is to make sure they all come up as a project. All the images talk to each other. They are within the same network. They have the volume requirements. They have the environment variable requirements. So all of that you can do using Docker Compose file. It is a one single file that helps you run multiple Docker images in the order of dependencies and with every setting and configuration that is required. Who has to write the Docker file? Docker Compose file? You have to do it. Just like how you created the Docker files, you have to create Docker Compose file as well. Is it complicated? Not at all. There is a simple structure for the Docker Compose file. I'll write it again for you. So to explain it in the easy way. So the structure of the Docker Compose file, you will start with services. What are services? Front end, back end, database, the microservices. So under the services, just start with, let's say, front end service. Okay. You will provide the configuration of the front end service. You can just say either provide the Docker image directly or just say from where it can build the Docker image. So just provide the path of the Docker file. Along with that, any environment variables that you want to pass. For example, the API tokens, passwords, secrets, anything that you want to pass. And any volumes that you want to deal with. Once you're done with the front end, similarly, create under the services. This is basically a YAML file. Under the services object, you created front end. In the same way, create one for the backend. Again, either provide the image directly or provide the location of the Docker file. Then the environment variable, the password to connect to the database, etc. Finally, DB. Okay. So even for the DB, you will provide the configuration. And then at the services level, you will create a network. If you want to create a new network, you will create a network for all of these containers. If you want to create any volumes, at the services level, you will also create volumes that are required. That's it. If you do this, your Docker Compose file is ready. And when you execute Docker Compose using Docker Compose up, this is the command to run. Once you run Docker Compose up, all the containers will be started and your project will be running on your local machine. This is very, very beneficial for QA engineers, developers. If they ask you, Abhishek, I want to set up this project on my laptop, just tell them install Docker, execute this Docker Compose file using Docker Compose up, and you will have everything running on your machine. You don't need to know Docker. You don't need to know how to run, how to read a Docker file. You don't need to know anything related to Docker. Just install Docker and run this command, Docker Compose up. That's the beauty of Docker Compose. Cool. So how will we write the Docker Compose file? So in this main branch, you can just create a Docker Compose file at the parent level folder, right? That is at the root of the repository here. So we will have to create a Docker Compose file. Okay. So here, let's create a new file, docker-compose.yml or YAML. It's up to you. Let's start. So we will start with the services. As I told you, what microservices are we dealing with? We'll first deal with the database microservice. So DB. For database microservice, we are directly using the image. We are not using the Docker file, right? So let's just say Postgres. What is the Docker image that we're using? :16-Alpine. I'm using an older version again for the same reason. But if you want, you can just go with the latest version. Okay. And then the name of the container. If you want a name for the container that is created, you can just say container name. I'll just say journey-db. So Docker Compose file can also create the images for you. Just like how we did by running docker build-t, right? You don't have to do it when you have Docker Compose. It can not only start the containers, but it can also build the images for you, right? In this case, I'm just providing the image name directly. If I provide the Docker file here, it will create the image. What we will do for front end and back end, let's give the Docker file. Although we created them already, but just to show you, for front end and back end, I'll give the Docker file to Docker Compose. But for database, I'll directly provide it with the image. Cool. So image name, container, and there is also a cool feature of Docker Compose. For some reason, if your container goes down, you can say restart the container. So unless stopped for some reason, do not restart. So if my container goes down, maybe because of resources, because of CPU, memory, anything, just restart the container. This is a cool feature, the one that you get with Kubernetes as well. Then the environment variables. Definitely we need environment variables for the database. So I'll just say the Postgres username, Postgres password, and the Postgres DB. Why you need this? Obviously, you are starting the database container. So the database container will have the Postgres instance, and the Postgres instance should be created with some schemas, or it should be created with some tables. For all of that, you need a database user, database password, and name of the DB that it has to connect to. Then the ports, we usually have only one single port when you're dealing with database. So what you can do, you can map the port of the database that is running within the container to the port of your local host. How can you do that? Let's say the port is 5432, which is the default Postgres port. We will map it with port 5432 on my local machine as well. Again, you are dealing with database. So you also need volumes. So volumes only for database, the number of steps are usually more. So volumes, just provide the volume mount. So PG data is the volume that I am mounting to this specific location within the container. But Abhishek, where will you create this volume? Like you haven't created the volume called PG data. We will do it. After the services definition is complete, what I'm going to do at the same level here, I'm also going to create something like this. Volumes, PG data, driver as local. When you add these fields in the Docker Compose file, it is exactly same as Docker volume creation command using your Docker CLI, right? Docker Compose file will not do anything extra. It will do only things that are supported by Docker CLI. But only thing is that we are not running the Docker CLI commands. We are putting them in the YAML manifest so that all the commands can be executed at once. This one here is running the container for you. This one here is creating the volume for you. Similarly, I will add another container for front end, another container for back end. All the steps will be executed in the same order. Okay? Unless you maintain the dependencies. If you want, you can also add some health checks. So I'm going to add the health check here to just make sure the database container is started and everything is good. This is optional only if you want. Now, similarly, let's go with another service. So I'm going with the backend service now. I'm done with database. I'll start with the backend service. So here at the same level, I'll just say backend. And as I told you for backend, instead of directly using the Docker image that we created locally, I'll provide the build context. I'll say build context. I'll provide the location of the Docker file. It's in the backend folder, right? Docker Compose is here. This is the backend folder. Inside the backend folder, there is the Docker file. So I'm just providing the path of it. Okay. Then also say the name of the Docker file, because in this folder, it has to know what is the name of your Docker file. I'll say the same name, Docker file. If you have a different name, you can go with it. Then just say here, let me just fix the indentation a bit. Okay. So next thing, the name of the container underscore name. I'll just call it as journey underscore backend. I'm following the same nomenclature. I'm calling the database name as JourneyDB. I'm calling the backend container name as journey underscore backend. What next? We'll follow the same practice, restarting the container unless stopped. Okay. Environment variables. Even this time, we have to pass the database related environment variables because backend will connect to the database. So I'm saying environment 5000, DB username, DB password, everything that is required. Expose the port. So eventually backend should be connected to the front end. So I'll expose the backend on the port 5000. And Docker Compose should first start the DB container. Only then it should start the backend container. So I'll use this depends on tag. Something like this. Depends underscore on colon DB. Now this is backend container will only be started once the DB container is ready. And also I'll just say there is a condition. Not only DB container is started, but the condition is that DB container should also be healthy. So service underscore healthy. I hope this is clear. The depends on tag says that only start the DB container once database is completely ready. And because you are providing a condition also, it will wait till the service is all good. And some security related steps here. So security, where I'm saying no escalated privileges are required, just run the backend container with the user that is provided in the Docker file. Now finally front end. Okay. So even for the front end, we will use the same thing, name of the service. I hope the indentation is correct. Yeah. Here for YAML, you have to be little careful with the indentation. Front end, of course, I can write this entire file using some plugins in Visual Studio Code. I can write it by taking help of GitHub Copilot, but I'm intentionally writing it so that you also understand what steps are involved. Build, either provide the container image or just say context dot slash frontend folder. Docker file is here. What is the name of the Docker file? The name of the Docker file is with the same thing, Docker file itself. Name of the container, let's call this as journey underscore frontend. This should be the name of my container, or hyphen. Did we follow hyphen or did we follow underscore? Let me see that. Okay. So here we used hyphen, container name journey hyphen DB. Here we used underscore. Let's follow the same standard. Journey hyphen backend, journey hyphen DB, and journey hyphen frontend. Restart policy, only unless stopped. Then port mapping. What ports do we want to map while running this container? Front end is running on port 80, right? So I'll just say 80, 80, 80. So this is the internal port mapping. So port mapping of the application running inside the container and my local machine. Okay, this is also well indented. All good. Now, depends on. Is there any dependency for front end? As you can guess, a front end without backend doesn't make sense, because everything that we are seeing here, all the information should be populated from the database. It should be populated from, the blogs that are created, it should come from database, and backend should fetch it from the database. So your order of starting the containers, you should first start database, then you should start backend, and only then you should start the front end. So that's why depends on backend, where backend is internally dependent on the database. Just provide the security option one more time in the front end as well, so that your front end does not run with escalated permissions. There you go. Your Docker Compose file is ready. That's it. So this is how you write the Docker Compose file. When you look at it initially, you might feel that, oh, this is a 66-line YAML file, but we just wrote it in 10 minutes. And there is no additional thing here. The same fields that you have to follow. The services field, which will have the list of microservices. And each microservice has the same fields. Within the DB, image, container image, restart, environment, ports, volumes, health check only if needed, and any security related thing. Even in the backend, build, container name, restart, environment, expose, depends on security settings. Same in the front end as well. So this is where people ask me the question, do I need to learn Docker Compose file? Do I need to learn Docker file? Will I be asked in the interview to write Docker Compose, to write Docker file? Answer is simple. Just remember the structure. See, nobody is a superhuman. Nobody can remember everything. But if you remember the syntax, if you remember the fields that are part of important fields that are part of Docker Compose, Docker file, Kubernetes manifest, that is good enough. Explain them. This is how I'm going to write the structure of the Docker file, and you will definitely clear the interview. Cool. Now let's verify by running this Docker Compose as well. What should this Docker Compose do for us? Step one, it has to build the Docker file for front end and back end to create Docker images. Okay, even before that, it has to pull the database related Docker image, and then it has to build the Docker files for front end and back end. It will first start with the database as per our order that we provided. So once the database image is pulled, then it will start the database container with all the settings that we have provided, the environment variables, the security settings, the health check settings. And once the health check is successful, then it will go to the backend service. And in the backend service, as I told you, it will first build the Docker image. Then it will configure the environment variables. It will see if it can connect to the database. And if it can connect to the database successfully, again, it will start with the front end. Cool. Now it will create the front end image and it will verify if front end can interact with the back end. That's all. This is what Docker Compose is going to do. How can we run Docker Compose? Take the terminal. At the same location of the Docker Compose file, we are not there. It is somewhere here. Okay, this is the location of the Docker Compose. At the same location, just execute this Docker Compose YAML file. What is the command to do it? Docker Compose up. Let's do it. So going back, if you already have images that you created using Docker Compose, you can do this Docker Compose down. So first Docker Compose down is going to delete everything for you. Of course, I ran this application previously, so that's why I ran Docker Compose down. Now I'll run Docker Compose up -d. -d will start these containers in the background, and you will not see the logs of the container when they are starting. Okay, so it is taking time to pull the journey DB container, but otherwise, rest of them, because there is some Docker caching on my machine, previously executed it. That's why it was very, very fast. Now let's verify. Okay, Abhishek, you ran the Docker Compose as well. Now let's try to see if on my local machine, I can access the application. Okay, so all the containers are started, the front end, back end, database, everything is configured, everything is connected to each other. So let's verify if the application is running through the Docker Compose. On which port should we access it? Front end is running on port 80. So you can see here, we expose the front end port to 80. So we will request the front end. So request goes to the front end container. From there, request goes to the backend container. From there, request goes to DB container. We don't have to bother about it. We will head to the local host. I'll take a new tab, local host. I'll not provide any port because the port is 80 and click on the enter. There you go. So we have the application running on port 80. Okay, how is that possible? That is possible through Docker Compose. Now, if I click on anything, for example, new post. So we got these emojis, we got this basic information. This is coming from the backend. So this is coming from the database and backend fetch this information for us. So overall, the Docker Compose part is also successful. Where are we right now? Let's go back to our initial stage, the one that we documented, the list of steps. We are done with the application running locally, infrastructure, Docker file, Docker images, Docker Compose, Kubernetes cluster creation. Now, only thing that we are left with is Kubernetes manifest creation, which is not going to take a lot of time, and CI/CD pipeline setup. Okay, let's even take a look at them step by step. Let's start by listing down the Kubernetes manifests, right? So what all resources that we have to create in Kubernetes? From Docker Compose, it's clear what we have to create. We are done with it. But for Kubernetes, we have to create few more resources, starting with Okay, let's start with the obvious resources that we have to create. So there is front end, there is back end, there is database. For database, deploying database to Kubernetes requires dedicated resources. First, you can create the deployment instance. So for database, you can either go with deployment or you can go with stateful set according to your requirement. In this case, deployment is fine enough. But along with that, you can just not create the deployment for the database, but along with that, database also needs a volume, right? It needs a persistent volume. How can you create that? So with deployment, you have to create a persistent volume claim and you have to create a storage class. This is how you create a database within the Kubernetes cluster. You have to create either deployment or stateful set. Then you have to create a persistent volume claim that is going to create a persistent volume for us. But for that, persistent volume claim looks for a storage class. Let's try to understand what is a storage class resource. Let's say you are creating this on EKS, the way which we are doing. On EKS cluster, you have volumes like EBS, right? EFS, AWS, FSx solutions. Which one is your Kubernetes pod going to use? In this case, which one is the Postgres going to use? You have to provide that information. So you can say, I need 10 GB of volume, but do you need EBS volume? Do you need EFS volume? Do you need FSx volume? That is defined by the storage class. So as DevOps instance, whenever you are dealing with databases in your organization, just first create a storage class in the Kubernetes cluster. That will tell any database deployment that it has to get the volume from these particular options. If your storage class is EBS, then persistent volume claim, if someone creates a persistent volume claim of 10 GB, right? The persistent volume claim asks the storage class creates a EBS volume of 10 GB. Similarly, if someone creates 20 GB, same thing. EBS volume of 20 GB is created. Now, once the deployment related things for database is done, you have the front end. So for the front end, you will create a deployment, right? Plus you will create a service. For the backend, again, you will create a deployment and you will create a service. But we want to do it in the DevSecOps way, right? So we want to secure everything as much as possible. So for the backend deployment, let's say this is front end, this is backend. So for the backend, we will create a network policy as well. Network policy in Kubernetes creates an admission controller. Anyone who tries to connect to the backend, network policy first intercepts the request and it will see if it should allow the request to backend or not. But Abhishek, why do we need a network policy? Very simple. Your backend should only be accessed by the front end. Why should your backend be accessed by the hacker, let's say, or some other pod in the Kubernetes cluster? That should not be the case. So we will create a network policy and we will only accept the request if the request is coming from the front end. In the same way, even for database, we will create a network policy. Any guesses? Who should access the database? It should be backend. So in the network policy for DB, we will say allow only requests from backend. For front end, it is not required because front end is exposed to the internet. You don't have to do anything. And then for the backend, we will also create a secret. Secret so that it can sensitively connect to the database. So the database credentials are stored within the secret. These are the resources that we are going to create. Let me list down here one more time. So for the front end, we will just create deployment. Then we will create SVC. This is for front end. For the backend, we will create deployment. We will create SVC. We will create database secret. This can be for database instance as well. Plus we will create a network policy. For database, we will create a deployment. We will create SVC. We will create persistent volume claim, we will create storage class as well. So these are overall resources that we are going to create. I might have missed one or two. I think I haven't missed, but if I miss one or two while creating the Kubernetes manifest, we can recollect that. But overall, these are the important resources. Now you have two options. One, individually you can create YAML file for each of them. But because we are doing the demo, it will be little difficult to create one to like almost 11 resources. So what I'll do, I'll create a single YAML file. Okay, it will be easy to deploy as well. I'll create a single YAML file and I will call this as journey.yaml file. Okay, in the journey.yaml file, we will have all of these resources. So it is going to be a very huge YAML file, but that's okay. Okay, so I'll go back to my VS Code now. I'll close all the tabs. I'll just maybe create a folder called K8s here. You don't have to do it in the main branch. Okay, in my case, I'm just showing you by creating this in the main branch, but during your learning process, you know where all these manifests are. Once again, if you head to the DevOps branch, in the DevOps branch, you can find all of them in place. I created this branch for you. CI/CD is also running. Kubernetes manifests are in the working state. Docker files are in the working state. Docker Compose is in the working state. This is your blueprint. At any point, if you're stuck, head to the DevOps branch, look at the manifests here. And once you're comfortable, do the project without looking at these manifests. Cool. So journey.yaml. I think I just messed up a bit. Let me move this to trash, and inside this, let me create a new file, journey.yaml. Okay, perfect. So now you can start in any order. In Kubernetes, it does not matter. If you are following health check, you can follow any order. So I'll start with creating the resources. First thing, I'll create a namespace. Okay, this is one thing that I forgot. To create a namespace, I'll use this syntax. Okay, so API version is v1, kind is namespace, and I'm just providing some basic metadata, the label for the namespace and the name of the namespace. Then we will create a secret for the database password. Okay, so this is the one that I'm creating, the database secret. This has the database username. This has the database password. Cool. So this is also fine. Next thing. But Abhishek, how did you get this database username, database password? We already have that, right? If you look at Docker Compose file, we have the database username. We have the database password. Just encode this in the base64 format and paste it here. Or just copy it from here as well. Okay. Then, as I told you, you have to start with creating a storage class. So for storage class, we will be using the EBS storage class, which is very easy. When you use EBS storage class, as I explained here, if you create a persistent volume claim for the database, the persistent volume claim will talk to the storage class, and storage class within your Kubernetes will create EBS volume with the required size. And this is the storage class YAML manifest. Name of the storage class, I'm saying it should be EBS volume. Type should be GP3. In EBS, you have GP2, GP3 types. So I'm saying GP3 is the type. And I'm just saying reclaim policy as retain. Cool. Then comes persistent volume claim. Before creating the database related deployment, I'm creating persistent volume claim and storage class as well. And if you notice here, I'm saying my database would need 10 GB of EBS volume. Cool. Now the actual database deployment. So for the database deployment, we will use the Postgres official image. Because it has health checks also, you might find the database manifest a little big, but in the spec, we are saying the replica count is 1. we are following the rollout strategy, and then we are defining here. So this is going to be the container. Name of the container is Postgres. We are using the same image, the one that we used in Docker Compose, Postgres 16 Alpine. The container port is 5432. We created a secret file. We are using the secret reference in the deployment so that it can access username, password. And this is the volume mount for the storage class that we created. So 10 GB of EBS volume will be mounted in this particular location. We did in fact same thing with Docker Compose as well, but in the Docker Compose, we created a local volume. Whereas in the Kubernetes manifest, we are using EBS volume. Okay, then now we are done with the Postgres database deployment. Let's create a service for Postgres. This is the one. So in the service, I'm just saying the target port is 5432 and the port the service should be accessible is also on 5432. This is perfect. Now let's head to the backend deployment. Labels are important. Okay, I'm not focusing a lot on the labels, but take some time, look at this manifest, see how I define the labels. It is unique for every resource that I'm going to create. Especially, this is unique for the database deployment, the backend deployment, the front-end deployment, because in Kubernetes, service identification happens through the labels and selectors. Service discovery. Okay, now let's go with the backend deployment. You might have a question here, but Abhishek, when we are dealing with the backend deployment, how did you come up with the image name? Okay, because here we created a Docker Compose image, that is fine, but the image that we created is still on your local machine, right? If I do Docker images here, I have the image, but this is not pushed to the Docker Hub, right? Journey backend latest or Abhishek.Fi journey backend latest, this is not pushed to Docker Hub. Yeah, we have to do it. Okay, first of all, we have to define that. What I'm going to do, journey frontend latest is the image, right? So this is the one that we created through Docker Compose. I will tag this Docker tag this one as Abhishek.Fi, which is my Docker Hub username, followed by the same thing. Journey, we copied for the backend. Sorry, this is the front end. So I'll just say journey front end latest. I already did it because I wanted to, before doing this entire demo, I verified it on my Kubernetes cluster. During that time, I already tagged this image to Abhishek.Fi journey front end latest. I tagged this image to Abhishek.Fi journey backend latest. So both of them are already in my Docker Hub. I'll show you. So this is Docker Hub. Go to Abhishek.Fi. Okay. So these are my repositories. Here, if you search for, or directly let's search for Abhishek.Fi journey frontend, you would find it. See, it is pushed. Okay, and I verified it as well. Similarly, I pushed journey backend also. In your case, please execute these commands. First, tag the Docker image. Instead of Abhishek.Fi, you should go with your Docker Hub username and then just say Docker push followed by this. In case you run into any authentication issues, first run the Docker login command. I'll repeat this. With Docker Compose, we created the images, but the images are on our local machine. What you ideally need, you need these images to be pushed to the Docker Hub. Only then you can access them within the Kubernetes cluster, right? So first do the Docker login on your machine, then tag this image. The one that you have on your machine now is journey backend latest. Tag it to your username / journey frontend latest, journey backend latest, and then use the Docker push command to push it to Docker Hub. Perfect. Without pushing it to Docker Hub, if you try to run the Kubernetes manifest, you will see the pods are in the error state. Okay, perfect. So now, just like backend, let's copy the front end as well. Okay. My bad. Before that, let's copy the from the GitHub repository. Let's get the backend service configuration. This is the one. Okay. So in the backend service also, what is important? The target port and the port that you're going to use. Then let's copy the front end configuration. Where am I copying it from? I'm copying it from our GitHub repository itself. Okay, this is my front end deployment configuration. Okay, so I have the front end deployment configuration. Similarly, front end service configuration as well. How are we going to expose the front end service? Abhishek, end of the day, your Kubernetes cluster is in EKS. It is within a VPC. How are we going to access the front end that is deployed? You have two options. Either you can create an ingress or gateway API, or you can port forward the service. We will go with port forward, right? The service that is created, we will use kubectl port forward command and we will access it. If you want to use ingress or if you want to use load balancer service type, you are free to do it as well. Finally, network policies that I mentioned. This is the important part. This is the DevSecOps part that we are dealing with here. Okay. So, oh my bad. I was copying in the journey YAML file. I'll fix it. But the network policies are very important. So the network policy for backend and network policy for database. You have to explain this in the interview. When someone asks, how did you secure your Kubernetes cluster? Network policies is very important. Just say, whenever we are using database, for database resource, we are creating network policy. It uses the admission controller concept and it will only allow requests from the backend pod. Where did you define this in the network policy? If you look carefully, this is a network policy for database. Okay. So network policy is applying for the journey DB, which is my database pod, and it is only allowing incoming requests. Ingress means incoming requests from the journey backend. It totally depends on the label. And where is this label? This label is on the backend pod. Okay. Similarly, network policy for the backend, you can see here, this network policy is applicable for journey backend, and it will only allow the request from ingress from journey frontend. That's what we did. Cool. So this is about the Kubernetes YAML manifest. Now I'll just execute the kubernetes.yaml, and within few minutes, we should have all the resources on Kubernetes. Let's run the command. So where we have the Kubernetes manifest, I'll just head to the k8s folder and run this command kubectl apply -f journey.yaml. So this should set up all the manifests on our EKS. Again, this will take maybe 1 to 2 minutes. It might take more as well because we are using EKS auto mode. Every time the pods are created, the resources are created, Carpenter has to scale the cluster. Let's see. I'll refresh the page. The resources should be in the pending status at least. Yeah. So DB has started, but backend resources are still in the pending state. So that's good. It's actually very fast. We have the front end running, we have the backend related components running in the pending state, and we have DB also good. Cool. We'll only select the journey namespace. We are not worried about the other ones. There you go. All the resources are in the running state. In fact, it's much faster than I thought. Maybe because I already created a Nginx deployment. So Carpenter created a pod. It created a node for us. It is reusing the same node, I guess. If we do kubectl get nodes. Yeah, so the same node is being reused. The pods that we created, they actually have enough resources on this node. That's why it was faster. If you are doing it for the first time, if you haven't done Nginx deployment, don't worry. This might take up to 5 to 6 minutes as well, because Carpenter has to create an EC2 instance as a node for you. Cool. Okay, now we can verify. Let's see the services. kubectl get svc -n journey. I'm only looking for the front end service because this is what I'm going to access. Let me kubectl port forward. kubectl port forward followed by svc. I'll say journey front end. If it goes wrong, we'll fix it. We don't have to worry. Followed by the port is 80. I'll expose a very different port. Let's use 6666 colon 80. So I'm mapping this port of the service to port 6666 on my local host. -n journey -address 0.0.0.0. I'm mapping it with the local host. Let's see what happens. Okay, the port forwarding is good on the local host. Let's do this. Localhost colon 6666. Address is restricted. So address uses a network port, which is normally used for the purpose of web browsing. Okay, that's fine. Let's change the port and see. Instead of 6666, I'll use a different one. I used 8172. The same command, I just replaced 6666 with 8172. And this time on port 8172, I can access the application. In fact, this is new to me. I was not aware 6666 port is restricted. Good to know. Anyways, so we have our application running in Kubernetes as well. Please take some time to go through the Kubernetes manifest. While I explained you, it's not that easy. Especially, a lot of people have questions about database, how to deploy database in Kubernetes. Is it possible? It's definitely possible. In fact, it's not a rocket science. You just deploy it as a basic deployment. Only thing is that additionally, you have to create persistent volume claim and you have to create a storage class. Okay. Now, finally, we are only left with one thing. You all know what it is. It is the CI/CD process. But even till now, we considered a lot of security best practices. In fact, in every step we did that. When we started with infrastructure creation, apart from running the application locally. During the infrastructure creation, we did not directly create EKS. We considered security best practice. That is, we created VPC. Okay, let's write it down here. What all security measures did we take till now? One, we created VPC, virtual private cloud. Then we created private subnet. We did not expose Kubernetes API to outside. Okay. This is about infrastructure creation. Then we worked on the Docker files. While working on the Docker file, we used multi-stage build, another security best practice. We ran the containers as non-root users. Then in the Docker Compose as well, we took care of the secrets, right? And then when we were dealing with Kubernetes manifests, we used network policies for security best practice and to make sure DB is not compromised with any other external access. Similarly, backend as well. Yeah, so these are some things that we took care till now. The final thing is CI/CD pipeline. And usually in CI/CD, you can do a lot of things in the CI/CD pipeline, the DevSecOps practices. Let me first tell you what are the things that we're going to consider. Okay, even before writing the CI/CD pipeline. The first thing, when it comes to GitHub action, when it comes to this pipeline, we are going to use GitHub Actions. Why? GitHub Actions is very, very popular. It is gaining a lot of significance, and especially for public projects, this is the go-to solution. If you're hosting your repository in GitHub, I would say just go with GitHub Actions. It can be GitHub Enterprise or any kind of GitHub installation. Then within the GitHub Actions, we will use multiple stages in our pipeline today. We will start with the basic linting check. Linting check is basically like checking the semantics, syntax related things, verifying if there are any additional spaces or any basic security failures. Then we will look at, then we have a stage called SCA, Software Composition Analysis. This will verify if the dependencies that you used in the application build process, any of the dependency, if it is vulnerable, if there is any CVE attached to it, or if there is any security threat with respect to the dependency version that you used. It can be dependency related to your front end, back end, everything will be covered. After software composition analysis, we will look into another stage where we will build the Docker image. And during the Docker image build stage, we will create the images for front end as well as images for the back end. Once the image is created, we will perform image scanning, where we will go with Trivy, another security best practice. And once this is done, we'll also perform linting on the Docker file, because in the Docker file, you can go with a lot of security inefficiencies, or you can do issues with respect to Docker, not best practices, right? And then I'll use another thing called Checkov. Checkov is for security scanning of the manifests. If you followed our DevSecOps 0 to Hero playlist, all of them are already covered. I'm just taking that extra effort in this end-to-end CI/CD pipeline to cover all the steps in one place. We covered Checkov in our DevSecOps 0 to Hero. We covered image scanning. We covered SCA. We covered linting. But anyways, what Checkov does, it performs security scanning on the DevOps manifests. For example, the Kubernetes manifests, the Terraform manifests. But Abhishek, what can be issues with the manifests? I'll give you a simple example. Let's say using Terraform, you create an S3 bucket. Maybe because you are new to Terraform, you copied the manifest from somewhere. You are creating S3 bucket, but eventually the S3 bucket will be public because of the configuration that you used. Now, if you create this S3 bucket in production, and if you have some information in the S3 bucket, because of your lack of experience, the bucket is public, it is exposed to the hackers. Who can prevent this? Checkov can prevent this. So Checkov will scan your Terraform manifest. It will say, hey, your Terraform manifests are good, but they are not very secure. If you execute them, it will create resources that are not secure. Similarly, it can go through Kubernetes manifests as well. Maybe used latest tag for the image. It will say, hey, latest tag is not good. Go with a particular version. Or maybe you used health check where you did not follow a particular standard. This is where Checkov comes into picture. And then we will update the Kubernetes manifest file. So we created a Kubernetes manifest file, right? When the Docker image is complete and when all of these steps are complete, the Kubernetes manifest should be updated with the new image that is created, right? Developer created a pull request, all these steps are executed, or developer created a commit, all these steps are executed. Obviously, a new version of the Docker image is created. You have to make sure the image is updated in the K8s manifest, and then commit the K8s manifest back. This is what we are going to look at using GitHub Actions. Cool. So let's go step by step. There are close to 10 to 11 jobs in the CI/CD pipeline that we are going to write, but that's okay. I already have the workflows here. I'll just delete it for you so that I'll do it from the scratch. Okay. Create a folder called .github. This is the first thing that you do. Within the .github, create a folder called workflows. Okay, let me do it. New folder, workflows, and within this, you can put anything as the name of your workflow file. I'll just call it as ci.yaml, or you can say cicd.yaml, or you can say anything else as well. Cool. What is the first thing that you write in the CI/CD file, GitHub Actions file, start with the name of the workflow. I'll just call it as Journey DevSecOps Workflow. Cool. Now, on which action the CI/CD should be executed? I'll say execute it on the push action on all the branches in the repository. Okay. If you only want the CI file to execute on a particular branch, you can decide that as well. But I'm saying on all the branches. And then I will say execute it on the pull request as well. And again, pull request on any branch. Branches, colon, star. Good. Okay, this is perfect. Even if someone copies this CI/CD pipeline, because you used star as the branch, it will work for them. Next thing. So the next thing is to define the environment variables. If you're using any environment variable within the GitHub Actions, this is the right place to define it. What I'm going to do, instead of using the Docker registry, see, when we created the Docker compose file, when we created the Docker images through it, even through the Docker file, we got the images locally, we tagged them, and we pushed them to the Docker registry. But in real time, when you work in your company, you might not use the Docker registry. What you might use? You might use GHCR, GitHub Container Registry. So it is a best practice. Any image that is created through CI/CD pipeline, we will also use GitHub Actions Container Registry. For that, you just have to provide 3 variables here. One, name of the Docker registry, ghcr.io, just like docker.io. Name of the backend image, ghcr.io, followed by GitHub repository name. So what will this turn to? ghcr.io, followed by journey, which is the name of my repository, followed by journey backend. So in this particular location, the backend image will be stored in the GitHub records. Similarly, this is a repository for my front-end image. Cool. So we defined these environment variables. Now the actual thing, jobs. Each thing that we discussed here is basically a job. Linting is a job, SCA is a job, build is a job, scanning, again linting of the manifest files, Checkov, update, commit, everything is a job. So you have to define the jobs field in YAML, and you can start with stage 1. You can use something like this to say, now for easy identification, you can use a comment and say, I'm starting with the first stage, that is the lint stage. Basically, when it comes to GitHub Actions, just like Docker compose file, there is a specific syntax that you will follow. You might write 10, you might write 15, you might write 20, but you will follow this step where the first thing that you do, let's say we are dealing with the linting job, you will provide the name of the job, anything. Then you will say, what is the runner for this? In GitHub Actions, you have 2 things, right? One is self-hosted runner and one is the runner that you can bring, personal runner. Okay. So if you are using the self-hosted runner, the hosted runner and the self-hosted runner. Hosted runner, let's say you want to go with the GitHub hosted one, you can say Ubuntu latest. So it will spin up a runner for you. And this linting job will run on this virtual machine. You don't have to create it. You just have to say what is the operating system that you need or distribution that you need. And then if you want to continue this job on error, no, in our case, we have 10 different jobs, right? Do you want to fail the entire CI/CD pipeline if this job is failure, or do you want to continue? I want to continue because I know my CI/CD pipeline will fail. So I'll just say continue on error as true. Okay. So this will pass. This will not pass the particular job, but it will move to the next step. And then start with the steps. That's it. So these 3 are common for all the 11 jobs that we are going to create today. And within the steps, we have the order of the steps to follow. For example, to perform linting, I'll just say what is the name of the step, and I will use a GitHub action uses the checkout action. So checkout action will check out the code for us. Then next step, I will set up again. Every time you create a step, provide a name for it and use the GitHub action. You don't have to write the code. There are hundreds of GitHub actions out there. For example, to set up Node.js, you can use this GitHub action action/setup-node. This will install Node.js on the virtual machine. So this will check out the code. This will install Node.js. Then we will install dependencies, right? And finally, we will run the linting check. Okay, let's put this in action. So first for linting, this is how we are going to write. Okay, so these are the things. Paste it. So linting, name of it, lint code, runs on Ubuntu latest. Strategy matrix for component backend and frontend. That means execute the same thing 2 times. One is within the backend folder and one is within the frontend. I mean for frontend as well as the backend application. What do you need to execute? Within the steps you define that. Check out the code, set up the Node.js, and once the Node.js is set up, install the dependencies and run the linting. Okay, my bad. So here I'll just say install the dependencies and run linting. That's it. This is the first job. Similarly, we'll proceed with the second job. So the second job is to verify software composition analysis to verify if there are any dependency issues. For that, this is the job. Okay, let's take some spaces and this is the one. I'll walk you through them. SCA. So I'm saying name of the software composition testing as dependency audit. Runs on Ubuntu latest. Needs linting. That means only execute this step after this one. I'm just defining the order. Okay. So this will be the first one that is executed. This will be the next one that will be executed. In the strategy, again, frontend and backend, because we have 2 microservices in the same repository. Instead of writing the same states 2 times, we are saying for frontend and for backend. And this is a folder name for frontend. This is the folder name for backend. This will be replaced here. Once for frontend package.json, once for backend package.json. Okay, so check out the code, set up Node.js, install the dependencies, and perform the auditing on the dependencies. Okay, perform auditing on front-end dependencies and back-end dependencies. How will you do it? Using the npm audit command. If you are using Python, you can use pip audit, right? If you are using Java, you can use a different command. If you are using Go, you just have to change the command. That's it. Okay, next thing, the building of the Docker images. To build the Docker images, these are the steps that we're going to follow. Let me quickly put them here and explain it to you. Because this is huge, if I have to write it, this will take a lot of time. In fact, this might take up to 3 to 4 hours. So instead of that, I'll walk you through the steps. First thing, build is the name of the job. Again, runs on Ubuntu, needs SCA. So I'm defining the order of the jobs to execute. Matrix, front end as well as the back end. So front end Docker file and back end Docker file. 2 times this will be executed. Check out the code. Set up Docker on the virtual machine. I mean, install Docker. Then log into the GitHub container registry, just like how we do Docker login. Then run the Docker image. Basically create the Docker image, and this should be the name of the Docker image. If the matrix is being executed for frontend, the name of the image would be ghcr.io frontend journey frontend. This will be the name of the image. If these steps are executed for backend, ghcr.io journey followed by journey backend. Okay, cool. And then we are just pushing the images to the ghcr.io. Again, for both of the things, front end as well as the back end. Once the Docker images is complete, we have to scan the Docker image, for which we will use Trivy. And these are the steps for Trivy image scanning. Not only Trivy, there are multiple options that you can follow, but Trivy is very, very popular. So the name of the job is image scan, where we are choosing a runner. For every job, you have to choose a runner. Okay. Every time you create a job, you have to go with a runner. This time the runner name is again Ubuntu latest. Steps, check out the code. You must be seeing something. The steps are quite repetitive. Every time we are checking the code, every time, we are following the same things like choosing a runner, continuous on error. Yeah, that's what GitHub Actions is all about. That's why I say, if you practice 2 to 3 GitHub Actions on 2 to 3 applications, your job is done. You will never forget the GitHub Actions again, at least the structure. And this time we are using Trivy. So this is the action for Trivy, where we just have to provide the image name, journey frontend, journey backend, and it will perform the scanning. And it will tell you if there are any critical issues, if there are any high severity issues on the image that we created. Okay. Then once the image scanning is done, we will perform security scanning on the manifest. As I told you, using Checkov, you can scan Kubernetes manifest, you can scan Terraform manifest. That is what we are going to do. IAC security scan is the name of it. Ubuntu latest. Check out the source code in the first step. Then install Checkov on the virtual machine using this action, Checkov action. And we are providing the location of the directory. First perform on the Terraform directory. Run the Checkov command on the Terraform manifest and let us know if there are any issues. Then run the Checkov on the Kubernetes manifest within the K8s folder and let us know if there are any issues. Okay. Finally, we'll perform Docker linting before we execute the update Kubernetes manifest. What are we going to do in Docker linting? Just like source code linting, we are going to verify if there is any obvious issues in the Docker file. Right? Finally, updating the Kubernetes manifest. Because a new Docker image is created on the developer's pull request, this is what we are going to do. Update K8s manifest. For the K8s manifest, every time the image is created, what we will do, we will head to the journey.yaml. We will replace the name of the image here from Abhishek.FI journey frontend, which is currently the name, right? On the repository, this is a current name, Abhishek.FI journey frontend. What we will do, on every action, we will replace the name from Abhishek.FI journey backend to the new image ghcr.io frontend followed by journey frontend and the GitHub commit ID, right? So that every time a new image is created, that is what the script here is doing. I have the script in the GitHub repository. It's basic SCD commands, right? So you can go through the SCD command and understand what I'm doing. So this is the SCD command that is taking the action. Cool. Now let's verify. What I'll do is on the DevOps branch, I will push a dummy commit and I will show you how a new image is being created. And we will also see what are the security vulnerabilities on this application, which we'll identify through DevSecOps pipeline, and also security vulnerabilities in the infrastructure manifests. So all these steps will be executed. All of these actions will be executed on a single commit, and they will tell you if there are any security issues, and also it will update the Kubernetes manifest with the latest image. Perfect. So let's push a dummy change here to the DevOps branch. I will pick up the README file and let's add at the end of the manifest a simple white space. In your case also you can do the same thing, but on your repository. You cannot try it on my repository. Or let me just remove this line. Okay, go back and commit changes. Okay, so the changes are committed. Now the CI/CD pipeline should be automatically triggered. It's just taking some time to refresh, but the commit should be done by now. I don't know, there is some bug in the UI. There was an error. File could not be edited. Let's see why. Okay, I'll do it again. I'll go back, refresh, and okay, I think the issue is with GitHub itself. GitHub is not responding well. Let's try again. In one of the files, go back to journey, go back to readme.yaml, sorry, readme.md, edit, and let me update the last line here. Oh, in fact, the commit was successful, is it? No. Okay, remove this line, delete the white spaces, and go up, commit. Let's see. Okay, instantly CI/CD pipeline is triggered. We committed to DevOps branch, so the changes are triggered on the DevOps. I'm keeping the main absolutely clean for you so that you will look at the main branch. It will not have any DevOps manifest for you. You have to work on it from the scratch. If you have any questions, you can refer to the DevOps branch or you can refer to the video. Okay, so here CI/CD pipeline must be in progress. Let's refresh and see. Let's go to the commits. So this is the one that we committed. Remove personal node from readme.md. You can see the 12 jobs are executed. 2 of them are still running, but out of these 12, 2 have already failed and other things have successfully passed. Let's see what failed and what passed so that we get a very clear picture, right? So what all things passed? The first thing that passed is the dependency audit on the front end. So the dependencies that we are using for front end in the package.json, it is saying you are all using the good version. Even for backend, what we used in the package.json, what developer used is absolutely fine. Then in the front end application, linting is good. In the Docker file also linting is good. Update Kubernetes manifest. So it is saying the Kubernetes manifest file is updated with the new version of the image. Let's see that. But what failed? IAC security scan failed. So it is saying there is some issue with the, I think it failed for Terraform. Let's see. And even Docker lint has failed. Let's see why Docker lint failed. So it says, see, there you go. I explained this even during writing the Docker file. This will fail. So it says APK add package, the one that you used in the backend Docker file. Okay, you did not provide the version. This is what I was talking about. Okay, I'll go to this one and explain you. In the backend Docker file, if you remember, I said at this point of time, when you're using APK add dump init, you ideally have to pin it to a version. If not, you are doing a security issue. Tomorrow, by default, this is going to latest, right? If you're not providing anything. So today the latest can be something, tomorrow the latest can be other thing. So every time the Docker image for backend is built, it is different. So there can be a security issue. Today it is fine, tomorrow it can be not good. So that is what the CA also complained here. It said you have to go ahead and fix it. And what else failed? Okay, this is one security failure. And apart from that, another security failure is for Docker linting. Let's see IAC security scan as well. I think we just checked about the Docker linting. Now this is about IAC security scan, where it said, okay, in the Terraform that you used, it did not complain about one mistake. It complained about several mistakes in the Terraform manifest. Assertion error, config parser. We used a list where it is saying you have to go with the string. For which one? If you scroll up, you can find exact reference as well, where exactly it failed. Cool. So this is for Terraform manifest. The Checkov failed. Then what else? The image scanning failed for backend as well as front end. The one that we already expected. Why? We have been using outdated versions in the Docker file. Just to show you, it was an intentional decision. I used Node 20, the image which is vulnerable in the Docker files, both the front end as well as the back end. Node 20 Alpine, Node 20 Alpine. That's why it said, hey, the Trivi said, hey, you are using old versions, so your application is vulnerable to security. So these are the four pipelines, four jobs that failed, and rest of all are successful. Now it is up to you, and it is up to your development team. If someone creates a pull request, do you want to merge, or do you want to ask the developer or DevOps engineer to go back and fix it? Every time someone creates a pull request, this is going to be executed. Of course, here I directly created a commit, but in general, nobody creates a direct commit to the main branch. They would create a pull request. So on the pull request, you will see these things passed, these things failed. Now it is up to you. Do you want to accept or do you want to fail? In fact, if you don't want these jobs to be executed, if you don't want Kubernetes manifest to be updated, you want Kubernetes manifest to be updated with the latest version only if all the other stages are successful, then what you can do, just go back to your GitHub actions, go back to the CI and remove this line here. For now, we said continue on error true on all the things, remove continue on error true, and you will notice the failures will stop the further execution. This is also a good practice. This is also a DevSecOps practice where only run the stages if the previous steps are successful. Only run the Docker build if the security scanning and Docker linting is complete. Only update the Kubernetes manifest if rest of the stages are good. Let's do the final check. We will go to the source code. I can actually see it from here itself. Because the pipeline execution is complete, the Kubernetes manifest is updated with the latest version, and in fact it committed to the repository as well. See the commit. So previously this was the commit ghcr.io, this was the image name. Now it is updated to the latest image name 4757747. What is it? This is the commit ID. So the new Kubernetes version is tagged with this commit ID. If you rerun this, again a commit will be created, but the new commit, the new image will have a different commit ID. You can verify that. Now change something again. Maybe you can update the README file one more time. You will see one more time in the DevOps branch. You have to make change in the DevOps branch, right? Update the README file. You will notice the Kubernetes manifest file will be updated, and from the ghcr.io, the one that we have right now, image. Okay, from this one, everything will remain the same. Only this tag will be updated. This will be updated with the commit ID. Why? That's what we wrote in the GitHub Actions script. In the last lines of the GitHub Actions, that is exactly what we wrote. And this script will remain the same. You might be using Python application, you might be using Java application, anything that you want to, this will remain the same. Perfect. So this is about end-to-end DevSecOps. Now, if you want to complete this, like Abhishek, I want to deploy every latest version onto the Kubernetes cluster, you can also do it. What you will do, just head to the ArgoCD documentation. So ArgoCD docs. ArgoCD is well integrated with GitHub. So every time there is a new commit, ArgoCD can automatically identify the commit and deploy that to your Kubernetes cluster. For that, just install ArgoCD on the Kubernetes cluster. So what it is doing, I'll explain you that part as well. So GitHub Actions is creating a new image and it is updating the new image in the K8's manifest folder. ArgoCD can read it and ArgoCD can read it, and what it can do, it can pick up the new Kubernetes manifest version and deploy it to your Kubernetes cluster. This is the capability of ArgoCD. So you can build an end-to-end CI/CD process. CI is implemented by GitHub Actions. CD is implemented by ArgoCD. What is the bridge between CI and CD? The shell script that we wrote in the last lines of our GitHub Actions file. So this is acting as a bridge. Once all the stages of CI are complete, the shell script is updating the Kubernetes manifest with the latest version. ArgoCD looks at that GitHub repository. It will look at the commit like this. So it will keep looking at this file. It will see if the image is updated. Okay, it identified an image change. It will deploy the new images onto the Kubernetes cluster. Right? In our case, onto the EKS cluster. I can show you that as well. So now ArgoCD is installed. If you just do kubectl get all -n ArgoCD, you will find all the resources that are created in the ArgoCD namespace. There will be a bunch of resources, but what you should be interested in, the first one, kubectl get secrets -n ArgoCD. You will have something called ArgoCD initial admin secret. Just fetch the ArgoCD secret from here because you want to connect to ArgoCD. kubectl edit secret, name of the secret -n ArgoCD. This is in the base64 encoded format. Copy it. I'll close it here and run kubectl or directly also echo pipe base64 -- decode. Great. So this is the password. Now how to connect to ArgoCD? kubectl get svc -n ArgoCD. So this is the ArgoCD server. kubectl port forward svc ArgoCD server. Choose a random port again. We'll this time go with 7111 :80 is the service port of ArgoCD -n ArgoCD -- address 0.0.0.0. Now we will copy the password here. Okay, go back, localhost :7111. Oh, my bad. I added one extra one. Now, why are we doing kubectl port forward all the time? Because we are using a free, not free, but we are using an EKS cluster on AWS free tier. If you keep using load balancer or if you keep using ingress, it will incur a lot of cost for you. Instead, kubectl is free of cost. That's why we are going with it. But otherwise, in real time, you have to create an ingress or you have to create gateway API for it. Admin is the username and this is the password, the one that we got from the terminal. Now setting up ArgoCD is a cakewalk. Just create a new application. Okay, I'll call this as journey application. Name of the project is default. Sync policy is automatic. When you say sync policy is automatic, it will start looking for a repository. Which repository it should look for? This is a repo. Okay, copy. I'll paste it here, repository URL. Which path it has to look for? It has to look for the K8s path. Which branch it has to look for? I will say just look for DevOps branch. Okay, because CI/CD is updating DevOps branch. Cluster URL, go with the local host. ArgoCD is installed on EKS cluster. I'm saying just update the same cluster. Namespace, let's say the journey namespace. Perfect. This is all. Just click on the create button. ArgoCD will automatically sync. It will start deploying all the resources that are in the K8s file. And now if you make a simple change, okay. So right now in the DevOps branch, in the K8s folder, in the journey.yaml, let's see what is the version. Image : okay. Right now the image version is 47577. Okay, it starts with 47577. Let's make a simple change. Let's see if our end-to-end DevSecOps CI/CD pipeline process is working as expected. I'll add an empty space, commit changes, commit. Okay. Now automatically CI/CD pipeline should run on the DevOps branch, which is running. It should automatically run all the stages. It should update the Kubernetes manifest, and ArgoCD should deploy it to the cluster because we enabled automatic sync. But you have to note one thing. It will take 3 minutes of time. The default automatic sync time is 180 seconds. So once the GitHub commit is done, you have to be patient for up to 180 seconds. Okay. Sometimes it might happen pretty fast for you, but otherwise you have to wait for 180 seconds. I waited for 2 to 3 minutes. Now the pipeline is complete in the K8s folder. If you look at image tag, it would not be 7 something like that. Now it is 75DA 1DA, and ArgoCD, it is already progressing the change. You can see it is creating a new replica set, and it is updating the pod version for backend as well as the front end, right? So this is how end-to-end CI/CD works in the DevSecOps practice. We not only looked at end-to-end CI/CD, but we looked at end-to-end project from DevSecOps point of view. Before I conclude this video, I just want to tell you, at the very first sight, this might look overwhelming to you because I covered everything in one video. Ideally, this should be a playlist where I have to take each and every step, and I have to cover each and every step as part of an individual lecture. That's what we did in our Udemy project, right? If you look at my Udemy DevOps project, I took even more complicated project and I explained the same things for 14 hours because I had to go through each and every step and explain it for you. This time we did it in one single lecture. We did it for DevSecOps from security focus. So at the initial site, this might be overwhelming. Please watch the video again if you're stuck at some point, or start looking at the GitHub repository and start implementing on your site. Thank you so much for watching today's video. If possible, please share it with others because videos like this deserves an appreciation. See you all in the next video. Take care.